pocket so we don't confuse anyone. Yeah,
Oh, sure.
I'm not going to do a whole thing because I don't want to confuse everyone. But if you want to know that this is here. have your notes right here. The one underneath it has the actual notes if you want to say that, but this one is just plain.
Okay, cool.
Okay.
Thank you.
Of course.
Good morning, everybody. Welcome to the 11th annual CSP Symposium. I'm Corey Gabriel. I'm the executive director of the program. Very excited to be here today. We have an incredible agenda, and that's a credit to an incredible group that's worked really, really hard this year. And one takeaway I'm confident you'll have is it's incredible how much was accomplished in such a short period of time. The intentional effort to do good and put community first in this group is really second to none. For example, we have somebody in this group who worked in disaster response, and the community that I've known in that space are so kind and responsive and played an important role in keeping me connected to science when Hurricane Sandy impacted my community in 2012 during my first year as a PhD student, to people who have worked in the Environmental Protection Agency with indigenous people, to people coming right out of college who have aptitude and experience using sophisticated tools that are going to make their career productivities absolutely just dazzle the people who had the honor of educating them. So it's an exceptional group, and I also think it's an exceptional time, and I'm not gonna start with or speak about a sense of doom with respect to climate change, because that's not what I feel. I often talk about a city, town called Denora, Pennsylvania, and an event that happened there in 1948. If anybody in here is a big football fan, there's some pretty prominent NFL quarterbacks who have come from the hills outside of Pittsburgh. Joe Montana, Joe Namath. Even if you're a football fan whose football prime occurred in between 1968 and 1989, you haven't watched a game since, you've seen the products of those communities. So Pittsburgh in the 1940s, known for heavy industry, important part of America, right? Obviously, just through World War II, our industrial capacity is kind of what got us through it to a large extent, in addition to a lot of other things. But 1948, October, it's warm, it's sunny, there's a southwest wind across most of the east coast of the United States, but the topography in western Pennsylvania is complex, and heavy industry often needs to be at low elevation near rivers and concentrated in very specific areas so that people can get to work, and so that that stuff that's produced, the steel and all of that value added, can be sent efficiently around the country to build civilization. Unfortunately, these warm southwest winds, they don't really get into the valleys because of this thing called an atmospheric inversion that'll set up, and it'll stay cold in the valley, and if you pollute in the valley, all that nasty stuff will stay in the valley. So we're at a Friday in October 1948. Dewey is about to lose to Truman, and there's about to be a big football game in Denora, Pennsylvania, and people show up to this football game. It's cold and it's dark, and people start getting very, 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 very sick at the game very suddenly. And hours, days later, this becomes one of the worst environmental disasters in the history of this country. People literally dying in a fire station, a makeshift trauma center, turned into a makeshift morgue. 20, 30 people die immediately, long-term indications of blood cancers, of immune disease, immune system dysfunction in that area. And the proximate and actual cause was a smelting plant that had been operating there without any regulation for a long time. The citizens knew it was a problem and couldn't really do much about it. But this discrete, terrible event served as a call to action. The citizens of this town said, we're not going to take it anymore. We're going to demand accountability and environmental action. And over the period of the next 12 years, Pennsylvania adopted the first ever environmental protection legislation, environmental protection agency in the country. In 1969 and 1970, Richard Nixon, Republican president, signed into effect and set up the EPA and agencies that enabled regulation of water and things like that. And it has been 35, 40, 50 years of successful governance of agencies like the EPA, and a full-out assault by Donald Trump right now trying to reverse ozone regulations, reverse air quality regulations, not enforce stuff. That requires the acquiescence of Congress, and that required the acquiescence and basically the compulsion of and the misappointment of a large part of the judiciary. And we have midterm elections coming up very, very soon. And if the other party does win those elections, there will be hearings. There will be some level of accountability, and agencies will continue to function. And more importantly than the governance is what's happening on the ground. States that are so-called red states are adopting wind and solar very fast because people can put up solar panels, developers can put up wind farms, and that can put energy on the grid that takes the Strait of Hormuz, takes international geopolitics to some extent. Remember, the components do come from all over the world, right? There are supply chain vulnerabilities, but solar and wind plus batteries, that's what's powering our grid right now, right? If you were to look up the California ISO, Independent System Operators website right now, maybe wait 3 hours, please, you will see that we'll probably be operating on 100% renewable. And during that 4 to 9 power downtime in California, we're not supposed to use as much power, we're discharging batteries to cover a lot of that and not importing as much natural gas as we used to. And this is all really good stuff. And the reason this is happening, and this isn't just in the United States, massive adoption of solar in Pakistan, massive adoption of wind in Europe. There's massive, massive adoption of renewable for energy security purposes, and this sort of thing is making it so it's not the low-cost, easy alternative necessarily to burn coal going into the future, but renewables are going to be a big, big chunk of our energy economy in the future. And because of that, our trajectory for future emissions might be a little bit lower than what some of the worst case scenarios have envisioned. And the reason that this happened, I think it's because the public became aware and engaged that climate change was a problem and elected policymakers that put policies in place that incentivized the public sector and the sort of cooperations that made renewable energy adoption more powerful. What hasn't happened is there has not been a robust movement to make this country more equal. The maldistribution of resources, education, income, fairness, opportunity, that maldistribution, that deformation of society has not gone anywhere. And that inequality, the structural inequality and the everyday inequality that people experience in this country and that serves as a barrier to keep people from the middle class, lower economic classes, immigrants, people who have had challenges in life from reaching 100% of their potential, those barriers are not being eroded as quickly as maybe they could. So I think the real things that we're seeing right now is substantial progress on the energy front, remarkable people in this climate space, and the next problem that we have to work on solving is a more equal society where everybody can have the opportunity to be in this room and do this kind of amazing work that you're about to see. So I want to stay on track, but I want to thank this amazing group who's given me an amazing year and given me so much hope and gratitude and the immense satisfaction and the realization of their amazing work. I can't tell you how much that has meant. And without further ado, I'm going to introduce our first speaker, Gail Bova, and her work started with an idea that she she vetted to me during the summer, just several weeks into the program, about doing something really cool in San Diego Bay, a graduate of The Ohio State University, an amazing factory of wide receivers, linebackers, and pretty much everything else that plays in the NFL. And her project is entitled Assessing the Impacts of Inorganic Pollutants on Cultivation of Ulva app in San Diego Bay. Gail, the floor is yours.
Thank you, Corey. Sorry I was never a big enough football fan to be able to talk about wide receivers with you. Awesome. Well, good morning, everybody. As Corey mentioned, my name is Abigail or Gail Bova, and today I'm going to be talking to you about seaweed, specifically a green seaweed, scientifically known as ulva, commonly known as sea lettuce, and the impacts of inorganic pollutants on its cultivation in San Diego Bay. Before I begin, I would like to take a moment to thank my amazing committee members and the California Sea Grant Aquaculture team here at Scripps for their guidance and assistance throughout this project. I would also like to thank the teams at Sunken Seaweed, SDSU's Coastal and Marine Institute Laboratory, and Dr. Kim Prather and the Prather Lab for allowing us both access to their facilities and utilization of their equipment throughout this experiment. And finally, of course, my family, friends, the CSP leadership, and the 2026 cohort for all of your love and support throughout this project. Coming into this study, our goal was to answer the following questions. Will ulva uptake inorganic pollutants such as heavy metals when grown in San Diego Bay? If so, what pollutants, at what concentrations, and what are some of the possible implications for meeting food safety standards? And in the event that the answer to question 1 is yes, can metal concentrations be reduced through depuration, a purification process that I will define in the coming presentation? Before we get into the science, a little bit about the ethos for this project. You may be wondering, why study aquaculture in the context of climate change? Aquaculture has become an increasingly popular area of study for climate mitigation and adaptation strategies, including but not limited to combating ocean acidification, CO2 capture, bioremediation of pollutants, and commercial outcomes such as addressing the global food crisis and product replacement in high petroleum industries. We chose to focus on the impact of inorganic pollutants as it feeds into some of those other sectors. Inorganic pollution uptake not only addresses the question of possible bioremediation of polluted waters, but also how this biomass can be used down the lines in terms of determining consumptive and non-consumptive commercial pathways. For those unfamiliar with San Diego Bay is a crescent-shaped estuary fed by 3 main tributaries, in this case rivers. These rivers are impacted by the land area highlighted in yellow, red, and green, making up the extent of what is known as the San Diego Bay watershed. The San Diego Bay watershed is highly urbanized, and the bay and its shorelines have a long history of supporting military and maritime operations. So why San Diego Bay? Policy support from the Port of San Diego, which holds jurisdictional authority over San Diego Bay, is not only making aquaculture possible in San Diego, but also emphasizing the importance of sustainability in aquaculture practices. Additionally, it is no secret that San Diego faces pollution challenges. Inorganic, non-dissolvable pollutants such as trace heavy metals have accumulated in the bay from a long history of military and maritime industry, consistent rapid population growth, and the improper disposal of largely untreated wastewater up until the 60s. While policy changes and large-scale cleanup efforts have greatly improved conditions, we still see concerning amounts of pollution in San Diego Bay. In 2024, the San Diego Regional Water Quality Control Board released their San Diego Bay sediment evaluation, identifying cadmium, lead, copper, and zinc as pollutants of concern in terms of heavy metals. The first portion of our study aims to answer the question, will the ulva uptake organic pollutants? Our team outplanted just under 2 kilos of ulva grown here at Scripps across 20 oyster baskets at the Sunken Seaweed Farm located off of Grape Street Pier in downtown San Diego. As depicted in this diagram, the graph is comprised of a metal frame suspended about 1 meter below the surface to floating buoys, with 4 lines supporting the oyster baskets. 5 randomly selected baskets were pulled for sampling every 2 weeks, at which time the biomass of each basket was weighed for growth weight analysis. A 70-gram sample was removed from each basket to be dried for tissue analysis, and an additional 40-gram sample was removed to be placed in tumble culture for a depuration study that I will get into shortly. The second portion of our study aimed to answer the question, can metal concentrations be reduced through depuration? Depuration comes from the word depurate, meaning to free from impurities or heterogeneous matter. The process has been largely formalized within the shellfish industry to reduce the presence of pathogenic organisms using a controlled aquatic environment. Studies are limited on commercial applications in this process, using this process on seaweed, so we hope to begin to study that a bit more. For this study, the 40 grams of ulva referenced before was taken to SDSU's Coastal and Marine Institute Laboratory, or CMIL, where they were placed in tumble culture tanks pictured here. These tanks are set up with a continuous flow of seawater sourced from San Diego Bay and filtered by 2 large sand filters and protein fractionation to remove biological material. An air stone was used to provide adequate O2 levels and promote tumbling. Weight and total biomass and a sample for tissue analysis were taken at 2 time periods. The first, known as D1, at roughly 66 hours of exposure, chosen loosely based on the National Shellfish Sanitation Program's 44-hour depuration requirement. And the second, known as D2, at roughly 138 hours, based on the findings of Rivas et al.'s study on depuration of a red algae in Chile, which found peak depuration at 7 days. Based on the standards set by the National Shellfish Sanitation Program, we checked the boxes of providing continuous water flow, adequate aeration, but we did not test or treat the water to ensure consistent pH and temperature, or if it met sterile water standards. Finally, a quick overview of our sample analysis. All samples were dried at 60 degrees Celsius in an oven for 24 hours, and heavy metal analysis was completed utilizing an inductively coupled plasma mass spectrometer with the assistance of Toby Bloom, a PhD candidate and committee member on this project. So let's get into some results. Biomass and element concentration data was primarily analyzed in reference to time. These sample periods, as shown in the legend here, are T0, referencing the starting biomass, T1, referencing biomass samples collected at 2 weeks after owl planting, T2, representing samples collected 4 weeks after owl planting, T3 at 6 weeks, and T4 at 8 weeks. Starting off with growth rate trends, the blue bar represents T0, again the starting biomass of all of the baskets, and the subsequent color-coordinated bars represent the biomass of the various samples per sampling period, starting with T1 in green and ending with T4 in purple. After an initial positive growth rate in T1, there's a clear negative growth trend from T2 to T4. A few observable factors may have contributed to this trend. The first, as shown by the black line overlaid on the biomass data from our last graph, shows that there was a drastic increase in the water temperature, particularly over the course of T2 and T3. Current literature identifies water temperature increases as a stressor for ulva. Additionally, we saw a large amount of epiphytic fouling, very fun photos, on both the oyster baskets and the ulva blades themselves. We saw a spread of bryozoans, tunicates, and even some scallops and oysters, but the most prominent was a tunicate known as a sea squirt that covered many of the ulva blades. To answer the question on everyone's mind, none of the organisms absorbed as epiphytes are known to eat ulva. Rather, they are competitive for similar nutrients and potentially block sunlight from reaching the ulva's cells, reducing photosynthetic capability. Despite negative growth trends, we observed some really interesting data on inorganic pollution uptake. As previously described, sample biomass was analyzed to determine trace metal concentration and then graphed to analyze uptake relationships to exposure time. This slide highlights the observed elements that were labeled as pollutants of concern by the San Diego Regional Water Quality Control Board. A statistical analysis was performed using RStudio to determine statistical difference between groups and trends between concentration and time. Of the elements on this slide, all elements showed statistical significance between sampling groups except for copper. Additionally, copper showed no trend between concentration and time, highlighting the plateau-style trend that we see visually on the graph here. All remaining elements demonstrated moderate to very strong trends, And surprisingly, we did see a negative trend in cadmium, which I'm going to get into a little bit later. Aside from cadmium, the only other elements that resulted in negative trends were potassium and magnesium. Potassium and magnesium are both mobile cations from the alkali and alkaline earth metals group that are known to be desorbed via ion exchange in the biosorption process of heavy metals. So this was to be expected. Looking at the additional elements observed in this study, all elements showed statistical significance between sampling groups except for nickel. Similar to copper, nickel also showed a weak trend between concentration and time, while all other elements showed a strong positive trend. Concentrations were then scaled to milligram or microgram per gram for analysis against food safety standards based on total human intake in milligram or microgram per day. Concentration was scaled to a gram for easy scalability into future various applications, and food safety regulations were chosen for comparison due to the ability to complete a relatively simple comparison and the large-scale standardization across the country. Maximum thresholds came from California's Prop 65 standards, which apply to both children and adults, as well as the U.S. Department of Health's tolerable upper intake limits for adult men and women ages 19 to 50. The blue and orange dashed lines represent the U.S. DOH recommended daily intake for the same demographic to add a little bit of nutritional context. The age range was chosen by selecting the age range with the largest age range with the most common values. This could be applied to children's age ranges and everything else via a simple switch in the graphs. All other elements were analyzed using the same method, and the results showed that all concentrations were well below their respective toxicity levels, so I have focused on the pollutants of concern for this slide. As evidenced by the green shading, across all time periods, concentrations of elements remain below toxic and total daily recommended intake except for lead. Lead concentrations are governed by California's Prop 65 standards for both cancer and reproductive risk. While lead concentrations are below the threshold for cancer risk identified by the blue dashed line at the top of this graph, all samples surpass the threshold for reproductive risk, which sits at the bottom of the graph with a value of 0.5 micrograms per day. As described earlier, a depuration style study was conducted on all samples with sufficient biomass in order to understand the possibility of reducing element concentration. Each line on the graph shown is representative of the concentration of the respective element per basket over time. The first data point represents the concentration of the element when it was removed from the farm site. The second concentration at D1, i.e. 66 hours in tumble culture. And the third is representative of the concentration at D2, i.e. 138 hours in tumble culture. Tissue concentrations were reduced for all heavy metal elements except for cadmium and zinc. Based on water quality testing completed and provided by CMIL, we know that there are reportedly high levels of zinc in the water used for this study, which may have resulted in this trend. I hypothesize that we see a switch from cadmium desorption at the farm to sorption in tumble culture due to the varied concentrations of metals between the water at the farm site and the water source for CMIL systems. Additionally, as heavy metal concentrations decreased, we saw an increase in magnesium and potassium, signaling a possible reversal of the ion exchange observed at the farm. And finally, the question on everyone's minds, did we reach acceptable levels of lead concentration? It may not look like it at first, but when we zoom in, we can see that baskets 10, 14, and 1 all achieve a less than 0.5 microgram per day concentration within a range of their standard deviation by D2. All of these samples were collected during T1. The fourth sample from T1, represented by the orange line, had a comparatively lower rate of depuration at less than 50%, emphasizing the need for additional studies to better understand replicability. The samples from T4 in brown and T3 in purple saw significant depuration, over 50%, pointing to the need for additional studies to understand if a longer time frame could result in further depuration in order to better understand the limits and applications of this process. So to answer the questions posed at the beginning of this presentation, yes, we did observe uptake of inorganic pollutants grown in San Diego Bay. Based on the swath of elements analyzed, no additional pollutants of concern were identified in this study. In terms of concentration and implications for food safety standards, most elements are in the green and do not show concerns for food safety. However, lead and cadmium need to be closely monitored, with lead being the most concerning. Additionally, through our depuration study, we saw that yes, depuration of inorganic pollutants is possible. However, further studies on the standardization and optimization need to be explored. Now you can enjoy this lovely photo. These are Olva blades turned into heavy metal fans, as they were. Any questions? I've been waiting for this my whole life. Thank you.
We got a question over here. Sorry, we got to use the mic. Go on ahead.
Were you surprised by the outcomes, or was this kind of what you were expecting to find when you started the study?
I think like a lot of people, there's a lot of sensationalization around the pollution in San Diego Bay. So I was actually expecting to see higher rates. We did a full swath just because we could with the ICP-MS. And we were like, let's just see what's out there and see what else is going on besides the pollutants of concern that were mentioned. And I was actually surprised that it wasn't as much of a concern for other pollutants. The lead does make sense. So yes and no, yeah.
Gail, phenomenal presentation.
Thank you.
Thank you for all your hard work on this project. Question for you. What made you choose Ulva as the algae of choice, and do you expect your findings to carry over to other algae that could be used for human consumption?
Yeah, that's a great question. A few parts that go into why we chose Ulva. Part of that is permitting as a part of the SSAP, or the Shellfish and Aquaculture Assessment Plan. Oh my gosh, now I'm blanking on what that title goes for. Ulva has been identified as a species that can be grown in San Diego Bay based on just species range and things like that that say, yes, you can grow that here, it's not going to be invasive. So that's one part there. Ulva has also been widely studied for use in the treatment of wastewater. So it has been shown to be able to absorb a large combination of metals all at once. And then the third part there is the morphology. Most accumulation is happening just on the cell surface, where you have the cell walls that are actually just, it's positive and negative ion charges and exchanges going on. So because Ulva is a sheet, it has a high surface area to volume ratio, so there's a lot of room to accumulate things. There have been studies that have been done on different kinds of seaweeds. The morphology is going to change that. Also, the makeup of the cell wall is going to change that. There are some studies that say that red seaweeds are actually more efficient because of some of the chains that exist in their cell walls and just affinity for different heavy metals. So studying additional species is definitely something of interest as we move forward. Yeah. Mm-hmm. Any other questions, I guess? Yeah.
I don't know where the microphone is at, but I'll try to speak loud. Here you go. Thank you.
So before this program, I was actually working at a Prop 65 law firm, and we saw a lot of seaweed come in for lead and cadmium specifically. So based off of your findings, do you think that depuration is worth it for companies who are trying to grow this for food consumption? Or do you think that maybe the current policy is basically to slap a sticker, a warning, but it doesn't actually say the levels, which was always my problem with it, because one could be barely over and then one could be like 10 times over and you won't know the difference.
Yeah, absolutely. And that's a problem worldwide. So it is, if we open up to the rest of the world, there's a lot that we can pull from a lot of different countries that have more established systems looking specifically at algae. The Southeast Asian countries, as well as even Europe, has better systems than we do of just like starting to look specifically into algae, because it is such a concern, especially with heavy metals. In terms of depuration, I do think it's worth exploring. You can definitely see an increase in just like the quality of the seaweed in terms of reducing those heavy metals. And it would be interesting to see, can we get that to a lower level? But I agree, yeah, Prop 65 is a weird one, given that it's a sticker, it's not necessarily a limit. There are limits that are caps in other countries that might be a better parameter, and that could be a conversation around how we're addressing that nutritional issue. Because also, I mean, I don't know about everybody else, most of the time when I see that sticker, I'm like, oh yeah, they put that on everything. Like, it's okay. Like, it's whatever. It probably isn't the best way to go about things. But yeah, Prop 65 is definitely like a weird one there in terms of just how it operates. The current US system is just closer to zero. So that also doesn't give us a whole lot of guidance. But I definitely think it's worth exploring because we can see it happening. We can see a decrease in that lead, and better research on just actually how it impacts humans, and having a better cap on that for us as like a society, I think is where the focus really needs to be honest. Yeah.
All right, excellent job. Thank you so much, Gail. Very interesting topic. Our next presenter has really basically been everywhere in the world, but at his happiest, he's probably sporting a pair of binoculars, staring at birds in Hillsborough or Beaverton or some other suburb of Portland, or on a basketball court dominating. Alex Rubenstein with a project, Seabirds and Climate Change, examining the impacts of climate-driven environmental variables on Brandt's cormorants in Southern California. Alex, the floor is yours.
All right. Good morning. It's so good to see all of you. How are you? I want you to take a moment and close your eyes. Close your eyes for just a moment and imagine it's pitch dark. It's black, it's musty, it's warm, it's kind of smelly. Weeks go by as you start to hear all these unfamiliar sounds, the honking of cars, people talking and kids yelling, the fluttering of wings. After several weeks, a crack and a sliver of light starts to appear. As you open your eyes, you see the light peeking through the eggshell where you've been incubating for the last few weeks. Your parents have spent the last month building a nest, courting it with each other, and raising you and perhaps several other eggs. And congratulations, after about a week, your egg will hatch, and you will emerge as a baby Brandt's cormorant. Give yourself a round of applause. You are a disgusting, beautiful, featherless little hatchling chick of a Brandt's cormorant. Your parents, with their beautiful blue cobalt throats, have been searching offshore, diving and foraging on all sorts of fish to feed you. Look to the person to your left. Look to the person to your right. Say hello to the other 2 eggs in your nest. One or both of them are probably going to die by the end of the month. But you might survive. Over the past few weeks, as they've been courtship rituals with each other, you look around and you see other nests, other hatchling chicks making their way into downy stage chicks, nearly fledged, and eventually will start to leave their nest and wander around as they grow their feathers and their plumage to take off for a bigger world. You're a Brandt's cormorant. What are you? You're a colonial seabird and water bird, endemic to the coast of the Pacific coast, all the way up from Alaska down to coastal Mexico down here. You are a mostly resident bird, staying kind of in the same area, nesting year after year in the same habitats, in hard cliffs and islands and rocky ecosystems, foraging offshore in kelp forests and elsewhere for all sorts of fish. And you're really important. You're an indicator species of environmental and climate change. And for my project, I was really interested in looking at how are birds a reflection of climate change and our changing world, what kind of conservation measures and science communication can we do to improve our understanding and our appreciation for these birds. Now, if anybody here knows me, you know that I am chronically obsessed with birds. But I didn't used to always be like that, but you could say that there were some warning signs. Now, seabirds and birds in general are sentinels of environmental change. They are an amazing and immediate reflection of changes when things are amiss in our environment. They have incredible, important ecosystems and economic functions, as well as importance to our mental health. The bird economy is upwards of $300 billion industry. Birds are pollinators. They're seed dispersers that cycle nutrients and carbon in our environments. They act as pest control and carry on cleanup crew, helping decompose and prevent disease outbreaks. Seabird guano is also a really important source of nutrients, phosphorus and nitrogen, in healthy marine ecosystems like kelp forests and coral reef systems and mangrove forests and other ecosystems. But birds are suffering. Birds are suffering all across the world. In the last 50 years, North America has lost over 3 billion birds. Globally, in that same time, seabirds around the world have dropped 70%. And the legacy of human emissions and climate change and ocean warming and sea surface temperature and the disruptions to prey availability and habitat have devastated bird populations across the world. The legacy of marine heat waves and El Nino events that cause stratification in the ocean that push prey further down to colder waters make it harder for birds to find their prey and survive. Heat waves like El Nino events in 2015, 2016's of the blob, and recent El Nino events have killed hundreds of thousands and millions of birds around the world. The effects of human disturbance and pollution, overfishing, bycatch, have also contributed heavily to disturbance. For the area that I'm interested in, I wanted to take a look at a part of the Pacific Flyway, a really crucial migratory pathway for birds, known as the Southern California Bight. The Southern California Bight is a really important part of the California current ecosystem from Point Conception all the way down to partway down to the Baja California Peninsula. And it's filled with all sorts of interesting bathymetry and upwelling and islands and nesting colonies for cormorants, and including in San Diego. And in this area, I wanted to understand and explore what the impacts are of climate-driven environmental variables on cormorant abundance and mortality in the Southern California Bight. To do this, I used several data sets. The first data set I used is a citizen science tool called eBird. You can download it after this presentation. It is a citizen science app and website where you can make an account, and you go birding, and you check off all the birds that you observe and submit it to this database of billions of checklists from around the world. And it's used in science and research and understanding changes and shifts in distributions and abundance of bird species around the world. The other bird-based data set I used for mortality is a beachcombers program called Beachcombers with the Fish and Wildlife Service that performs monthly dead bird beach surveys all along the coast from San Diego up to Monterey Bay. There are 4 counties in Southern California that I use data from for this. The main environmental variables that I wanted to understand the relationship between was sea surface temperature and sea surface temperature anomalies, the Oceanic Nino Index, which measures El Nino and La Nina events, and atmospheric rivers. Atmospheric rivers are measured in integrated vapor transport and duration to get a monthly atmospheric river dose. And my connection here in the mechanism is the relationship between coastal precipitation and extreme precipitation events on potential runoff of pollution and pollutants that introduced terrestrial pathogens to marine life along the coast. So let's take a look at my study area. This is my study area along Southern California Bight that I split up into several different half-latitude transections, from 34.5 degrees north to 32.5. And within each of these half-latitude sections, I split up into different half-latitude by half-longitude grid cells. I used the Beachcombers data from Santa Barbara, Ventura, Los Angeles, and San Diego with different beach segments along the coast that do those volunteer-trained beach dead bird collection, and I've been able to participate in some of those volunteer efforts here in San Diego. The purple here is our marine protected areas. The blue diamonds are Brandt's cormorant nesting colonies along the coast, and you'll see here one of the only mainland colonies in La Jolla Cove right here. Within each of these grid cells, I was able to find monthly abundance, relative abundance of birds, monthly sea surface temperature anomalies and raw temperatures for each of those cells, and compare them to each other, as well as comparing these mortality data from the beachcomber surveys with local nearshore sea surface temperature variables. And from all this data, I made a lot of plots. I'm not going to get into any of these, except for this one. This is a plot. The top blue bars are measures of abundance, which is relative abundance, which is how many Brandt's cormorants are observed out of how many different checklists are submitted for a given area over time. And I was using monthly abundance turned into an annual average. And then in red, we have mortality. So these are dead birds per kilometer for every single year during my study period, which is from 2013 to 2025. These red shadow sections are El Nino events, strong El Nino events, and a La Nina event here, and these red bars on the bottom are marine heat wave events as well. This tells a really interesting story. This shows these really big rises and dips and rise and fall and rise again in abundance. And Brandt's cormorants are known as a boom or bust species. They do really well in cold years with high breeding success, and they tend to have lower breeding success in really warm years. And you see this trend, but it's kind of this one step forward, two step backs almost. You see also some interesting rises and falls of mortality events over time as well. I ran a lot of different tests. The main ecological test that I ran is a nonlinear analysis called a generalized additive model, or a GAM. And for this, I wanted to understand how and do sea surface temperature anomalies, oceanic Nino index information, atmospheric river dose, affect or predict Brandt's cormorant's abundance. And using this model, I found that these environmental variables explained about 39.8% of the deviance to a high significance for that test. I also ran a center of abundance test. Within each cell, I was looking at a month-by-month comparison of abundance and local sea surface temperature anomalies to understand is there a change in north to south or east to west movement and distribution of cormorants. And I did find with a high significance that as sea surface temperatures increase and anomalies increase, cormorants are more likely to move offshore westward, likely to perhaps look for other foraging opportunities when nearshore opportunities are affected by ocean stratification. There was no significant change in north to south distribution. I ran a bunch of tests with the local beachcombers data on local nearshore atmospheric river and sea surface temperature anomalies, and I won't get into the specifics of it all, but I did find that all 4 counties in different months of lag time, from 0 to 3 months after an anomaly, there was a significant correlation with increased mortality and sea surface temperature anomalies. My atmospheric river results were inconsistent, and as I continue this research for a scientific publication, I'm going to be looking at precipitation data as well, because atmospheric river doesn't guarantee that there's going to be precipitation. The next main big part of my research has been conducting in-person seabird and nest colony surveys in La Jolla Cove. La Jolla Cove is a really important environment in the ecosystem. It is a crucial habitat and stopover point for migrating seabirds all along the coast, and it provides cliff environments, beaches, islands, vegetation for all sorts of different species. It's also one of the only mainland Brandt's cormorant nesting colonies in the area. So to do this, I worked with a team of Leo and Haley, Leo Harris and Haley Pfeiffer, and Dr. Tammy Russell with the Vernay Lab, to lead teams of volunteer students from the UCSD Bird Club and conduct twice a month seabird surveys going from the children's pool all the way up to Goldfish Point, walking a couple hours every other week, early, sometimes too early in the morning for some of us, and counting all the individual birds of all the different species that we saw, just to understand what species and where and when throughout the year are using this habitat, what areas are most important. And this data also helps validate certain conservation measures, like the closure of Point La Jolla or the seasonal closure of Children's Pool Beach during the seal pupping season and the western gull nesting season. This was really, really fun. From this data, I made a couple of different plots. I'll share this one. This is over time, for each of these survey dates, every 2 weeks from October to May, the total count of all the different species that we observed during each of these surveys. And you see that there are so many, over 1,000, 2,000 birds in some cases, that rely and pass through this habitat. And now we were only counting birds on shore, on land. That doesn't account for all the birds that were foraging, depending on the different tidal conditions that we were surveying during. But you can see in blue how Brandt's cormorants need this area, and they're here throughout the winter during their breeding season. Pelicans are here throughout the year, really increasing in the last few weeks as they migrate north. Elegant terns had a huge spike a couple of weeks ago as they migrate north, and over 18 different species that we observed. In addition to this total abundance, we're interested in what parts of the cove are most important. This is a moving time lapse of each over time from February to March, starting from October, of the spatial distribution of Brandt's cormorants, going off of count, so 200, 400, kind of aligned with this section of the cove from the children's pool up to Goldfish Point. And you can see they're really using all the cliffs all along this area to rest and roost throughout the day, and also nest in our study area for the nest surveys. The nest surveys were some of the most fulfilling and exciting, rewarding parts of this research. Starting in early January, our team spotted the first eggs of a colony of over 70 different nests along the coast. We mapped out and labeled and numbered every single nest, and we went every single week for the last 5+ months, leading other students from the bird club, and kept track of how many eggs did they lay. Of those eggs, how many made it to a hatchling chick stage, downy chick, near-fledged, and then how many left the nest to be a successful fledge from that nest. From this, I was able to find that on average, our section of nests had about a little under 2.76 eggs per pair, which is well within the normal range. But their fledgling success rate was slightly lower than I was hoping. It's within a normal expected range, but it is on the lower end of 1.07 fledglings per active breeding pair. Now, younger Brandt's cormorants perform worse with breeding. Colony nests that are further away from the center on the edge also perform worse. And we don't have consistent annual data for this colony, so this is really important baseline data that we can hope to continue year after year going forward to understand how trends in ocean conditions and human disturbance and pollution and entanglement and bycatch are affecting the birds in this area and their survival rates. For me, none of this would have been complete without the importance of science communication and storytelling. I knew coming into this program that I wanted to use all sorts of different writing and visual communication to tell this story and tell people more about birds, and I was fortunately able to do just that. I've been able to volunteer this past year with the San Diego Bird Alliance's Conservation Committee, and was able to write an article for the upcoming quarterly edition of their magazine Sketches, highlighting and telling the story of our research in La Jolla Cove, which is a really important area for local tourism and habitat. I got interviewed by a local magazine and the newspaper about this research, and I've been working with our team with Dr. Tammy and Leslie Handa, Leo Harris, and Haley Pfeiffer to develop and design a seabird-focused interpretive sign in the Cove to kind of improve science communication. This has all been really exciting and really fulfilling. I have endless gratitude to Tammy Russell and Mark Merrifield, Leslie Handa and the San Diego Bird Alliance, and Andrew Meyer and Muriel Spooner. Special thanks to Leo and Haley, Connor Mack, Julie and Dan from Point Blue, and of course, Corey and Jada. And of course, all of you. You all have been so amazing throughout the year. It has been such a joy to be with all of you guys, and you inspire me every single day, from our baseball games to barbecues to holiday events and all sorts of adventures and activities throughout in between, and all of our boat rides together and beach sand sampling collection. And I hope you can continue to go forward and see all the birds you can, appreciate the birds that you can in your life and what they do for us and our mental health and our economy and environment and society, and find ways to contribute to citizen science and long-term data collection and conservation efforts to continue to protect bird habitat in our shared world. I wish you all a keep calm and bird on, and I welcome your questions. Thank you.
Hi, Alex. Thank you. Oh, do we have time for questions?
Let's do one more. Let's do one question.
Okay. Thank you so much for your presentation. I really enjoyed learning about your research. I live in the Cove, so I see these birds all the time, and I think this research was super fascinating. I had a question particularly about the super El Nino that everyone's predicting. How do you think that is going to affect these bird migration patterns?
How do I think this upcoming Super El Nino event will affect bird migration patterns? Probably not very good. It's probably going to continue to have pretty impactful effects on their food availability and prey distribution, and we'll probably can expect similar trends from past El Nino events, which include pretty severe unusual mortality rates.
Thank you.
Thank you.
All right. That was truly amazing. Thank you, Alex, and thank you for featuring your amazing cohort so prominently in the pictures and the presentation. Excellent presentation. Our next speaker is, I do this. This involves educating, and that's what I'm evaluated on, and how well I educate. And when I took this job, a lot of people were like, dude, you got to publish papers. That's how you remain relevant as a scientist. You got to just publish. And I was just like, okay. But the education, the connection with people, seeing that progress, and sometimes, this is a lot in 1 year, but sometimes there's students that you can both see learning in real time, and you can see how the problem sort of impacts them in real time, and then kind of see how they process climate change and work through climate change, and then how they work through like a 1 year program, and the way that they do it, and the kind of learning and the kind of interactions you have with that person. And this isn't just true for Lang, but I think Lang is the best example of that this year. All of that stuff about publish or perish and do this or that, it seems irrelevant, because just the satisfaction and of the interaction and seeing the other person learn and experience this issue for the first time, and also the connection that you develop with the person, and just the satisfaction you see in a project like this, I cannot describe how amazing this feels. So this is one of those moments where I'm like, okay, maybe I don't have 4,000 publications, but I have 135 MAS students, and a lot of them, fit this mold and set this tone very well. So our next presenter is just an amazing student in person, Lang Sarah. Watch your tone. The influence of voice on willingness to participate in climate action with a case study on coral bleaching. Lang, the floor is yours.
Thank you so much, Corey, for that very kind introduction. My name is Lang, and I'd like to start off just by thanking my advisory committee for their selfless dedication to this project. Dr. Stuart Sandin, Dr. Corey Gabriel, and the magical Miss Sophia Carter-Peters. I really could not have done this without you. So the title of this project, one more time, is Watch Your Tone, Influence of Voice on Willingness to Participate in Climate Action, with a case study on coral bleaching. I'd like to start off with some personal reasons as to why this project is important to me. I have found that the CSP program really emphasizes the importance of an interdisciplinary focus. And I'm very lucky to have been able to learn not only about climate science and policy, but also even a little bit about communication and psychology as well. Another passion of mine is the increase access to education. I hope that enforcement of this project is able to help address that issue on a large scale. And as for some bigger applications and motivations of this particular project, one of the inspirations I found to conduct this particular study is the fact that while almost every scientist believes in and knows that climate change not only exists, but is also an anthropogenic issue, fewer than 70% of Americans believe in climate change at all. And that is a deliberate problem. That gap in information is due to a formulation of communication that frames climate change as a polarized issue and makes it sort of a taboo topic. In order to talk about climate change, we need to remember to phrase it as access to natural resources such as clean air, water, food, even protection from storms. But framing this project as just access to these necessities of life is going to definitely inspire education and information. Unfortunately, that's not enough at this point. A solution to climate change requires action. And that's what this project is about. How can we talk about climate change to most effectively inspire climate action? I will be studying two main tones in this project: a more positive, solution-oriented, hope-inspiring tone, contrasted by what is historically relied upon in climate change and the communication thereof as a negative, problem-focused, sort of alarmist approach. Now, in order to study this impact of tone, I chose specifically to discuss coral reefs as an ecosystem, despite the fact that climate change is a global issue. And my focus on coral reefs can be boiled down to three main reasons. First of all, coral reefs are a very visibly affected ecosystem at the hands of climate change. Anyone can see a healthy coral and see compared to a bleached, broken coral and notice the visible differences therein. Because of that visibility, there's a lot of media coverage about coral reefs. And so the basic information that my audience group had going into this study was key to this project. Secondly, coral reefs are an invaluable ecosystem. They provide all sorts of resources, not just to humans, but also to the world as a whole. They are producers of oxygen, of fisheries, of protections from storms, and they provide financial benefits that are highly valuable. Anyone can find reason to protect coral reefs. And finally, coral reefs are a very vulnerable ecosystem. As Alex was talking about indicator species in birds, coral reefs are a sort of indicator species on a global level. This ecosystem is projected to all but go extinct within the next 25 years by NASA. And so that urgency made coral reefs a great case study for studying tone. Tone may seem like a bit of an abstract topic, so I wanted to define it within the bounds of this project specifically for you. It is an aspect of communication that involves narrative delivery characterized by linguistic tools. The linguistic tools which I used in particular in this study revolve mainly around vocal inflection, music, and vernacular. And the specific feelings that I was hoping to elicit in my audience are that of hope or concern, respectively. Tone is proven to have massive impacts on audiences' perception and further action after receiving media. And the way in which we communicate needs to be determined by the author's goal, whether that's to inform and educate a population or, again, perhaps more importantly, to inspire action in the viewers of our communication. So the first thing that I did in order to actually collect data on the impact of tone was I surveyed 200 visitors at Birch Aquarium. And I did so with a survey that I created which answered two main questions. I broke them down here. You can see this graph on the left represents the first answer that I was searching for. These first four questions in the survey are derived from the 6 America's Super Short Survey created by Yale University. And this offers a national perspective compared to my 200-person control group, data displayed here in white. And that national information is shown with the blue bars here to the right of those white ones. And we can see here that the majority of my population that I surveyed stands as a very alarmed population when it comes to climate change, especially compared to the national average. The average American is much less concerned, significantly less concerned than the group that I was studying here at Birch Aquarium. And this may seem like a very skewed result. However, I think this is imperative to this project in that audiences who are already choosing to engage with climate communication are going to be those who are entering the field at an alarmed or concerned stance. Secondly, I'd like to draw your attention to the right side of this slide. We have a pie chart here showing the answer to my second key question, and perhaps the more important part, definitely for this particular project. It asks about participants' willingness to participate in climate action. Now, this is a sum of 5 different forms of climate action. This is on a personal level, a conversational level, within their community, on the political scale, and also one question asking about their willingness to participate within the next month. You can see here that the largest response group is about 40% in that willing triangle there. And this is the median response available in this survey. So right in the middle is where most people wound up, with fewer than 10% of the population not willing, or you can't even see that 1% sliver of very unwilling participants. And then just about 30% of people were either extremely willing and also very willing to participate. Now try your best to remember those statistics. I know it's a little bit difficult, but they'll have a little bit more context in a minute. First, I need to show you my form of communication. The treatment that I used for this particular study revolves around 2 videos that I created. Visually, they're almost identical, using data collected by the Sandin Lab here at Scripps. This is a form of photogrammetry called large area imaging, which converts pictures of coral reefs, millions of them, into interactive 3D models. However, the videos differ in their audible components. I wrote 2 different scripts, both covering very similar topics of conversation, but in quite different ways. One of them is a more positive tone, and one is a more negative tone. And I'm going to play snippets of each video. I'd like for you to try to guess which video is which as we watch these together.
The extremely slow-growing nature of coral reefs makes them a non-renewable resource. This bleaching event alone decimated a third of this reef system. These sites will never be the same. Large area imaging makes it possible to see, in the rare instance that these reefs do survive, only a select few species of coral can return to these sites.
Okay, and our second video here.
With large area imaging, we can witness how coral reefs fare in healthy conditions, unsustainable temperatures, and rarely, the recovery that follows. This site, like a third of the whole reef, was bleached beyond what scientists previously believed to be salvageable, due to the slow-growing nature of corals. However, select sites like this one reveal corals recovering and regenerating at incredible rates.
Okay, here's the big reveal. Hopefully we're all on the same page. So a little bit more context when it comes to tone. So I showed 400 more participants, one or the other of these videos. And the results are as follows. So we're going back to those 2 fundamental questions one more time, starting with stance on climate change. So as you remember from that first bar graph we saw, that white chart, our control group, our baseline data, was already heavily skewed towards alarmed. These people are already well educated on climate change and concerned about the issue at hand. After having watched either one of the 2 videos, my treatment groups were actually even more alarmed than the concerned group that I originally surveyed. Surprisingly, the negative video had a stronger impact than the positive video, both of which were more powerful than no treatment whatsoever. But the negative video seems to suggest that people are more educated or alarmed about climate change after having watched this, again, alarmist approach. So makes a little bit of sense. So if your goal is to educate your population, then perhaps a negative tone is the more effective solution for that particular goal. However, if you would like to actually inspire change in your population and your audience, the positive video does have a statistically relevant higher pull towards extremely willing to participate in climate action. And this is actually a compounding result. If you can notice under the not willing part of this graph, there are fewer people who are not willing after having watched the positive video displayed here in pink in the middle of those 3 bars than there are not willing after having watched the negative video. This is very interesting, and this is really the answer that I was looking for having conducted this experiment. And we can learn that with a positive tone, although it may seem difficult to convey climate change in a lighter event, we can inspire more action towards a solution. As for applications of this particular project, they're pretty far and wide between. First of all, I would love for climate scientists to apply this to their publications, whether they be scientific or op-eds. Educators could absolutely implement this in curriculum they write. Policymakers could use this in their proposals, and environmental organizations could absolutely use a more positive tone in their outreach. But I think maybe the most important takeaway of this project is that activists, or just people in this room who already have some knowledge about climate change, can and should talk about it so that it's no longer this voodoo kind of topic that nobody's allowed to discuss. And doing so in a positive tone, or even if you can do it in a negative tone, you can make a difference and inspire climate action in your family, your friends, or even maybe a complete stranger. And so I want to leave you with one final message. Thank you so much for being here today and participating in climate action yourselves.
Your support in the form of climate action pulls fragile ecosystems like coral reefs from the dangers of climate change and towards a brighter future.
Thank you all.
Hi, Lang. Thank you. That was amazing.
Thank you, Brooke.
Why did you choose videos as the form of media you use to communicate?
So I wanted to have a combination of different aspects that I could control very easily. First of all, I was able to utilize visual data that was offered locally as part of the Sandin Lab here at Scripps. Also, I was able to deliberately manipulate a specific tone and replicate it consistently. These videos, if I had been talking to the people that I surveyed, I would have messed up my words, as I'm sure I did in this presentation, and it would have been a little bit different every time. This offered a form of consistency, and it offered a reliable way to measure the impacts of multiple different variables, including music, as I know you all heard that kind of big crescendo in that more positive video, as well as those 3 key aspects that I wanted to focus on in language and music again, and just tonality, how we talk about problems like this. Thank you for your question.
Hey, Lang, good job. That was really awesome. I have kind of 3 mini questions for you. So first, I just was curious if you showed them, like at what part of their aquarium experience did you show this video? Was it in the center of the aquarium? Was it as they were entering or leaving? And then also, was there anyone, did they have to approach you or did you approach them? And kind of how did you gauge their willingness to watch the video? And I guess I'll just leave it at that.
So it's a little bit varied. First of all, I was stationed. I had like a table set up of right near kind of the entrance or exit. I don't know how many of you have been to Birch, but I'm sort of by the door when you walk into the actual building. So some people were coming and some people were leaving. It was a little bit all over the place, but definitely varied. fewer people were interested in talking to me. There was a lot of rejection when it came to approaching people to participate in this study, as I'm sure you can imagine. But some people were actually very willing to be involved, and that was really heartwarming for me personally. There were a few cases where people's responses after having participated in the study, largely after watching the positive video, people were more willing to ask about ways that they could participate in climate action and asked for specific actions that they could carry out in their day-to-day lives. Whereas after watching the negative video, I didn't have that as much. I can't believe I'm saying this, but I was kind of proud to say that I made a couple of people cry after watching the negative video. I'm sorry to say that on camera, maybe delete that part, but and I'm sorry, what was the last part of your question? One more
That was
time?
it. Thank you. That was great.
Thank you so much.
Right. Great job, Lang. Our next presenter is Marina Minnick, and it was impressive throughout the year to see how Marina just approached scientific problems from whether it was AI to air quality in a way that kind of foretells somebody who might have a lab of their own one day. Just very good at finding where the key questions are and how to design ways to address important questions. And I think this capstone, Marina's going to be talking about a situation where there is ongoing extreme environmental impact on vulnerable communities, and part of that is because of long-term politics and policy failure, and also it's just a difficult problem trying to understand this Tijuana issue that Marina is going to talk about. But this research is being applied to a problem that is directly and severely impacting the lives of many San Diegans right now, and this kind of data collection and working with this data to get a better understanding of the problem is going to make, this kind of work is going to make lives in San Diego better very soon for the people who most need the support. So Marina's project, quantifying indoor air quality impacts of Tijuana River pollution across South Bay households, a low-cost sensor network study. Marina, the floor is yours.
I'll try to keep a positive tone. I'm inspired. Okay. Again, thanks, Corey, for the intro. My name is Marina Minnick, and I chose to focus on the Tijuana River pollution and how it impacts indoor air quality in the South Bay. So for those of you not familiar with San Diego, we are here, and the South Bay is there, 41 kilometers south of Scripps and about 1 kilometer north of the Tijuana River. The Tijuana River flows through Tijuana across the U.S.-Mexico border near San Ysidro, and through San Diego's South Bay communities and the Tijuana estuary before emptying into the Pacific Ocean. The river is famously polluted, ranking second on America's most endangered rivers list. And the river is being polluted by a lot of different things, one being sewage and untreated wastewater from aging and inadequate infrastructure on the US and Mexico sides, from trash and urban runoff from Tijuana's urban area, an area that has experienced extremely fast growth, and toxic industrial waste from factories upstream. In recent years, Imperial Beach's public beach was closed for over 1,000 consecutive days due to toxic pollution exposure, and NASA's Jet Propulsion Lab can now identify wastewater plumes from space. The issue of the Tijuana River being polluted is not a new one. In fact, these issues have been going on for decades. We've seen odor complaints and health concerns being reported as early as the 1930s. There have been decades of plans, commitments, and infrastructure and restoration projects, but the problem persists. As you can see on this map, the pollution crisis does not fall on everyone equally. South Bay communities like Imperial Beach and San Ysidro consistently score in the top quartile of pollution burden statewide. Cal EnviroScreen is a statewide tool, and it determines the score based on relative health risk, demographic factors, and local pollutants that communities are being exposed to, including air pollution. So as you can see, when compared to most of the rest of San Diego, these areas are in the bright red, meaning that they have a very high pollution burden. The Tijuana River is a known source of air pollution, but how is pollution transferred from water to air? One way is through aerosols. An aerosol is a solid or liquid within a gas and can be formed through various mechanisms, one being turbulence at the water surface, which can convert pollutants into fine aerosols. This video here is of the Saturn Boulevard hotspot, which is a turbulent spot in the river that was located by scientists with the help of local community members, and elevated levels of hydrogen sulfide and fine aerosols like PM1 were measured at this hotspot. So why does this matter? Both hydrogen sulfide and particulate matter have large public health implications. So hydrogen sulfide is a common tracer of sewage and has a natural rotten egg odor that you've probably experienced if you've been near the river. Panel B on the figure on the left shows in black hydrogen sulfide levels overlaid with daily odor complaints in red. And as you can see, there's a strong correlation between the hydrogen sulfide from the river and just daily odor nuisance that people living along the river face. The California Air Resources Board set a 1-hour average standard of 30 parts per billion for the purpose of odor control, and Rico et al. Found that hydrogen sulfide measured at the river hotspot exceeded that odor standard of 30 parts per billion nearly every day in September 2024. And during my study period, in April 2026, we saw spikes surpassing 3,500 parts per billion, with all but 3 days during the month exceeding that odor standard. Next, we have particulate matter, which is a mixture of solid particles and liquid droplets in the air. PM10 is associated with pollen, dust, mold. PM2.5 is next and closely tied to combustion particles. And this study focuses mainly on PM1, which is less than 1 micron in diameter and has been tied to Tijuana River pollution. It's especially dangerous because it's small enough to penetrate lung tissue, enter the bloodstream, which can cause cardiovascular and respiratory problems. And unlike PM2.5 and 10, there are no standards set for PM1 due to lack in research and monitoring technology. South Bay residents have been advocating for change and demanding for more attention toward this pollution crisis for a long time, and the science has started to follow. First, in 2023, Pendergraph et al. Detected sewage-associated bacteria returning to land, which was transported there via sea spray aerosol. And in 2025, Cooper et al. Found that people living near the coast may be exposed to wastewater chemicals via airborne exposure. Later in 2025, Rico et al. Measured extreme levels of hydrogen sulfide coming from the hotspot that you saw in that video, and found that the turbulence at that site was likely leading to those elevated levels. And finally, in December of 2025, Cisneros et al. Measured elevated levels of PM1 at the hotspot, suggesting that PM1 formation may be driven by the hydrogen sulfide. So air pollution is a leading global public health threat, and indoor air quality has emerged as a critical but comparatively understudied area of research. Residents of developed countries often spend approximately 90% of their time indoors, yet the United States has no federally mandated residential indoor air quality standards. Prior research has established that the Tijuana River pollutes local water and outdoor air, but the question of whether that pollution reaches people inside their homes remains unanswered. This study is designed to fill that gap. With such a prominent pollution source located right here in San Diego, this study seeks to determine if and how pollution from the Tijuana River influences indoor air quality. It focuses on PM1, a size fraction that is understudied, unregulated, and relevant to the Tijuana River. It demonstrates that low-cost sensor networks and citizen science can expand access to indoor air quality data, and it works to complete the exposure pathway. So for my design, I was able to use 2 sets of air monitors, an already existing outdoor air monitor called QuantAQ, and an indoor air monitor that I was able to purchase with Julia Brown funding, and these are called air gradients. Both the indoor and outdoor monitors measure a lot of different parameters, but we'll be focusing on PM1 and PM2.5 for this study. And together, the monitors create our own low-cost sensor network, which again have been growing in popularity due to their ability to make indoor monitoring more affordable and accessible. The air gradient monitors were hosted by students selected from the Youth Climate Advisors Program who are interested in getting into science during high school, and by various local public institutions like the Imperial Beach City Hall and the Tijuana River Estuary Visitor Center. So all hosts were asked to fill out detailed surveys about the information of the building the monitors would be hosted in, including ventilation, window use, and cooking behavior. And those results were used to interpret our data. So here is a map of the sensor locations with the red being indoor monitors and the blue being outdoor. Here is the hotspot with denoted by the yellow star. And then right above the hotspot where you see 3 clustered circles, that's the Prather Mobile Lab. So it's a mobile lab that houses both the indoor and outdoor sensors and a hydrogen sulfide analyzer. And I'll be referencing that location quite a bit when talking about the results because it is just 1 kilometer north of the hotspot. But there are other outdoor sensors located throughout the region. Okay, so what did I find? Here is a heat map summarizing the particulate matter 1 measured throughout the study period, which was April 3rd through April 28th. And it's showing it with a color bar. So the concentrations go from 0 to 15 micrograms per meter cubed, with the dark purple being 0 and the yellow being 15. The x-axis shows time or date, and the y-axis is the PM1 located at the sensors. The top 5 rows are outdoor, and then the rest are indoor. And you can kind of get a sense of trends from this image. So when you see yellow spikes going from top outdoors to bottom indoors, that kind of gives you an idea that the indoor sensors may be impacted or responding to outdoor pollution, like we see here on April 8th, which was a high pollution day. If you couldn't see that, we'll zoom in a bit closer. Here is 3 contrasting days from the study period. So the first panel on the left is April 8th, and on this day we measured high levels of PM1 and hydrogen sulfide at the hotspot. You can see there was a peak happening from 6 a.m. to 2 p.m. at the Prather Mobile Lab sensor, and then the City Hall sensor shows a similar but slightly weaker signal, which City Hall is about 4 kilometers northwest from the hotspot. The indoor sensors respond to that outdoor PM1, as you can see if you take a look down the panel. Moving to the middle panel with April 24th, we see a shorter spike in outdoor PM1 rather than sustained elevation. So the indoor sensors show a similar pattern to that. And then April 13th is our clean reference day. We measured close to 0 levels of PM1 and H2S that day at the outdoor sensors, and the indoor sensors remained near 0 as well. You may notice a few random flashes of yellow there. This data was filtered to remove indoor sources like cooking and cleaning, and while they did a good job removing a lot of that noise, it was not perfect, as we could see by some of those flashes. Okay, so zooming in a bit closer to the, we're keeping the same 3 days, but looking at 3 specific sensors. We'll start with the left panel. So in the first column is a home in Imperial Beach. This home has no air conditioning and almost always has a window open. And as you can see, the indoor PM1 in blue tracks the outdoor pollution quite closely, pointing to the fact that the outdoor pollution is coming indoors easier due to the windows being open. The middle column is a school classroom with central air conditioning and windows almost always closed. So notice how much quieter the indoor signal is. The building is doing a much better job filtering out that outdoor air before it comes inside. And the right column is City Hall, with central air conditioning but variable window behavior. Sometimes they're open, sometimes closed, and it shows more outdoor response in the classroom and more varied response than the home. And now if we look at the bottom row, this again is our clean reference day. And outdoor PM1 is near 0, and indoor PM1 follows suit at each sensor. This is our control, and it confirms that what we're seeing on event days is likely real outdoor to indoor relationship and not noise or coincidence. One more figure, the matrix shows how strongly each sensor correlates with outdoor PM1 at the hotspot. So on the x-axis is our outdoor PML, or Prather Mobile Lab monitor, and on the y-axis are our different indoor sensors. So the darker red means the stronger correlation. If we start at the bottom at AG19, this represents our strongest correlation, and it makes sense. This is the sensor that is co-located with the outdoor sensor, but it is also closest to the hotspot and represents residents that are located within similar, if not closer, proximity to the hotspot. Moving up the rows, AG15 is a bit of a problem child. It had really noisy signal, but AG7 and 13 show moderate correlation, and AG11 and 17, both institutional buildings with that central air conditioning, show weaker responses, which again confirms that building filtration can help decouple indoor air from outdoor conditions. And finally, the coastal residence is the only sensor that had a slightly negative correlation value, which could be due to greater coastal influence at the site, which is corroborated by higher correlation value with the outdoor sensor that's located right on the coast. So what does this all mean for people's health? Due to the lack of PM1 standards, like I mentioned before, we're using PM 2.5 as a proxy for PM1 to try to quantify some of the health impacts or harm. So the World Health Organization, or WHO, recommends an average daily PM 2.5 threshold of 15 micrograms per meter cubed. So essentially, remember that number 15. You don't really want to go above it in one day because going above the exposure level is considered harmful to health and is associated with increased respiratory and cardiovascular risks. The toxicity potential is a metric that basically measures how close you got to meeting that WHO threshold in a day. So for example, if we had an air monitor in this room and at the end of the day, the daily average concentration of the room was 15, we would have a toxicity potential of 1, meaning we would have met the threshold for the day. Essentially, toxicity potential can kind of be used, and you can filter out data to look at what source is getting you, or look at one source and see how close it's getting you to the number 1. So for example, if you wanted to see how close a gas stove got you to toxicity potential of 1, you could look at data coming just from a gas stove. Here we kind of did the opposite. We filtered data just to look at indoor pollution that was being influenced by outdoor pollution. And right here is the figure that shows that data. So the x-axis is the toxicity potential, with the y-axis being the indoor sensors. And I want you to focus on the blue and the purple bars there. So the blue bars represent how close outdoor pollution and likely Tijuana River pollution got us to 1. And you can compare that to purple, which is taken from days when we saw high pollution at the river. So when comparing blue to purple, we're seeing almost a double value when there is pollution happening at the river, kind of pointing to the fact that when we do see pollution happening from the Tijuana River, we're getting closer to meeting the World Health Organization threshold for PM 2.5. So what did we kind of find from the study? The main findings first is that there is evidence that suggests pollution from the Tijuana River, specifically PM1, negatively impacting indoor air quality in Imperial Beach. And number 2, ventilation and proximity to the Tijuana River influence how strongly the river pollution impacts indoor PM1 levels. The bottom line is that the Tijuana River is more than just an odor problem. There's mounting evidence that the Tijuana River is a major source of air pollution, and that this study suggests it may be making its way indoors. This has implications for other communities that are located near polluted bodies of water, which may be serving as an additional and unexpected source of indoor air pollution. And then quickly acknowledgements. I know I'm over time, but I want to thank Dr. Mark Merifeld and Layla El-Masri for being on my capstone committee and providing the best guidance, support, and expertise I could have asked for. Thank you to Dr. Kim Prather, the Prather Lab, the Airborne Institute, and the Bellevue Foundation, and the Youth Climate Advisors for supporting and funding some of this research, for providing resources, and for connecting me with a group of awesome youth scientists who were willing to participate in my project. I want to thank Dr. Corey Gabriel and Jada Ryan for the ongoing encouragement and wisdom. And I want to again thank Julia Brown for funding the Air Gradients and Air Gradient for giving me a discount. And finally, thank you to my family, friends for pushing me to take this leap of faith, and to my cohort. I love all of you.
Thank you so much, Marina. That was fantastic. When you think about ways to communicate, if there's an incoming, if you can predict an increase in PM levels, and if there's like a lot of wind or something, what are the best ways of communicating with communities that you think should be utilized to warn people in advance to close their windows and change their behaviors?
Yeah, I think that a lot of community members are very passionate and involved about this issue, but certainly not everyone is. I think one thing is there does need to be an expansion of monitoring systems to understand when there are going to be high pollution events, so that community members do know to close their windows, turn on their air purifiers, things like that. I think it starts at current institutions. So if we can go through schools, if students can be educated K through 12, they'll go home and tell their parents about that. I think that's always a great way. And then just meeting people where they're at, rather whether that's at houses of worship or block clubs or things like that. So I think, yeah, word-to-word communication is best.
Thank you so much. Thank you so much, Marina. What an incredible hotspot to be looking at. Very huge environmental, human, and economic impacts of the Tijuana River there. In the short term, did any of your research reveal that the indoor air purifiers had any effect on the toxicity inside? I mean, I can't imagine living near the beach and not keeping my windows open, so.
Yeah, definitely. It was asked in our survey results, but I don't think we had enough sensors in homes with and without air purifiers to really tell whether or not they make a difference from my data, but I know in other studies, I think they definitely do make a difference. So I would encourage, if you do live near a polluting source, to purchase an air purifier and to use it, for sure. Yeah.
All right. Excellent work, Marina. Thank you so much for that. Continuing here on the theme, to some extent, of health impacts. Often when we think of climate change, we think of the temperature increasing, we think of more severe storms, we think of the need to decarbonize, we think of sea level rise, we think of all sorts of things like that. We think of extreme heat, but often we don't think about the things that might lurk a little bit beyond the realms of our everyday imagination. But as we perturb our climate, we also perturb the biodiversity on this planet, and we perturb the distribution of where things live and where things thrive. And we have adapted as a species to live within a pretty narrow bounds of parameters. And one of the things that we need to take very seriously and give a lot of attention to is the potential for changes in patterns of vector-borne diseases. People, anybody here who's been to parts of Africa where there are severe malaria is a thing, and there are substantial amounts of human beings who carry a gene to provide some level of immunity to malaria, right? Very small percentage of people are going to be carrying that gene, for example, in the United States or in Canada. And the trajectory of how these vector-borne, like something like a mosquito stinging a person, the trajectory of how these sort of diseases evolve, right, and other threats that we might not think about, these kind of beneath the surface threats, these aren't necessarily in the models, part of the damage function. But the kind of work Cole did, bringing his background in biology and chemistry to this problem, is extremely important and extremely interesting, because these sort of public health and changes in the distribution of diseases and how these diseases exist with the existing comorbidities in individuals and communities, it's really important, and that's going to give a lot of granularity and detail to how climate change does impact this country and San Diego. And Cole is going to be presenting on that with ameliorating San Diego's climate action plan in anticipation of emerging vector-borne diseases. Cole, the floor is yours.
Alrighty, good morning, everyone. I am going to be, as Corey just said, be talking a little bit about vector-borne diseases and how our prediction of vector-borne diseases is changing as our non-analog climates. Non-analog climates is just a fancy term for climates that have never existed before, climates that we don't have previous data for. So climates that are moving into new ranges will be considered non-analog climates. And a vector-borne disease, so just to define a couple things, a vector is that guy right there. That is a Pulex irritans, or a human flea. Whenever I say vector, just think of a small bug, small insect, anything that is capable of transmitting a disease. And this guy, Pulex irritans, along with a couple other people, a couple other insects, are responsible for roughly about 17% of infectious diseases around the world. That equates to 700 million cases worldwide, with over 1 million of those, or roughly under 1 million of those, being fatal. A majority of these are collected in tropical areas and have kind of adopted the term neglected tropical diseases because they are in areas with low GDP growth and inadequate healthcare to actually address these issues. Now you might be thinking, why should we care about this? We have great healthcare, we have amazing vaccines and all these great things going for us in our first world country, but unfortunately, neglect can no longer be our option of looking at these. We have to kind of change the way that we look at these. So the biggest one in my research and what I looked at was various different mosquitoes who have become endemic to California. So there's the Aedes aegypti, Aedes albopictus, sorry, I always get that one wrong, and the Aedes notoscriptus, which are all different types of very similar Aedes mosquitoes that can be found in a variety of different counties here in California and San Diego as well. Their lifespan actually revolves around water. So that's what kind of where the important part of climate comes into this, is the water cycle, or the life cycle of the vector itself is heavily dependent on water. They live to be roughly about 4 weeks, the adult females, but they spend the first week of that in water. So the water source is incredibly important. And there's about 176 different species found in the United States, 3,700 worldwide, and we expect those numbers to be increasing in the United States. So the first one that I'd like to talk about, an impacting factor in these vector-borne diseases, is climate and climate change. So temperature rise will allow for these vectors to grow and move into new areas in which they were previously uninhabitable. So the temperature rise will fit the temperature range in which that vector is most competent and able to transmit its disease. So down here in the left corner, just kind of a general guide of what California might look like. I think we can kind of maybe not ignore the higher emissions, but those are worst case scenario. So lower emissions is a pretty good predictor for what we can look at. With that temperature increase, there's also going to be range expansion. So they'll be moving polewards at, I think it's roughly about 5 kilometers per year is what some studies have been showing. And then also seasonality. Seasonality will be increasing as well with the temperature increase, meaning more months out of the year, the mosquitoes will be able to transmit that vector-borne disease. Another issue is sea level rise. So some Aedes mosquitoes have become tolerant to saline water and have been able to find ways to adapt to saline water. And this could be an issue with tidal flooding in the area of La Jolla and other areas that experience tidal flooding. On top of that, precipitation shifts and extreme events will also have an impact. Now, it's a little difficult to say how a heavy rainstorm will impact it because there's a lot of factors that go into this. And also, California is expected to experience extreme wet years. The extremes are going to go up, and those extremes are going to contribute to the habitat expansion of these mosquitoes. So us as a species, we're incredibly urban. We have adapted to urban environments, or we grew the urban environments, and then the mosquitoes kind of came along secondary and adapted very well within our urban environment. They can find stagnant water in many different anthropomorphic sources, whether that's either rainfall or other urban areas. Studies have shown that they have specifically adapted to host specifically humans and in urban areas. So our heterogeneity or homogeneity of cities is very similar across city to city. So these mosquitoes that are, temperature tolerant or capable in one urban environment are very likely to be suitable for another urban environment because of their similarities between the two. Global travel is a huge issue and has been linked to a spread of a lot of these diseases. I think a tire is a pretty good example, like a used tire, no matter which way you sit it, it can collect water because of the U-shaped interior. So tires being shipped, used tires being shipped across the country, over water, those will contribute to the spread of diseases. Land use changes, this is kind of an important one because we've changed a lot of our surfaces to be semi-impermeable and water cannot go through it. So standing water can arise from those areas in various urban environments. Now, when it comes to predicting how California will be impacted, it gets a little bit murkier because of the complexity of the issue. So what we do know is that California will face small amounts of warming and then longer dry seasons and then also increased extremes. These are challenging to deal with because as you can see here in this photo, the resolution of this has all of San Diego and a bunch of other counties all kind of in one box. So finding meaningful predictions and information that can be found that is useful for policy is not as easy at this scale. So to give you a little bit of a bigger picture on the global scale, I think this image does a pretty good job of describing where the mosquitoes are going to be moving and how they're going to be moving poleward. And this is under the worst case emission scenario. So again, take this with a grain of salt. This is most likely not going to be what is going to happen. It's going to be a little bit less than this. However, you can see the number of months as well as the actual habitat where 1 month per year where the Aedes aegypti can spread its disease is increasing. The amount of surface area of Earth and also the amount of people that it will reach with this expansion is a very large number. Tick habitats are expected to produce or to increase by over 200%. That runs the risk of Lyme disease. Diseases that we have to worry about are Zika virus, dengue, malaria, not so much, but a couple other ones in there as well. But I really like this image. I think it does a good job of kind of explaining the core issues. So what's being done about it? There's a handful of things being done about it. The WHO is very on top of things, and they have a global vector control program where they coordinate with multiple different states and different organizations to monitor the vectors and monitor the amount of diseases that are prevalent inside of those vectors, because not all mosquitoes carry disease. Some mosquitoes do, some don't. The mechanism of that is not very well known, but we are trying to learn a little bit more about it. So different types of climate-driven disease models. I think NASA's working on one, as well as a couple other ones. I think that that will be a very important part in determining future predictions for diseases if we can kind of get the climate modeling inside of that as well. So vector control is a big part of it as well. Almost every country has some form of vector control that has vectors. The interesting ones that I found were the ones that involve modification either genetically or physically of mosquitoes and then a re-release of those into the wild. So some male mosquitoes will be treated with a certain type of bacteria or will be sterilized, and so they go into the wild, they will mate and then produce offspring that cannot reproduce. So essentially, in some areas, in some cases, that will lead to a reduction of mosquitoes and vectors in that capacity. And there's a couple different ways to do that. Vaccines and treatment, I think that's probably the biggest key of this, because it's a frontline defense. It is proven to be very effective in terms of getting rid of or preventing diseases. So I think looking into different vaccines and treatments for these are going to be an important part. So what can we do about it? I think that's a pretty important question. I always ask myself, what can I do on an individual level? What can I do to make this change? And there's a couple things that I'd like for you to think about. I guess just when you're on your next walk, and if maybe it had rained the day before or you're in a neighborhood, just pay attention, see if there's any stagnant sources of water, any sitting sources of water that are either in a yard or anywhere where people live. And common sources of those are, as you can see on the screen, so tires, like I mentioned earlier, kids' toys, equipment, anything that will hold enough water. And these vectors only need about like a bottle cap's worth of water, about 5 to 15 milliliters, a very, very small amount of water to be able to reproduce. So a lot of these bird baths, hot tubs, anything that holds water and can become stagnant has the potential to become a breeding site for these vectors. Using DEET, which is an insect repellent, is very helpful. Supporting policy for funding these programs that can get out insecticide-treated nets, as well as different insecticides at a public level would be important as well. And then also on the policy side, so integrating vector risk into climate adaptation planning, I think, is an important one. Having procedures and safeguards in place for when these diseases emerge into new places, we have a proper protocol on what to do about it. There is kind of the biggest thing that I've found in this climate science space is that everyone says decarbonize. And decarbonizing, I think, is a huge part of being an active participant in climate change and being a good participant in climate change. So I think that's an individual action that most of us can do, and supporting policy and systems that also support decarbonization. So if there's any takeaway that I want you to have here is that this is a very complex issue, incredibly complex. There's a lot of different factors that go into this. An entomologist, an immunologist, a public health official, a climate scientist, as well as a handful of other different expertises will all have something meaningful to add to this picture. So there is a very, very large need for interdisciplinary science, because with normal diseases, you're only worried about a handful of things like a R value, and then like in the gray over there, the other factors. But with vector-borne diseases, there's a whole other organism that's attached to those organisms. So you have to worry about where that organism can thrive, where it can live, where it can't live, in order to be able to actually predict these things on a level which is applicable for policy. So it's pretty interdisciplinary is the only thing that I'd like to have you take away from this. And that is all. Thank you very much.
That was amazing. Thank you.
Thank you.
I have a quick question on your maps where you were time lapsing and showing 2050, 2080.
Mm-hmm.
The 2080 South America map, I just kept staring. There was a break where the red the red was hot, but it looks like the Amazon opens up.
Yeah, that's
Do you have
actually,
any idea there? Of
yeah, that's actually an interesting point. And you can see that happening in Africa as well. Some of the more equatorial parts actually decreasing in months where the mosquitoes will be able to transmit the diseases. That's because it's getting too hot for the mosquito. The temperature ranges are actually increasing to where the mosquitoes cannot function anymore. So they're predicting a decrease in months where those would be available. Yeah.
So I think within the last week or so, there was some interesting policy issue came up that Alphabet, which is the the parent company for Google, mm-hmm. is requesting from the EPA to release like 32,000 sterilized male mosquitoes. Mm-hmm. And so the policy is kind of interesting there. Number one, the approach. Number two, a private sector company that wants to take the lead there. And I'm just wondering your thoughts.
Yeah, I think that various forms of releasing insects to breed with other insects is a good form of insecticide or vector control. I personally think that that's using fire to fight fire in the best way possible. If done incorrectly, it can make the problem worse. So there are precautions that you need to take when it comes to screening to make sure that all of those males were actually sterile and making sure that you're not increasing the mosquito population. But yeah, I'm all for it. There are potentially unforeseen consequences and side effects that have not been documented, but I think that's kind of the case with every novel interaction.
Great presentation. Thank you so much for the work you've done. I have a question about Chagas disease.
Yeah.
It's a vector-borne disease that causes a lot of problems in Latin America.
Mm-hmm.
An epidemiology study was begun some time ago to see if it had spread into San Diego County yet.
Mm-hmm.
Do you happen to know the outcome of that study?
I can't remember. I do remember looking at Chagas numbers in California because the California Department of Public Health has released those numbers. In my finding, I don't think it was anything of significance, which means that there might have been a couple, but it's nothing crazy. I don't think I've seen. Maybe a handful, but yeah.
Just so you know, we will have a short break after this next presentation. Our next presentation, the final presentation of this block, will be by Brooke Parks. Brooke has really shown very little interest in empty words and virtue signaling, but rather has a theory of change that I think involves actually implementing long-term important changes over time in a way that is potentially sticky. An example I'll give to de-abstract that is I was preparing a discussion this summer, and one of the articles just wasn't that interesting, and Brooke called me out on it. And I replaced that article with an article about a data center project in Memphis that was pushed through basically with minimal oversight and a lot of arm twisting, and ended up being a pretty big news story a long time afterwards. So Brooke has an ability to identify problems, bring attention to the problems, and in this project, apply rigor and careful study to get facts that support her points of view and energize somebody, I don't say this lightly, somebody who could be on a state or national level a serious change maker. One of the more talented people I've ever taught or met. Brooke Parks, with the heat we don't see, quantifying indoor heat disparities in San Diego County to drive policy change. Brooke, the floor is yours.
All right, well, thank you so much, Corey. I'm gonna try not to cry as we get started. That was amazing. But I'm gonna go back over this. My name is Brooke Parks, and today I'm gonna be presenting my capstone project titled The Heat We Don't See, Quantifying Indoor Heat Disparities in San Diego County to Drive Policy Change. So today I'm gonna be covering my introduction, methods, 3 different objectives, and some policy recommendations. Before we go further, let's first look at the problem of extreme heat. Extreme heat kills more Americans than any other climate hazard, more than floods, tornadoes, and hurricanes combined annually. And these events are only getting longer, more frequent, and more severe. But what makes extreme heat so dangerous is how it affects your body. When temperatures rise, the body works hard to cool itself through sweating and increase blood flow to the skin. But when heat becomes extreme, the body's cooling system gets overwhelmed. Heat exhaustion can escalate to heat stroke when the body's temperature exceeds 40 degrees Celsius. At that point, you could be looking at organ failure, and without intervention, even death. Prolonged exposure also damages the cardiovascular system, the kidneys, the lungs. Extreme heat affects every part of your body. But what is less talked about with regards to extreme heat is where most of these deaths and heat exposures actually occur. The CDC estimates up to 45% of known heat-related deaths occur indoors. Yet almost every heat warning system we have is built around outdoor temperature only. That gap between where people are and where we are measuring is what this project is about. Before I continue, I want to first ground this study in an environmental justice framework. If you couldn't tell, that's what I'm about. Environmental justice scholars identify 4 key dimensions of climate inequity. First is differential exposure, where communities of color and low-income communities are disproportionately located in hotter urban areas with less shade and more heat-absorbing surfaces. Second is differential susceptibility. Groups like the elderly, children, and people with chronic illness face greater physiological risk at similar temperatures. Third is differential adaptive capacity. Running air conditioning costs money. Retrofitting a home with air conditioning costs money. Moving to cooler locations requires resources, and not everyone has equal ability to protect themselves from extreme heat. And lastly is differential evidence. The communities facing the greatest heat burden are also generating the least data about their conditions, and we cannot advocate for communities we know nothing about. Next, I want to talk about the indoor heat exposure gap. This chart walks through the pathway from climate change to what this study is actually measuring. Climate change intensifies outdoor heat. That is the starting point. But the assumption most heat systems make is that outdoor temperatures equal human heat exposure total. This is something that Marina mentioned prior, but people spend up to 90% of their time indoors. And for the vulnerable groups I mentioned prior, that time is even more. What widens the gap between outdoor and indoor conditions comes down to so many factors: old housing, dense building materials, lack of air conditioning, cost barriers, and high energy burden. The list could go on and on. But those factors hit low-income and minority communities the hardest. Heat warnings miss the most vulnerable people, and that is exactly why indoor monitoring at the community level is needed. For my case study, I chose San Diego County, where we are right now and where I was born, and there are a few reasons why. San Diego County is home to over 3.3 million residents, making it the 2nd largest county in California. As a result, I felt like this allowed for a more widespread and comprehensive analysis given the large population size. It also has a very dramatic coastal to inland gradient, which is particularly interesting for studying temperature. It's also incredibly racially, ethnically, and socioeconomically diverse, which makes it a great place to look at inequities in heat exposure. For the purposes of this study, I focused on 3 main objectives. First is to quantify the indoor-outdoor temperature differential, what I'll be referring to as delta T, and its socio-demographic predictors. Second is to analyze heat mitigation factors. And third is to examine data missingness as an environmental justice issue. So the study area, like I mentioned, is San Diego County, and the study May through October, which now is shockingly considered the warm season for us. And the reason 2023 was chosen and not a more recent year is because it has the most complete and comparable data sets across all of these variables. For data, I use Purple Air crowdsourced indoor and outdoor sensors co-located, which measure temperature, humidity, and particulate matter. I used GridMet for gridded meteorological outdoor data for extreme heat analysis. I use the American Community Survey Census Bureau data and CalEnviroscreen 4.0 for sociodemographic variables. I use the Enhanced Vegetation Index by MODIS satellite data for green space coverage and vegetation, and modeled AC ownership data from An and Hueo, who created a predictive AC access model. My analysis included descriptive statistics, regressions, t-tests, and spatial mapping. All of these allowed me to produce correlations between different predictors and temperature variables. So like I mentioned earlier, my first objective is to quantify that difference between indoor and outdoor temperature and associate it with different sociodemographic predictors. So just for clarity, delta T is just average seasonal indoor temperature minus average seasonal outdoor temperature across 21 directly measured census tracts. You can see that in the map there. And the gray areas are areas where we have no data. The results showed that the average indoor gap, or delta T, was actually plus 4.07 degrees Celsius, or for us Americans, 7.3 degrees Fahrenheit, which is actually kind of a lot. And in 90% of measured tracts, indoor temperatures were warmer than outdoor. This means that during the warm season, homes in San Diego are consistently and substantially warmer than the air outside. Now let's look at extreme heat days. So on a normal warm season day, I found that delta T is plus 4.72 degrees Celsius. But on these days, outdoor temperature is mild, so even though homes are warmer, the risk is a little bit more manageable. But on days when outdoor temperatures hit San Diego's heat emergency threshold of 93.1 degrees Fahrenheit, that buffer collapses to just 1.08 degrees Celsius. Now you may be thinking that's great, indoor temperatures are decreasing, but this is not true. Indoor temperatures are not holding steady while outdoor temperatures spike. They're both rising together. So on the most dangerous days of the year, going inside barely helps. You may be out of the direct sun, but you are in an environment that is nearly as hot as outside, if not warmer. And our warning systems have no way of knowing that because they're only tracking outdoor conditions. So next, I looked at different sociodemographic variables. When I looked at delta T, income was significantly associated with it. Wealthier tracts appeared to have a much larger delta T, which I found kind of surprising. So I decided to separate indoor and outdoor temperature, and then I realized the picture completely changed. No sociodemographic variables significantly predicted indoor temperature, but income and poverty were significantly associated with outdoor temperature. Wealthier census tracts had cooler outdoor air. And looking at locations where measured tracts are, it's highly likely this is because of the marine layer, the tree canopy, and ocean breeze, since they're located near the coast. So the gap only looks larger in wealthier communities, not because their homes are hotter, but because their outdoor conditions are cooler to begin with. This finding tells us it's a lot less about what kind of house you live in and a lot more about where you live. So the next objective was to analyze different heat mitigation factors, specifically green space and air conditioning access. To understand why I measured green space, it helps to know about the urban heat island effect. Dense and dark urban surfaces like concrete, asphalt, and rooftops absorb and retain heat during the day and release it at night, making urban surfaces significantly hotter than surrounding areas. Green space and vegetation counteract that effect by providing shade and cooling through evapotranspiration. So I used the Enhanced Vegetation Index for green space coverage across the full county to capture this. And what I found was that EVI, or the vegetation, was not significantly correlated with delta T or any other temperature variable. I kind of associate this with the small number of census tracts I was able to look at. But EVI was significantly and negatively correlated with CalEnviroscreen burden, which is a composite score based off of population characteristics, poverty, and pollution. What this shows is that communities with the least amount of green space are also facing the highest pollution and poverty. And you can clearly see that with the zoomed in version of the map. The blue areas represent the highest burden and the lowest amount of green space. And this is in like the South Bay and downtown San Diego area. And so this has direct implications for where urban greening investment needs to go. Now let's move on to AC access. Overall, I was kind of surprised by this. San Diego has a relatively high air conditioning coverage at 91.2%. This was calculated using a predictive model, so there is room for error. I myself don't have AC in my apartment, so I feel like 91 is kind of high. But 2.7% of households have no mechanical cooling at all. Now, you may be thinking to yourself, this is great, that's super low. But in a county of 3.3 million people, That's 31,000 households who have no form of cooling at all, and more than 80,000 individuals with no cooling on the hottest days of the year. Now looking at air conditioning prevalence and overall burden. Zoomed in on the map, we can see here in dark blue, there's a large amount of tracts with a high percentage of residents who have no AC and also have a high overall burden. But here's another clarification about air conditioning access. Even households that have air conditioning may not be running it. Energy cost is a real barrier. I found a significant negative correlation between central air conditioning and outdoor temperature, meaning that air conditioning is concentrated in communities where outdoor air is already milder. The communities that need cooling the most are the least likely to have it and the least able to afford running it when they do. This takes us to objective 3, was to examine data missingness as an environmental justice issue. So I first looked at overall sensor coverage in San Diego County. Of San Diego's 737 census tracts, 694, or 94.2%, have no indoor purple air sensor. It should be noted that purple air sensors carry an inherent bias. They are privately owned and installed, meaning wealthier households, municipalities, institutions like this are far more likely to have them. However, this is still an important finding because satellite data and broader gridded temperature models cannot capture what is happening at the community level. They tell us about regional conditions, but miss the street level variation that actually determines what people are experiencing inside their homes and neighborhoods. I also looked at racial and ethnic variables in association with sensor coverage. When I compared the racial composition of tracts with sensors versus tracts without, the pattern was actually pretty stark. Tracts with sensors averaged a significant percentage more white residents than people of color. This finding showed that monitoring infrastructure is disproportionately absent from communities of color. I found a very similar pattern with regards to socioeconomic and environmental burden. Mean CalEnviroscreen burden score was 13.6 in tracts with sensors versus 36.8 in tracts without. Poverty, unemployment, housing cost burden, and asthma rates were all significantly higher in unmonitored tracts. Results from this finding shows that sensors are present in the least burdened communities and absent from the most burdened. Based on these findings, I now have a few policy recommendations. First is simple. Put sensors where heat is the worst. We must prioritize minority communities that are high burden and unmonitored. But this cannot be a top-down government effort. These communities have a history of distrust with government agencies, and rightly so. Deployment must be community-led, partnering with trusted local organizations who already have relationships on the ground. Further, there needs to be updates to heat emergency protocols. San Diego's heat emergency system currently only triggers on outdoor temperature. We showed that on those exact extreme heat days, the indoor buffer collapses to just over 1 degree. Indoor monitoring at key sites should help supplement that outdoor trigger to give us a fuller picture of true exposure. At the policy level, California did take a significant step forward in 2025 by passing Senate Bill 655, which establishes that all residential units must be capable of maintaining a safe indoor temperature. But enforcement mechanisms and retrofitting for existing housing have not yet been clarified or defined. San Diego is currently developing an extreme heat action plan, which is good news, expected by 2027, and that's a real opportunity for us to get this right and to incorporate indoor monitoring while setting meaningful thresholds that help communities we know are most at risk. Third is urban greening investment. In Objective 2, we saw that communities with the greatest heat burden also have the least amount of green space. County and state funding needs to flow into these communities, but community organizations should direct where and how it happens. This does not have to mean large, sprawling parks. This greening can take the form of community gardens, pocket parks, and street trees. These can all meaningfully lower ambient temperatures without displacing residents. Fourth is cooling access and energy burden. We know from what I showed you earlier, 31,000 households, and probably more, have no mechanical cooling at all. And households that do have air conditioning may not run it because of cost. On officially declared extreme heat days, there should be a regulatory framework that requires utility companies to lower electricity rates, removing that financial barrier for many households. And lastly, expanding cooling centers into high-burden communities needs to be a #1 funding priority. Before I get to my numerous gratitudes, I just wanted to share one last personal takeaway. What I realized throughout the process of this project was that it was far less about the heat that we don't see, but rather the communities that we don't hear. their struggles, their experiences, and the way the environment around them has shaped their lives. These gray parts on the maps that I have shown you today don't just represent missing data, they represent missing stories. The stories of sleepless summer nights, of a family huddling together in the one room that has a fan, and of praying that this month the energy bill will be lower so they can spare a couple hours of air conditioning. We know that climate change will continue to intensify, and extreme heat will become more common. As a result, these unheard voices must become increasingly important. The challenge ahead is not just collecting better data, but it's making sure that communities living these realities are included in the conversations and have a seat at the table. Only then can we build a future that is not only more resilient, but more equitable as well. I want to thank my advisors, my chair, Dr. Tariq Ben-Marnia, Dr. Corey Gabriel, our program director, and Marion Hale for their guidance throughout this process and for all the amazing work that they do. I also want to give special thanks to everyone at the Climate Change Epidemiology Lab, also to Jada Ryan, our Rockstar Program Coordinator, and everyone in the CSP cohort who inspires me every single day. And lastly, at home, I know you guys are there, I want to thank my family, friends, and partner for your support throughout this process. I couldn't have done it without all of you. Thank you.
Thank you for that presentation. That was very impressive. I hope you're very proud of yourself. I just wanted to ask, if you were given the resources to expand on this project, how would you go about that?
Oh, that's like every researcher's favorite question. I think the first one was that I was really saddened that I didn't have the time to talk to communities and local government officials. As you can see, I love to talk, but I really wanted to do like qualitative interviews with local government officials and community members about what indoor heat means to them, and also if there's any policy around indoor heat that is currently being put into place or in the works. Like I mentioned, that extreme heat action plan, I actually wasn't involved with anyone with that, so I was really curious about what they're doing about indoor heat and if they have any plans for that in the future. Similarly, our program is focused on climate, so I wish I had more time to kind of look at like climatic regions in response to delta T and temperature, like areas that are more inland, what that delta T or indoor and outdoor temperature might have looked like. As you saw, sensors are really concentrated near the coast, and like I mentioned, really wealthy areas. So that was my last whole objective, was to talk about environmental justice and the fact that we don't know about inland communities, so I would like to know about inland communities. Yeah, I think that those are the things I wanted to do.
All right, we've got a quick break. We'll be back here at 10:35. Thanks, everybody.
Okay, wait. Is this not like the main?
Welcome back, everybody. I'm glad everybody survived the peril of the re-entry into this room. For those of you joining us remotely, we do have a door that closes very automatically, and one of our attendees had to race back to avoid being crushed by the automatically closing door. So it's definitely a you had to be here kind of moment, but it was funny. And that's my attempt to reproduce that as a radio broadcaster would. Our next speaker is a graduate of the University of California at Los Angeles, a major in atmospheric and ocean sciences. And as somebody who's studied that area just a tiny bit, I can tell you that that school and the way they approach it is first rate in this field. And Michael came to this program, and I know that he had previously been very, 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 very interested in turtles and had gone to Honduras and places like that to study turtles, and came back to this program and demonstrated a lot of aptitude for math modeling, intuition, and really engaged me in a lot of really interesting conversations about the atmosphere and how I think about it and how I explain it to people, and definitely had a really big impact on me as a director, especially in that space of how do I communicate science to scientists and non-scientists effectively at the same time. So it was quite helpful in that realm, and he really found a capstone that was synergistic with his strong sense that we all have a right to clean air and society should be more just, combining that with an opportunity to utilize his excellent data analysis skills. So I'm really proud of Michael's project on the Salton Sea. His project is entitled Extreme Heat and Dust at California's Salton Sea, a Public Health Analysis. Michael, the floor is yours.
Okay, thank you so much for that amazing introduction, Corey. Hi everyone, I'm Michael, and my project was on analyzing the combined exposure of extreme heat and dust at California's Salton Sea through a lens of public health. Now I know for me, the Salton Sea has meant a lot to me ever since I first learned about it in my freshman year of high school. But what is it exactly? Well, it's a high salinity artificial lake in Imperial and Riverside County, and it was created in 1905 from a routing accident along the Colorado River, where river water was being diverted, and there was an accident that led to the Great Salton Basin filling with water over a period of 2 years before repairs could be completed. And people thought that this new Salton Sea was going to dry up and evaporate really quickly, but no, it persisted. And it actually became a booming resort hub for people to go on vacation at. And places like Bombay Beach here were actually thought of as potentially being the next Palm Springs. It was that popular. But unfortunately, the Salton Sea gradually became polluted from farm runoff from the surrounding agricultural industry. And this resulted in people fleeing the area and the entire tourism industry drying up dramatically. And it also led to mass ecosystem collapse for the entire Salton Sea ecosystem. Now, I know when I learned about this in high school, I was motivated to one day investigate this and try and come up with solutions for the Salton Sea to try and restore it to its former glory. Now, the Salton Sea has also been drying up more recently due to two main factors. One is the long-term decline of the Colorado River due to Western U.S. climate change trends, but more significantly is the 2003 Quantification Settlement Agreement. Now, this was the largest agricultural to urban water transfer in U.S. history, whereas an agreement between San Diego and Imperial counties that transferred all that agricultural water that had been sustaining the Salton Sea to San Diego in order to support its growing communities. And the Salton Sea's decline was a known byproduct of this. Now, this is really concerning because the Salton Sea receding, as we can see, it accelerates after that agreement was signed in 2003. It poses significant air quality hazards because the sea is so polluted that toxic dust is then exposed to the elements and then can interact with dust storms and then spread throughout the region, which really lowers air quality for the locals. So the main issues at hand that I really wanted to investigate here is that I was really concerned about disproportionate health impacts on vulnerable communities in the area and around drying saline lake ecosystems in general. And this was really an important issue of environmental justice and health equity to me, because these populations that are the most affected are often the ones least responsible for the things that are driving it. So the really low income areas around here are the least responsible for historical carbon emissions compared to richer areas like San Diego County that are driving climate change. And they also had very little say into water management policies like the 2003 QSA. And really, I just thought this project would serve as a case study for compound exposure of extreme heat and dust around these drying salt lake ecosystems as they decline. So think of other areas like Lake Abert in Oregon, or the Great Salt Lake in Utah. This is an issue that we're going to be seeing a lot more of as these lakes decline as climate change gets worse. And specifically looking at compound exposure, it's important because the combined effects of dust and heat exposure results in a synergy where the total environmental hazard posed is a lot greater than just the sum of their individual parts. It has been associated with oxidative stress, a heightened systemic inflammation, and impaired thermoregulation in people, where their heart and lungs have to overwork to maintain themselves. So the main research questions I want to investigate were, how has compound exposure to extreme heat and dust in California's Salton Sea evolved over time? What areas around the Salton Sea are most affected by compound exposure? And is compound exposure of extreme heat and dust disproportionately impacting more vulnerable populations? So what data did I use to go about this? Well, I first consulted the CDC's Social Vulnerability Index. Now, for those who don't know, a social vulnerability index is a scale from 0 to 1, with 1 being the most vulnerable and 0 being the least vulnerable, of essentially how prepared a community is for a natural disaster of some sort. So think of like a tornado or even the pandemic that we all just experienced, or a hurricane. It's essentially a measure of how much outside help that area will need and how disadvantaged they are relative to everyone else. I also consulted two proprietary data sets for daily average temperature data and then biweekly dust concentration for PM2.5. I also used publicly available data sets for census tract layers for the mapping part of this analysis. So what was my methodology? Well, I limited my study period from the beginning of 2005 to the end of 2022 because that was the range my data that I was provided with ended in. And then my study region was the 157 census tracts that are surrounding the Salton Sea that comprise the whole region. All of my compound exposure maps and graphics were coded in RStudio, which is a software development environment. And then all the asthma analysis maps I made were created in ArcGIS, which is a mapping software program. So what are the main analysis definitions to really understand here? Well, when we talk about compound exposure of extreme heat and dust, it's important to set cutoffs so that we know when compound exposure is occurring. So I created two. I did lower joint exceedance and higher joint exceedance. Now, I defined lower joint exceedance as when there's at least 1 day above 89.6 degrees Fahrenheit, or the 85th percentile for the whole region. And in that same biweekly period that's occurring, the overall dust concentration has to be above the 75th percentile. Now, for higher joint exceedance, there has to be at least 4 days above that roughly 90-degree threshold, and then the dust concentration level has to be above the 90th percentile. I also created a dust heat index to see how compound exposure is evolving over time, and it basically resulted in me having to multiply each biweekly dust data point together with the number of extreme heat days in order to get that index. I also separated all of my findings by 2014 Social Vulnerability Index quartiles, so we had 4 groups in total from the CDC data, and this was done in order to assess any disproportionate impacts on communities in the region. And I specifically picked the 2014 data because that fits right in between my study period of 2005 to 2022. So what were my results? Well, here we have a map showing the mean annual extreme heat days in the region. Now, the main takeaway here is that the entire eastern part of the region experienced much warmer than average temperatures a lot more often than the west, especially the northwest. Specifically here, that reddish tract that you see on the lower right, that tract is approaching nearly 80 days out of an average year in my study period that are above that roughly 90-degree threshold for daily average temperature. It's very concerning. And then the spatial pattern we observe for dust concentration is even more stark, where air quality is significantly worse in the southern part of the region for tracts that are directly south of the Salton Sea. Now, this pattern is so distinct that it really begs the question, why are we observing this? Well, it makes a lot of sense when you realize that the Salton Sea is surrounded by 2 mountain ranges, the Chocolate Mountains on the east and then the Santa Rosa Mountains on the west. Now, these act to create a wind tunnel of sorts, so all the dust in the region is blown from the northwest to the southeast and then settles in those tracts that are directly to the south of the Salton Sea. And this poses significant air quality hazards for locals. Now, if we bring a disproportionality analysis into it, where we examine those 4 quartiles of social vulnerability, we see that that most vulnerable part of the population in red is experiencing significantly elevated dust levels relative to the other 3 segments of the population. And this really reinforces this whole issue as one of environmental justice and health equity because they have to contend with worse air quality. Now, if we look at the actual combined exposure of heat and dust together, here's a map of the frequency that we observe over the study period for compound exposure being met. And we see a really similar spatial pattern to the dust map that was presented earlier, where that seems to be the primary association that could potentially be driving compound exposure in the region. But then if we overlay a social vulnerability index with this map, we can essentially look at how social vulnerability index, which is mapped on the y-axis for color coding, and then the cumulative burden of compound exposure, which is mapped on the x-axis, see how that varies on a track-by-track level. And the main thing to take away here is that the intersection of these two is going to be that dark blue region, where those areas are the most socially vulnerable, but then have the highest level of cumulative burden for extreme heat and dust. And it really shows how those same tracks, a lot of which we already observed in that prior frequency map, are really the ones that are the most disproportionately affected, even though they are so vulnerable. Then if we look at that heat-dust index I mentioned earlier, two key findings emerge. One is, again, that upper fourth quartile of the population, the most vulnerable segments of this community, are experiencing significantly elevated levels of compound exposure relative to everyone else. But we can also see that compound exposure is also increasing over time. There's a notable upward trend here where compound exposure has increased over my study period. And that makes a lot of sense because climate change has been getting worse over the 2005 to 2022 study period, but also the Salton Sea has been receding, so more of that lake dust is then exposed to then worsen air quality for the region. So it makes sense that we'd see this trend. Next, I wanted to really investigate and put numbers on the actual disproportionality for how different segments of the population are affected by this. So I did a disproportionality analysis. The main takeaway here is that the relationship observed is that the highest segment of the population for social vulnerability is now bearing 26% greater compound exposure periods than they ought to, given their portion of the population. And this is important because the Salton Sea region already skews toward that fourth quartile, with nearly 33%, or a full third, of census tracts that I observed for the study period being within that most vulnerable quartile. And then this gets even worse when you look at that higher joint exceedance level, where now at these more outlier scenarios for more extreme heat and dust events, that same segment of the population is now bearing 42% greater compound exposure periods than they ought to. And it again reinforces how big of a environmental justice issue and health equity issue this really is. Next, I really wanted to investigate what are the primary demographic predictors that are driving this disproportionality. So I examined socioeconomic status, household characteristics, racial and ethnic minority status, and housing type and transportation. Now we can see that all four of these sub-themes are displaying similar trends to what we observed before, but none more so than for racial and ethnic minorities, where the most vulnerable minorities in the region are bearing 47% greater compound exposure periods than they ought to. And a quick note on the upper right section for that blue quartile, that is a result of an outlier where only 2% of census tracts in the study period actually fall into that, but then they bear about 3% of compound exposure periods. So you get like a skewed result there. But then if we observe the higher joint exceedance level for these subthemes, we can see that the relationship observed gets stronger for all four of them, but none more so than for racial and ethnic minorities, where the most vulnerable minorities are now bearing 66% greater compound exposure periods than they ought to. It's a big issue of health equity, once again. Next, I wanted to examine the actual felt health impacts of all of this. So I clipped out all of the California census tracts in SoCal that are above the state average for asthma rates in adults. And we can see that a lot of the census tracts around the Salton Sea are represented here, but specifically, a lot of them are displaying some of the highest rates of asthma in the state, upwards of 15%, which is just really concerning. And it also aligns well with the prior dust concentration map we observed earlier. But then if you want to investigate disproportionate effects on poor populations, we can then clip out tracts that are above the state average for asthma, but also below the state median household income level. And the pattern that emerges when you sort by income level is that a lot of those same tracts remain from the prior map, but a lot of them are the most lightly shaded on this map, meaning they're the lowest income areas around the Salton Sea. So you can see that they bear a lot of the highest rates of asthma, but are also some of the poorest people in the entire state. It's just really concerning from a lens of health equity. So what are the main conclusions that we can draw from all of this? Well, the main one would be that compound exposure is increasing over time as a result of that dust heat index we observed. The southern region that's downwind of the Salton Sea is one that is hit hardest by compound exposure events for extreme heat and dust. The most disadvantaged communities, such as racial minorities specifically, are bearing the highest rates of co-exposure, especially at that higher joint exceedance level for those outlier events. And then finally, low-income communities that are exhibiting the highest rates of asthma, disproportionately so around the Salton Sea region, which is really concerning if you care about environmental justice and health equity, as I do. So what are the main limitations for this study? Well, pre-2005 and more recent years aren't being represented, which could provide a more holistic overview of how this trend has evolved over time. And then the wider Southern California geography is also not really being analyzed as much. Well, that could have provided a significant contrast to the Salton Sea region itself to sort of highlight how unique the public health crisis at the Salton Sea really is. And I think the most significant limitation is that while I chose that 2014 SVI because it fits right in the middle of my study period, it's not as up to date with modern social vulnerability indexes, and thus can't be really used for current policy debates for decisions for what to actually do about this health crisis. So speaking of which, what is some future work that one may want to do when, after having established this unique public health crisis at the Salton Sea? Well, again, that follow-up study with data from more recent years and prior to the 2003 Quantification Settlement Agreement could provide very useful analysis and a holistic overview here. But specifically, while I've shown a lot of correlation and association between proximity to the Salton Sea and greater compound exposure events, actually proving causation, showing that the Salton Sea's recession is driving these events, would require tracing dust from the Salton Sea lakebed to the surrounding region. And there's been some really exciting preliminary work investigating this, but for this study, that's what would have to be the next step. And finally, I think an investigation into the optimal restoration and mitigation solutions would really be warranted here to actually fix the problem now that we've identified it. You can see on the right here, I have a proposal for water optimization by Mr. Michael Cohen of the Pacific Institute, where he's proposing taking the higher quality inflow water into the Salton Sea and redistributing it via a system of canals into man-made lake beds and ponds around the Salton Sea region. And this would be done before that water can mix with the briny center of the lake and degrade. Now, this would serve two dual functions. One is that it would serve the obvious benefit of ecosystem restoration, but then it would also cover that exposed lake bed so then the dust cannot be kicked up by the winds and then degrade local air quality. It's a really interesting proposal, and I had a great time talking to him about it. So I just want to thank my amazing capstone team, Dr. Alexandra Heaney of UCSD Public Health, Dr. Corey Gabriel, and then also Dr. Wenxin Liu of UCSD Public Health for the data set analysis portion. Are there any questions?
Thank you, Michael. Great presentation.
Thank you so much.
Interesting work, and I like that the impetus for it all was something near and dear to your heart. When you're looking at the Salton Sea and you're looking at the past 20, 25 years, what type of policy implementation or adaptation at the jurisdictional or individual level have you seen? Or are we really just dealing with the hazard as it comes?
So there has been some significant progress more recently. So recently on the southern end of the sea, the species conservation habitat for like ecosystem restoration has been established by the state, and it was actually broke ground last year and was completed very recently. It's a really significant development because there's been a lot of years of inaction on that problem. But there's also been some mitigation efforts done at the area to actually reduce dust exposure. And this main one has been placing hay bales out on exposed lake bed to limit how much dust can be kicked up. Now, a lot of locals don't really like that because they think it like looks weird and they just kind of have a general distrust of government. But those are the two like main things that come to mind for what the state is doing about it. But of course, there's a lot more like interesting proposals, like I just mentioned, that we could be doing instead as well.
Trying to put my phone away, and this man's trying to shake my hand. Sorry for that little awkward exchange of respect there. Great job, Michael. Our next presenter is Henry Chen, and one or many things I could say about Henry, but I want to emphasize that being like an original thinker and getting where you get in terms of the conclusions and the process that you go through is very, very, very hard. I remember when I didn't become a scientist right away, and a lot of that was, I think, my personality type and the way it connected with mentors didn't really work for me. And I think that a lot of that was because I came at things in a pretty original manner. And in terms of the summer project Henry did, he demonstrated a number of vulnerabilities that would exist in a more distributed energy system where people were driving around EVs, using the EVs as batteries, and brought an interest in me that continued throughout the year in how secure is our renewable energy transition. And just a couple weeks ago, I was having a conversation with a senior official in a big corporation talking about some of the risk profile that exists with some of the technologies we're putting on our grid. And some of the initial impetus for me kind of being able to keep up with that conversation was some of the ideas that Henry put forth in his summer paper. And in this presentation, you will see that Henry's going to focus on a topic that impacts everybody directly, their families, in terms of mental health. And climate change is a context that makes life more difficult, and that burden is borne disproportionately. And often we're great at responding to extremely clear, discrete forcings. But speaking as somebody who experienced Hurricane Sandy, seeing the aftermath that had on mental health and community health was not just eye-opening, but terrifying. And this emphasis and the amount of work that Henry went through to find communities that shared attributes, finding opportunities to make relevant comparisons, and putting this issue of mental health in the context of both climate change and heat exposure in a Southern California equity lens. This was hard work, and I'm really proud of what Henry accomplished. Our next presenter, Henry Chen, Heat Governance and Mental Health Vulnerability in Southern California. Henry, the floor is yours.
Okay, hi everyone. My name is Henry Chen, and I will be focusing on extreme heat and mental health governance within Southern California. So, my project evaluates how climate, health, and heat plans and local planning documents address the mental health dimensions of extreme heat. And one of the reasons I wanted to personally focus on this project is because climate change can often feel distant or abstract to many people. And one of the best ways, I think personally, to connect climate change to everyday lives is by connecting it to health. So extreme heat is not just an environmental problem, it affects how people live, sleep, feel, work, and access support. Most heat planning focuses on physical health impacts like heat stroke, heat exhaustion, emergency room visits, and mortality. And while those factors are often important, the mental health dimension is often neglected. So today I'll be starting with a problem statement and then explaining the 3 overlapping vulnerabilities that frame this project: heat vulnerability, mental health, and governance. And then I'll explain the research gap and why governance matters within this context. And after that, I'll be walking through my methods, including the documents I reviewed and the scoring framework I used, and using the main results to create across the 3 jurisdiction pairs and discuss a San Diego spatial prototype for how my findings can be used to frame interventions. Okay. For my problem statement, I'm interested in how these 3 vulnerabilities overlap within extreme heat, mental health, and governance. Extreme heat is increasing as a climate change problem, but heat risk is not just about temperature. Heat waves are becoming more frequent, intense, and longer lasting. Warmer nights also matter because they limit recovery time, especially during daytime heat waves. But heat exposure is not evenly distributed. Some communities have more access to air conditioning, tree canopy, safe housing, transportation, and cooling resources. Others face more outdoor work exposure, older housing, lower income, disability, and higher environmental burdens. So for this project, I treat heat both as a climate and also a social vulnerability. When people talk about extreme heat, they usually focus only on like the physical outcomes. However, as like previously stated, extreme heat also affects mental health in multiple ways, ranging from sleep anxiety, depression, disruption of sleep, substance abuse, and behavioral health crises. And some groups, such as those with pre-existing mental health conditions, older adults, unhoused residents, and socially vulnerable residents, and also people with limited access to healthcare. And lastly, governance vulnerability. And what governance vulnerability means is whether or not local institutions are prepared to recognize and address this risk. So even when heat and mental health vulnerability overlap, these are not the final says, and these are not the final determination of mental health outcomes and related to heat. It also includes whether people can actually access cooling, outreach, behavioral health services, and community support during extreme heat events. It also, this is where my project focuses, using local planning documents to assess whether or not heat and mental health are being addressed within across different plans and agencies. So heat vulnerability indexes, as you may or may not know, are common tools used to identify communities where extreme heat, that face extreme heat risk. And they're used by combining factors like heat exposure, social vulnerability, health sensitivity, adaptive capacity, and environmental burdens. An example of this is Cal Heat Score, which gives zip code level data from scores from 0 to 4, with 4 showing higher scores and greater risk of heat-related illnesses. And although these tools are useful because they show where risk exists, they often have gaps. So one gap is that they don't fully capture governance capacity. And that missing piece is what my project focuses on, using local planning documents as evidence of governance capacity. So the goal here is to assess whether or not governments are planning for heat-related mental health risks through coordination, funding, behavioral health readiness, monitoring, and implementation. So instead of asking only where heat vulnerability is located, I'm also asking whether or not local planning systems are ready to address this risk. And my project is guided by 3 main research questions. To what extent do local climate and heat-related plans address the mental health dimensions of extreme heat? Do plans move away, beyond recognition and towards targeted implementation? And how do jurisdiction pairs offer or differ from their governance capacity to address mental health and extreme heat? So through my analysis, I looked at 3 jurisdiction pairs: Los Angeles City and County, San Diego City and County, and Imperial County and El Centro. And using a targeted literature review, I developed a scorecard of 10 categories that looked at assessing the effectiveness of local heat plans and also mental health. So, scorecard includes 10 categories, which I grouped into 3 broader themes. The first is risk recognition, so including whether or not plans recognize the risks of heat-related mental health risks, identifying vulnerable populations and equity concerns, and addressing long-term and cumulative impacts. The second theme is response capacity. This includes outreach and communication, coordinating with behavioral health systems, and community resilience and social support. The third theme is governance and implementation, including system coordination. So together, this framework asks 3 basic questions. Whether or not plans recognize local heat risks, do they propose support systems, and does governance create the conditions through which these plans can thrive? And this all connects back to the gap of governance capacity, whether or not local planning systems are ready to address this risk. So my methods followed a structured review system. So first, collecting all relevant planning documents from local city and county websites. And then using an application called Atlas TI, assigning all relevant passages and quotes certain categories, such as heat and mental health, like risk recognition, behavioral system capacity, and also whether or not they consider vulnerable populations and equity. After that, scoring each document on based on each category from a 0 to 5, with a 0 meaning no mentions at all, and a 5 meaning that not only is it mentioned, it's fully integrated into heat planning and like mental health. And then after scoring each document level scores, also synthesizing it into jurisdiction levels based on city and county. The reason why city and county receive different scores is because cities and counties are responsible for different roles. So for instance, counties are more involved within behavioral health systems, so making sure that people have access to mental health services during times of crises, while cities are more involved within land use decisions that like directly affect like physical heat exposure. And using these findings and connecting them to a San Diego spatial prototype to show that where interventions are most needed. An example of this, this is an example of a quote from the LA County Heat Action Plan. So this, for instance, this quote in particular merited a 3 out of 5 because it recognizes like the heat and mental health risks, but not necessarily a higher score because it doesn't talk about, for instance, like the targeted interventions you would need to address like these risks. Okay. This is a scoring matrix that shows how each local planning system appears to be on paper. So the darker colors show not only like stronger scores, but like more fuller integration within extreme heat and mental health, while the lighter colors show like either fragmented like areas of implementation or weaker scores. And the takeaway here is that although Southern California is beginning to recognize the trend between heat and mental health, integration differs like across jurisdictions and needs to be like aligned better. So my first finding here is that Los Angeles is the strongest overall, but mental health is still often indirect. So it shows like the most developed integration across like equity, governance, and built environment. So like whether or not they have like access to like green spaces, tree canopy, and stuff like that. However, mental health is still embedded within broader health rather than as like a separate like category and like an issue that can affect not only populations, but resilient healthcare systems. And the second finding is that although San Diego has strong planning infrastructure, has even less mention of mental health in general. So however, what it does have is strong planning tools and like funding and like data evaluation. So I would describe San Diego as, although they don't have strong integration, they have all the tools that they need in order to like address this issue. And Imperial County shows the worst planning gap in general, although it is highly relevant as like a heat, as in terms as a place that is highly heat vulnerable, it shows like weaker integration across like nearly all categories. And here is like San Diego's spatial prototype developed by Connor Mack here at SIO. And what this shows is how heat and depression risks are driven together. And the 3 colors represent heat exposure, and then green represents adaptive capacity, and yellow represents population sensitivity. And the key spatial trend here is that as you go more inland and east, it's primarily driven by heat exposure, while coastal and urban areas show more of a mix between population sensitivity and adaptive capacity. So the key takeaway here is that heat and mental health risk is not driven primarily by heat exposure. It's also driven by how, what populations are effective, and then also how, whether or not they have the resources to adapt. And closing takeaway, across all 28 documents, Los Angeles shows the strongest integration, while San Diego shows uneven integration, and Imperial County shows the largest gap in planning. And overall, mental health is becoming more visible in heat planning, but requires more consistent integration, preparedness, monitoring, funding, and implementation. And 3 next recommendations. So making local heat plans more mental health explicit rather than relying only on general health, equity, or emergency response language. Plans should directly name mental health and heat risks. Second, coordinating with local behavioral health systems. Like for instance, none of the plans mentioned like coordinating with hospitals. One thing that like has been documented widely is like during heat waves, there's an increase of violence, like suicide, and ER visits for mental health reasons, and it's basically having like hospitals and like service providers like coordinate like with each other in order to like address like these surge capacities, and like having healthcare be more climate resilient. And third, using spatial vulnerability to identify where populations are at risks. So one caveat about like the previous map is that it does not necessarily show causality. What it does show is that where the heat risk possibly exists, but it needs further investigation. Okay, and that's my presentation, and thank you.
Hey, Henry, good job. That was a really interesting analysis. As someone who's not from a place where there's as much extreme heat as Southern California, I was curious if there's a way to kind of scale this process that you used for other locations that have other, for example, environmental justice concerns, but maybe aren't extreme heat, or do you feel like this is a very heat-specific type of analysis that you used?
Yeah, so my scorecard is specifically geared towards extreme heat analysis. But I think definitely it can be modified in order to like address like other things. Yeah.
Cool. Thank you.
All right, great job, Henry. Very important topic. Our next speaker selected an incredibly important topic, but I think that just taking a quick step back and recognizing that this is a process, right? Identifying a project. And people come into this program with a lot of interests and a lot of ways to try to connect to their climate problem. And idly vetted a number of really, really, really good capstone ideas, the kind of projects that I'm keeping in my back pocket for future years. And for various reasons, ended up deciding on a project that was very, very applied to the Southern California area, had very, very cognizable stakeholders, and fits very well with the other projects in this theme relating to heat. But just that process that she went to identify the best possible capstone, it's worth sometimes a little bit of uncertainty to end up working on something that ends up really being a fit for you. In the case of this project, this is going to really look good in the context of applying for jobs and also for making people who are looking to hire or make those kind of decisions think, oh, this person recognized a real tangible problem and is proposing kind of an outline of how to mitigate a very important real world problem for a stakeholder we care a lot about. Adeli Shiedenkal, proposing climate resilient design in public schools in San Bernardino County against heat stress using Chalice Mead Elementary and Millennial Tech Middle School as an evidence-based model. Adeli, the floor is yours.
Hi everyone, my name is Idali Shikothenkalt, Thank you, Corey, for that introduction. And I'm really looking forward to share my capstone with you all. It's titled From San Diego to San Bernardino, a heat monitoring and green schoolyard model for heat resilient schools. This project looks at heat in public and school environments, so how we measure it, who bears the greatest burden, and how a model developed in Southeast San Diego can inform heat resilient schoolyard design in hotter, more vulnerable inland districts like San Bernardino County, located here in California. So extreme heat is becoming a much bigger issue for schools in California, and it matters far more than just comfort. It affects students' health, attention, learning conditions, and really the day-to-day functioning of school spaces. This is important because children experience heat very directly through the places they move through every day, such as their classrooms, their lunch areas, their playgrounds, and other outdoor spaces. And that's why this issue matters. More than 2.5 million students in California attend schools with less than 5% tree canopy, and San Bernardino County is one of those regions where they're also projected to have about 131 days each year above 90 degrees by 2050. And historically, red line neighborhoods, where many of the schools most affected by heat are located, have on average about 37% less tree canopy than non-red line areas. So these statistics point to what heat actually looks like in school settings. It can look like, for example, children spending time on asphalt play areas that can reach between 150 to 165 degrees on hot days, in schools in underinvested neighborhoods trying to manage heat with limited shade, canopy, and uneven cooling infrastructure. And this picture that I took shows exactly that. This is from one of my school sites in San Diego, Cholla Smith Elementary, showing the turf these kids in the picture were playing on was 139.5 degrees Fahrenheit, taken on a day that was relatively cool. That is why extreme heat in schools is not only a climate issue, but an environmental justice and equity issue, because the campuses facing the greatest exposure are often the ones with the fewest resources to respond. And that leads to my central research question: how can evidence from heat monitoring, climate education, and design interventions at San Diego school sites be used to build a transferable model of heat-resilient schoolyards that is compelling and feasible for districts like San Bernardino? This question runs through 3 threads throughout this project. The first is to measure, so documenting microclimate heat variability across indoor and outdoor spaces. The second one is to understand, so analyzing the equity dimensions of who is most exposed and why. And then the third is to transfer, so developing methods and findings that can be adapted in higher heat inland communities where the need is even more urgent. And my capstone focuses on 2 public schools in Southeast San Diego, Cholla Smith Elementary and Millennial Tech Middle School, both within San Diego Unified School District. Cholla Smith serves about 530 students in grades K through 5, and as you can see in the charts, over 81% of students are Hispanic or Latino, and 503 out of those 530 enrolled students are classified as socioeconomically disadvantaged. As for Millennial Tech Middle, they have about 378 enrolled students in grades 6 through 8 with a similarly diverse student body, and 338 of those students come from socioeconomically disadvantaged backgrounds as well, coming from data taken this past year. And both schools sit in historically underinvested community with limited tree canopy in hotter neighborhood microclimates where these schools are representative of hundreds of schools across California where the conditions for heat risk already exist. And this project uses an environmental justice lens built on 4 connected ideas to show how heat risk in schools is a triple jeopardy of higher exposure, greater susceptibility, and a lower capacity to adapt for historically disinvested communities. First is unequal heat exposure. So about 94% of historically redline urban neighborhoods show higher heat levels than non-redline zones. Redlining didn't just shape housing, it shaped who has trees, who has shade, and who lives in the hottest part of a city. The second is schoolyard disparity, so schools serving low-income students and students of color are far more likely to have minimal canopy and more asphalt, reflecting the same patterns of disinvestment, but at the campus level. Third is health vulnerability, so these same communities have higher rates of asthma, diabetes, and other pre-existing conditions that amplify heat risk and other cascading issues. And then fourthly, a policy gap. So as of 2026, neither San Diego Unified nor San Bernardino County Unified has an active heat protocol section in their school safety plans, even though the state has issued heat guidance for schools, and agencies such as OSHA has heat illness prevention standards. So the policy tools do exist, but local adoption is currently behind. And now moving on to the methods for my project, I deployed hobo temperature sensors at both campuses for over a full school week in late April and early May. At Choice Mead, I placed one sensor in a relatively cooler classroom and one in a relatively warmer classroom based on staff input, and a third sensor was placed in a common outdoor student play area between a soccer field and an open exposed playground. The goal was to capture the range of heat that students actually experience moving between indoor and outdoor student spaces during a typical school day. And at Millennial Tech, I followed a similar approach, so one sensor in a cooler classroom, one in a warmer classroom, and placed the outdoor heat monitor near the student drop-off zone and outdoor lunch table area. This allowed me to compare not only indoor versus outdoor conditions, but to also see how different kinds of outdoor student spaces vary over the course of a week. And here is the actual monitoring data collected from both schools. Choice Mead is on top, Millennial Tech is at the bottom, and each campus shows 3 lines. Blue is the outdoor temperature, orange is the warmer indoor classroom temperature, and yellow is the cooler indoor classroom temperature. You can see the blue outdoor line spiking and dropping sharply each day, while the orange and yellow indoor lines are almost flat by comparison, staying in a much narrower band. That contrast showing the outdoor variability with the buffered indoor stability is the central story of this finding. And now going on to focusing on that blue outdoor line, I want to point out 3 things. So at Choice Mead, the outdoor sensor peaked at 86 degrees Fahrenheit on April 30th. At Millennial Tech, the outdoor lunch and drop-off area hit 84 degrees on May 1st and May 2nd. And lastly, across the monitoring week, the daily outdoor swing from early morning lows to afternoon peaks was roughly 20 degrees Fahrenheit every single school day. And what makes that significant is timing. Those afternoon peaks happen between noon and 3 p.m., which is exactly when students are outside for lunch, recess, and transitions between classes. So the hottest part of the day and the most outdoor student exposure overlap almost perfectly. And I also want to note that this was a relatively cool, partly cloudy week in early May that I took these samples, and that these peak temperatures would be considerably higher during a summer heat wave or a hot September week at the beginning of the school year. Moving on to the indoor findings, looking now at the indoor orange and yellow lines, 3 patterns also stand out. First, you can clearly see the buffer. During afternoon peaks, indoor classrooms are about 5 to 10 degrees cooler than the outdoor zones. And on moderately warm days like these, the building itself is providing a protective barrier through aspects such as insulation, room orientation, and window shading that are all contributing to this. Second, looking at the warmer classroom orange line at Choice Mead, you can see that it tracks the outdoor curve more closely than the cooler classroom does. That's the sun-exposed roof effect. Rooms on the south or west side of older buildings absorb and transmit outdoor heat indoors. The cooler classroom has more protection from its position and orientation. This tells us that building design choices are already shaping who is more or less exposed even inside the same school. And third, and this is the detail that I find most interesting, looking at Choice Mead on May 5th and May 6th, the outdoor blue line dips at midday compared to the other days displaying cloud cover, so temporary natural shade measurably reduced the outdoor peak temperatures. That is exactly what tree canopy and shade structures can do, but in a more permanent way. Here, that data is just making that supporting design argument for me. So what does this monitoring tell us about schoolyard design, and how does it connect to work already happening at these campuses? Well, at Millennial Tech, Earth Lab is a 4-acre climate action park serving as an outdoor classroom where students engage in STEAM learning and climate education to help students and community members develop strong environmental and community stewardship. At Choice Mead, Nature Play is a green pilot project transforming an asphalt playground into a nature-based area. This project focuses on transforming a canyon-adjacent school playground into a play area and trail that provides shading structure and habitat restoration. Both projects at these 2 campuses are actively beginning to replace asphalt with trees, shade structures, and nature-based surfaces, using community-driven design to implement climate-ready infrastructure to reduce impacts, which I think is really incredible. This leads to what I see as the transferable model emerging from San Diego. What distinguishes the San Diego case is that it integrates 3 things: heat monitoring, generating campus-specific evidence of heat exposure, and using that evidence to guide shade, trees, and surface changes. And lastly, climate education, all grounded in community partnership, engaging students, families, and community organizations throughout. These partnerships between UCSD's Center on Global Justice, Groundwork San Diego, which is a local nonprofit, students, families, and school staff is what really makes this work. Students aren't just recipients of a cooler schoolyard, they're learning about heat, watershed ecology, and environmental justice through the schoolyard itself. Their lab, for example, becomes both the infrastructure and then the curriculum. And showing the pictures here on the screen, on the left shows pictures from MTM during their STEAM night, where students and their families come together for kids to show the current projects that they're working on. One of these projects, as you can see in the picture here, shows a model of MTM and the neighborhood surrounding the school. It shows the type of neighborhood that kids want in their own region. They added more green space, solar panels on more buildings, more bike lanes, and just set goals that they want to envision their local community to look like. And on the right hand shows Choya's Mead's heat mapping activity, where we went and talked about heat within their own campus and had kids use surface temperature guns and FLIR thermal cameras connected to iPads so that students can see how heat affects them and have them write their own observations, showing the difference that shade and open exposure have. This integrated model where we measure, design, and educate together is what makes it transferable. It isn't just a technical solution, it's more of a community-owned one. And that brings me to San Bernardino County, which I'm treating as a parallel higher stakes inland application site. As I mentioned earlier, by 2050, San Bernardino is projected to have 131 days above 90 degrees, but also have 35 days above 102 degrees Fahrenheit. Additionally, more than 300 warehouses sit within 1,000 feet of schools, creating what is known as a diesel death zone that compounds heat with air quality harm. And between 2018 and 2022, the county lost more than 25% of limited schoolyard green space it already had due to industrialization. The populations at risk look very similar to Southeast San Diego: low-income communities of color, under-resourced schools, and rapid population growth in areas such as Apple Valley, Victorville, and Hesperia, where families have relocated for affordability. What transfers from San Diego are the methods, so the sensor methodology, the heat mapping approach, the community-engaged design process, and the ability to link this to state funding. However, what has to be built first is trust and sustaining partnerships with local districts, community organizations, and local communities, which are key. And I want to close with 4 brief policy takeaways from this project, not just what schools need in general, but what this project suggests about implementation. First is to add heat protocols to school safety plans. Neither district has one, as I mentioned earlier. California CDPH heat guidance and Cal OSHA's heat illness prevention standards already exist, so this is a matter of local adoption rather than just implementing new policy. Second is using campus heat sensor data to drive investment decisions. So the value of microclimate monitoring isn't just knowing that it's hot, it's having evidence to say that this outdoor zone at this school exceeds certain safety thresholds for children during a certain time of school day or school year. And that's the kind of data that can prioritize structures, solar canopies, tree planting, and HVAC upgrades throughout most exposed sites. Third is leveraging fundings from programs such as California's Climate Ready Schools Framework and CAL FIRE Green Schoolyard Grants. Campus-level heat data makes a compelling case for why high-risk schools should receive these investments in the first place. And then lastly, it's building community partnership before anything. The San Diego model works well because it's trust-based and community-driven, and any expansion to San Bernardino must be built that same way. And I want to end by thanking my capstone committee. Thank you, Dr. Mark Merrifield, my chair. Thank you, Dr. Kyle Haynes from the UCSD Center on Global Justice. Thank you, Dr. Muriel Robnowitz-Bussel from UCSD's Urban Studies and Planning Department. And then thank you, Dr. Tariq Ben-Marnia, also from SIO. I also would like to thank the Julia Brown Fund for helping me sponsor my heat monitor so that I could be able to do this project. And then I want to thank Corey and Jada, and then lastly, thank my amazing, incredible cohort. It was a privilege working with you throughout this year.
Good morning. I wanted to thank you for that incredible presentation. With underserviced communities and these schools, a lot of times, a lot of the administrators and teachers are overtasked and don't have time to submit the grant proposals and go after this funding. So what policy recommendations or community engagement would you recommend to help bridge that gap for these overtapped schools to get the funding to implement these programs?
Yeah, it's a great question. I think just like modeling my experience working with San Diego school sites, I worked with the Center on Global Justice with Kyle. He has a bunch of fellows that work with teachers and other people working together just to help fund things and like move things along and even be involved with school activities. So I think just the foundation is just making sure that you have as much people involved in order to be able to prove that this is worth caring about and to like basically pitch it to like investors and like policymakers, because I think community is what drives action.
All right. So we are in a city right now, or sprawl, depending on from the East Coast. I don't know if you really consider this a city per se, but it's definitely sprawl. And, you know, going back like Industrial Revolution, like 1850, right? So even mid-19th century, people were losing touch with their outdoor environment. I started with that story about Denora, Pennsylvania, right? People working in a steel mill in a company town, in debt to the company store. Not much interaction with nature, definitely not growing their own food and stuff like that. So in this urban concrete jungle, kind of we get lost in terms of, you know, go to a Whole Foods, find blueberries any time of year or whatever you want. But people actually have to grow the food, interact with it. And while global supply chains are what they are, and it might not be the cheapest tomato that you ever eat, maybe the best tomato you ever eat will be grown here in San Diego by a small farmer. But this idea of communities staying in touch with both methods of keeping their land resilient, but actually growing stuff and keeping that cultural heritage and appreciation of an agricultural community and an area that is historically agricultural, keeping that alive and making it more resilient in the face of climate change is an incredibly important local objective. And throughout this program, Lainey's dedication to this project and focus on her work and doing everything, honestly, the right way and following through and just nailing it on this project, and pretty much everything she did is both impressive and also, for me, who's doesn't have green thumbs and has not done so well even trying to grow like a cactus. The amount of real impactful like messaging and connection that knowing that this is going on in this community and kind of consumer decisions that I might make because of projects like this and other projects like this, really important and interesting, and I'm just very excited that agriculture can be part of this program. We're not in the Central Valley, but we are in an area that has, I think, a richness of crops and that doesn't exist in many places. So cool project, cool place to do it. Lainey Bloom, Urban Agriculture and Climate Resilience, a thematic analysis of urban farmer perspectives in San Diego County. Lainey, the floor is yours.
Thank you so much for that introduction. That was so lovely. Okay, well, hello everyone. My name is Lainey Bloom, and today I'm going to be sharing my research on urban agriculture and climate resilience, where I focused on the perspective of urban farmers across San Diego County. So climate change is increasing the frequency and severity of impacts like extreme heat, wildfire, and flooding, and this is threatening both the health of people in cities and the systems we rely on to grow, transport, and access food. So much of the food in cities like San Diego is produced far away and then has to move through these long, complex supply chains before reaching our tables. So this makes food access sensitive to disruptions in both transportation and farm conditions.
Food systems are also concentrated into large industrial farms that use lots of water, chemical inputs, and grow the same crop for acres. Practices like this weaken the land and make farms even more exposed to those increasing climate impacts. And because food systems are so centralized and interconnected, disruptions in one part of the system can affect food availability far beyond where they originally occur. The COVID-19 pandemic made these vulnerabilities especially visible when labor shortages, transportation disruptions, and severe winter weather combined and contributed to empty grocery store shelves and rising food costs. The pandemic demonstrated how overlapping disruptions can affect food systems in ways that are expected to become a lot more common with climate change. At the same time, the pandemic also highlighted the importance and strength of local and regional food systems. Across San Diego, local farmers and food organizations were able to come together to support communities through both food production and distribution. So the need for strengthening resilience at the local level and the potential for it became very clear at this time. Climate resilience in food systems means being able to continue producing food and supporting communities despite climate-related challenges. One way to strengthen resilience in urban areas is through urban agriculture, meaning the farms and gardens that are located within and around cities. Urban agriculture can reduce dependence on those fragile supply chains by growing and supplying local food and flowers. And urban farms also provide these spaces for social connection, education, and cultural knowledge sharing. They bring ecosystem services, like cooling down urban environments with green space, or providing water retention and carbon storage in plants and soil. But all of this potential depends on farmers being able to adapt to climate change themselves. And here in San Diego, urban farmers are already doing that through practices that support both ecosystems and communities. But at the same time, they're facing significant structural barriers to this resilience. So in San Diego, there are community-based programs that are supporting urban farmers who are working to build this climate resilience. And over the past year, I had the opportunity to work directly with urban farmers as the program coordinator for Growing Equity. This is a climate resilience and health equity initiative led by UC San Diego Center for Community Health. The program currently supports 15 urban farms and gardens across the county by providing them with funding and technical assistance for their projects that are advancing all sorts of things like food access, education, and environmental stewardship. And Growing Equity defines urban farms as located within 25 miles of a population center of 50,000 or more. So this includes a wide range of growing spaces across the region. Participating farms are also located in or are serving communities that are disproportionately impacted by environmental and socioeconomic challenges, and so this makes climate resilience especially important in these service areas. As I worked with the 15 farms through Growing Equity, I became increasingly interested in the knowledge and experiences that they hold around climate resilience. Farmers are the ones observing environmental change firsthand while continuing to adapt, grow food, and support their communities. But the lived experiences and knowledge of urban farmers are often missing from conversations and research about climate resilience. And because this topic is so dependent on local conditions, I wanted to better understand if and how urban agriculture contributes to climate resilience in San Diego County from the perspective of urban farmers actually working here. So at the beginning of this research, I asked the questions, how do San Diego urban farmers perceive and contribute to climate resilience? How is climate change impacting their work, and how are they responding? And what support and resources do they need to strengthen resilience? To center farmer perspectives and answer these questions, I conducted in-depth interviews and site visits with 10 urban farms from the Growing Equity program, along with an interview with one technical assistance provider from an organization that supports local farms through distribution networks and climate resilience programs. The farms represented different operations and community roles across the county, and this included commercial produce and flower farms, nonprofit and educational growing spaces, and tribal farming initiatives. As you can see on the map here, farms ranged from inner city neighborhoods to more north inland areas like Ramona. And visiting these farms gave me the opportunity to hear directly from farmers about their experiences and see their work firsthand. I also got to do some fun things along the way, like meeting Honey the cow, who you see here. And I then used qualitative analysis to identify themes that were emerging across the interviews. So those findings are what I will be sharing with you today. One of the strongest themes across interviews was that farmers experience climate change through this increasing unpredictability in their growing conditions. In this chart, the bars show how many participants discussed each impact, while the dots are representing how often the topics were brought up. So looking at environmental impacts, temperature extremes, and shifting seasonal patterns like the very short winter we experienced this year were discussed by every participant and were brought up the most often. Farmers also referenced water availability and quality challenges, flooding, wind, changing pest activity, and for 2 inland farmers, increasing fire risk. And these environmental changes cause real consequences. So for economic and operational impacts, you see crop and income loss was the most frequently discussed outcome, and this was followed by increased labor demands and production costs, infrastructure damage, mental stress, farm relocation, and having to shift event timing. This shows that climate change is making it harder for farmers to sustain their operations and their livelihoods. Farmers connected climate impacts directly to the damage they cause. So some examples of this were extreme heat and shifting seasons contributing to crop loss, or Santa Ana winds damaging infrastructure like this shade structure. Flooding and water challenges became severe enough that 2 farmers relocated from previous growing sites altogether. And farmers noted that responding to these conditions requires significant time, money, and mental stress. A quote I want to share with you all was from a flower farmer. They said, "I can't help that my favorite roses are going to bloom in 2 weeks when they're supposed to bloom in May. And now they're going to be short and not sellable, and they're not coming during wedding season. And so that affects my bottom line and my ability to have staff and pay myself." Even with all of these challenges, the farmers I spoke with are actively adapting and are so deeply committed to their work. When asked what climate resilience means to them, a majority of participants framed it as being able to prepare for uncertainty and continue operations under changing conditions. A commercial produce farmer said, "It means being able to mitigate that chaos and finding ways to protect our crop so that we don't get those massive crop losses when unpredictable weather arrives." 2 tribal farmers described resilience as restoring relationships between people, ecosystems, and the land over time. One of them said, "Climate resilience is not just the ability to continue producing crops under stress, it's the ability of the land itself to remain in balance and continue supporting life." So it was really clear to me that these different framings of resilience relate to the kinds of adaptation strategies that farmers are using. And they're really using a layered approach that combines both immediate adaptation and long-term ecological strengthening. 10 participants described infrastructure investments as important tools for responding to climate stressors. Things like high tunnels, shade structures, and ground coverings create this kind of buffer zone that can then protect crops from extreme heat, wind, frost, and overall temperature variability. And all participants emphasize ecological farming practices as central to their long-term resilience. So farmers describe building healthy soils through practices like composting, mulching, reducing their tillage, and keeping soil covered. And they're conserving water through drip irrigation and water reuse. And together, these practices help retain moisture and support crops that are better able to withstand heat and drought. Many also increase biodiversity on their farms by growing a variety of crops and native plants. And this makes it so that if one crop is struggling under changing conditions, the entire farm isn't just going to fail. And farmers are constantly observing their land and then adjusting what they grow and when they grow it. And all of these practices are not only helping farmers adapt to climate change, but this is what's providing some of those community benefits, such as carbon storage, habitat support, and urban green space. So when continuing to discuss their role in community resilience, many farmers focused on how they expand access to food and flowers through things like farm stands, food bank partnerships, and other local distribution efforts. And farmers emphasize that access means not only having crops available, but making them affordable and culturally relevant. Several farmers discussed the resilient access that their farms can provide and described the pandemic as a real-world example. So one farmer recalled, "It was the weirdest time to be a farmer because I've never experienced that where people are knocking the doors down in demand of your produce. Anytime there's a supply chain disruption, local farmers theoretically have the most capacity to respond." Another way farmers described building resilience was through education and knowledge sharing. Many farms teach people how to adapt to changing conditions by offering internships, apprenticeships, and community events. As one educational farm explained to me, resilience is about anticipating variability and training our students to troubleshoot, pivot, and keep moving forward. So it was clear to me that these efforts are building resilience through knowledge across future generations. The resilience that local farms can provide depends on the ability of farmers to adapt to climate change, and many describe that a lot of challenges can get in the way. The most commonly discussed barrier was financial strain. Small farms are already operating with very limited profits, and the added costs of climate adaptation can be difficult to take on. Grants can help, but funding is often limited, restrictive, or difficult to access. And farmers noted that complex applications can be difficult and timely to navigate. Farmers also described the ongoing time and labor that's required to maintain these resilience practices, while many of them are operating with very limited staffing or volunteer labor. And high land costs and uncertainty around long-term land access, especially in these more densely populated areas of San Diego, make it difficult for farmers to invest in long-term resilience because they're not sure how long they're going to have their land. While there are significant barriers, many farmers talked about programs that help make long-term resilience practices more achievable. Multiple farmers described participating in a local climate-smart incentive program, which supported practices like compost application and soil building. One farmer explained to me, someone would come out and verify, "I'm applying my compost," and then it was just this bonus of income that could be reinvested in the farm. I think that's a big thing nationwide, where people are seeing farmers being paid for environmental services that they're contributing to, which helps us do more. Along with incentives, farmers also emphasize the value of flexible funding programs like Growing Equity that allow them to invest in the projects and practices most needed on their farms. Based on this research, building climate resilience requires stable, long-term support. Many of the strategies farmers are using take years to establish, but the funding and programs that support them are often short-term and vulnerable to budget cuts. Farmers describe needing flexible funding that's paired with technical assistance and reflects the realities of their different farms. And local governments in San Diego can support this work by incorporating urban agriculture into climate resilience funding and reoccurring budgets. This research also highlights the importance of place-based support. Climate conditions vary across San Diego County, so resilience efforts are most effective when they are building on local knowledge and conditions. And resilience depends on ongoing community support, consistently purchasing local food, volunteering, and investing in local farms can help ensure these communities remain viable in the face of climate change. So we have seen urban agriculture contributes to climate and community resilience in so many ways, and farmers have the knowledge they need for it. They just need long-term support to sustain it. Centering the lived experiences of farmers reveals the resilience benefits of urban agriculture that are often overlooked in funding and policy decisions. Farmers understand what's at stake if their farms can't survive, and so should we. The last quote I will share, a farmer said, "If we're not climate resilient, we're going to lose these spaces, and then the quality of life in our neighborhoods and the health of the children growing up in our communities immediately degrades." So my biggest takeaway from this research is that if we want resilient local food systems in the face of climate change, then the systems supporting farmers must themselves become resilient. I'd like to thank my committee, Dr. Amy Lerner, a professor of urban studies and planning, and El Mari, who leads Growing Equity, as well as the CSP program, and my cohort. I'm so grateful for all of these people's guidance and encouragement, and to the farmers and community partners who generously shared their time, experiences, and knowledge with me throughout this project. So grateful. Thank you.
Thanks, Lainey. That was fantastic and so insightful. I know that this has really been a passion project for you and you've been involved in this work for a while. So I was wondering if you could talk about some of like the other local orgs or initiatives that are going on in San Diego to support these urban farmers and everything that you're talking about today.
Yeah, thank you. So a lot of these farmers are a part of an organization called Food Shed Cooperative, and it's kind of an organization that will take on the purchasing from these farms and then distribute it to food banks and other communities in need. So that has created a really stable market channel for farmers, because that can be kind of the hardest part, finding customers and consistent purchases. And then I would say another really important one to mention is San Diego Food System Alliance. We don't have like a local food policy group in our county, so they've kind of taken on that role and lead most of the policy and advocacy action by bringing farmers and policymakers and community members into the same room to guide those decisions. And they've actually created a plan called Food Vision 2030, which is really up-to-date policy here.
Great job, Laney. So when I interviewed for this job, it was like a 4 or 5 part interview that was pretty exhaustive. And the final portion was the 2017 CSP Capstone Symposium. I would start as the director about 6 weeks after that. And one of the projects presented that day was by a student named Amy Knight. And it was about the 6th grade curriculum. I believe 6th grade was it, in California, and adding a climate or improving a climate change requirement that is part of that program. And that project was really, really good. And it gave me this program, I think there were 7 students that presented that year. And it was still a growing program. And that project was essential for me to see the potential of this program. And one other student in the program, I'll mention, Amy, that student, 3 years later during COVID, I needed a TA that was like a professional teacher. So I brought back Amy Knight, and she was the TA 3 years later, and she recommended somebody who was in her cohort to teach a week during the summer of math to kind of bridge the atmospheric science, oceanography, and give people the kind of math tools that they need to do well in the physical basis class of climate change people here take in the fall. And that was Amy's classmate who recommended that, Amy who recommended her classmate, Zach, who's still with us 7 or 8 years later. And I think that started and then, one of the first projects I ever did was education related here, starting the climate change studies program with the late and amazing Jane Taranis, and who, contributed massively to this program. And the tone that was set by Amy and her committee, some of whom are here today, about making sure that this program never lost sight, not just of educating the students in the room, but helping to enable educators, whether it be high school, elementary school, informal educators, thinking back to 2022 Elliott Project, mountain tour guides, help people, educate people in formal and informal settings about climate. And Ryan took on a really robust framework for this and thought of something and a way to engage, not necessarily directly going for the lever of people, but the lever of how do you get teachers and curriculums, but also how do you really entrain teachers to care about this and teach about climate change and climate change resilience. And the kind of engagement that Ryan had with the formal education community is just another excellent example of that history and legacy of making sure that we contribute to the way people learn about climate outside of this room is carried on. So Ryan's project is Building the Foundations, a micro-credential framework to support climate resilience CTE pathways in California. Ryan, the floor is yours.
All right, thank you very much for that, Corey. I appreciate the introduction. Hi, everybody. My name is Ryan Henry, and this is my project titled Building the Foundations, a Micro-Credential Framework for Climate Resilient CTE Pathways. To give you a brief overview of the contents, we'll first start with some background information, then move into the issue at hand, then the framework that I've created, and then finally some future implications for this work. The window of opportunity for this project starts in 2022 when California passed the Golden State Pathways Program Act to distribute funding to California public high schools for the growth and establishment of career technical education or CTE programs. The act allotted $500 million for the development of these CTE pathways with high priority in education, computer science, healthcare, and STEM climate resilience, which is the focus of this presentation. Districts applied for a grant to upgrade their CTE pathways or to create entirely new pathways. That was up to the discretion of the district. Grant decisions were publicly released in October of 2025, which brings us pretty much up to date to today. So CTE, or career technical education, originated to prepare students to work primarily in the trades, but has since evolved to encompass pathways to technical jobs, as well as post-secondary and secondary opportunities. Students who participate in CTE programs complete a sequence of courses throughout the 4 years of high school that combine the core academic knowledge needed to graduate with a diploma with additional courses specific to their sector that they've chosen. At the end of a pathway, the student receives a certification in recognition for completing all of the required courses. The classes a CTE student takes are determined by what's called the model curriculum standards, which outline what knowledge is required for a career in their selected industry. The curriculum standards that guide development of CTE pathways are state-specific, so California has its own model of industry sectors. In the bubbles on the screen there, you see two examples, the energy, environment, and utilities sector, as well as the agriculture and natural resources sector. Notice that climate resilience is not listed in either one of those. A crucial part of CTE is the collaboration between school sites and industry partners that provides hands-on learning experiences to students. This is a map that I've made that shows the breakdown of the schools that will be implementing STEM climate resilience pathways throughout California. There are 7. We have 2 in San Diego County, 3 in Orange County, 1 in Santa Barbara County, and 1 in Mendocino County. You can see the spread of them on this map, and then the upper corner is a zoom in of the Orange County schools so you can see them better. The issue at hand here is that STEM climate resilience as a CTE has not existed before. These schools that are planning to implement it are now going to have something brand new with no precedent on how to teach it. And there will be educators who, while qualified and experienced teachers, will now be involved in something that they might not have very much expertise in. The creation of both the Golden State Pathways program and climate resilience as a pathway exists to prepare students for possible future careers. And the addition of the STEM climate resilience pathway is a great opportunity to expand access to both climate literacy and climate careers for young people in a time when working in climate is absolutely crucial. Up until now, there has not been the expectation that teachers are experts in climate resilience, and thus educators will need to be prepared to take on this new and unfamiliar topic. Since this project is in the beginning stages, creating a clear structure now will make it a whole lot easier to expand this pathway as well as others later down the line. The question that I'm both asking and answering with this project is, how can we make this transition easier? To address this question, I've created an adaptable framework to guide the design of a micro-credential program that will support the educators involved with STEM climate resilience CTE pathway so that they can be better prepared to teach climate resilience to their students. A micro-credential is a short course designed to establish competencies in a specific subject area. The concept first originated in the computer science field about 20 years ago, but has since then been making its way into other professions. These courses are offered through accrediting institutions and accumulate in the participant receiving a certificate or a digital badge that signifies that they've completed all of the assigned competencies. For educators, micro-credentials can serve as a professional development training, which is required to happen a certain amount of times a year. And then receiving the credential or digital badge can also provide the teacher with the opportunity to gain additional units and subsequently a salary increase. A micro-credential in this context should equip educators with specific content area knowledge, as well as provide them with tools in the form of lesson plans or class activities that they can take back to their classrooms. That's why microcredential is so valuable. It goes beyond the simple relaying of information to provide tangible resources to educators teaching these topics. This is a visual representation of the framework that I've created. This is the Foundations framework, and I'll refer to it as Foundations throughout the rest of this presentation. Foundations is made up of 3 concentric circles that I'm calling modules. The first module, represented here by the innermost orange circle, covers the mechanisms of climate change. That asks, what are the driving factors behind this project, and how do Earth systems respond? The second module, which is shown by the green circle, covers solutions to climate change, and that asks, what can we actually do about it? And the third module, seen in blue, is called Local Opportunities, and that asks, what kind of climate resilience careers are available locally for students to pursue? Modules 2 and 3 allow for some differentiation in content depending on regional differences. So, for example, climate issues and the applicable solutions in Santa Barbara might be different than those in Mendocino. Content on climate solutions and local opportunities for climate careers should also reflect these differences throughout the course. To zoom in on each of the modules, starting with Module 1, the goal of this is to understand and explain what physical processes are driving climate change. So content included in this module is the enhanced greenhouse effect, controls on greenhouse gas emissions, the carbon cycle, climate feedbacks, ocean circulation warming and acidification, as well as climate modeling. The content included in each module is meant to be flexible, as I've said. However, there are continuities, and Module 1 is intended to remain fairly consistent throughout the onset of the course, because this is the basis for the rest of what we'll learn. Module 2, Solutions. The goal is to understand the difference between adaptation and mitigation and to be able to explain a few examples of both. The examples you see on the screen here are ones that I've chosen for today, but are by no means the only options for what can be taught. Renewable energy and decarbonization should remain constant in this module, regardless of regional differences, but ecosystem restoration and urban greening are just some of my favorites that I put up for the sake of example. Module 3 is local opportunities. This is where we apply learned knowledge of the climate mechanisms and solutions from modules 1 and 2 to an example of a local career opportunity. A crucial part of CTE learning is the exposure to hands-on experiences that students get. In this module, educators will have a similar experience by visiting with a community collaborator and exploring the climate resilience careers available in that area. This increases the awareness of what kinds of careers students might want to pursue as they move through this pathway. For our purposes today, we're using an example that I'm familiar with, but regional partnerships can span just about anything. Another example could be a construction company retrofitting buildings for energy efficiency. The example on the screen here is a visit to Kendall Frost Marsh Preserve, which many of the people in this room have done, where educators would explore wetland functions like biodiversity, water filtration, and carbon sequestration, and how that has impacts for the local and regional specific climate risks. So in a low-lying coastal area like San Diego, sea level rise, storm surge, and flood frequency are all very much concerns. This is an opportunity to explore the ongoing research, as well as find out what skills and credentials are required for a career in that sector. As I mentioned, assessment is a key part of the micro-credentialing process. This is how accreditors verify that participants have mastered the competencies and are ready to teach them. Foundations uses 3 levels of assessment throughout the process. Starting at the top with formative. A formative assessment is a pre-quiz and asks, what do you already know about this topic we're about to explore? An example of that can be explain the greenhouse effect in 2 to 3 minutes. And then summative assessments next on the list. That does a short recap, so it asks, what did you learn and how have you applied it? Formative and summative assessments both are intended to be included in all 3 modules, once at the beginning and once at the end. And then the cumulative assessment is an end-of-course recap that reviews all 3 modules, and that asks you to draw connections between the mechanisms, solutions, and local opportunities for careers. That is meant to take a little bit of a longer form, but again, can be flexible depending on the accreditor. So maybe a content exam, a longer writing assignment, or some sort of visual project could be examples. I'd like to walk you through a quick example from one of the modules. So each module is also broken into sections. This is an example from Module 1, Section 3. And that content is greenhouse gases and climate feedbacks. So the key subject material for this section covers controls on greenhouse gas emissions, the global warming potential for each greenhouse gas, and the atmospheric lifetime of greenhouse gases. And then after covering that, it moves into climate feedbacks, so snow ice feedback, cloud feedback, and water vapor feedback, and the effects that those processes have on amplifying climate change. There's then a group activity that is meant to elaborate on the learned content. For this section, the activity is a jigsaw, which means that participants are broken into groups and then assigned a specific area of the content that we've covered to do a deep dive. And then at the end of that, all the groups come back together, combine their research to reveal a big picture of what's happening with climate. The activities included in each module were specifically made for the teachers taking this micro-credential course, but they are easily transferable to a classroom environment. Additionally, at the end of each section, there are more resources for classroom application. There are other example activities and lesson timelines so that educators are walking away with not only a greater understanding of these processes, but also physical resources to aid in their teaching. There are some limitations here, especially given that all of this is relatively new information. Firstly, that course requirements and the model curriculum standards for climate resilience have yet to be announced. California State Board of Education is going to be voting on changes to its industry sectors and the corresponding pathways later in this year, so at which point the framework that I've developed will likely need to be reevaluated to align with those standards more closely. Something else important to highlight is the necessity of collaboration between implementing districts. As I said, there are 7 schools implementing this pathway, and that's 5 different districts. So assuming that a micro-credential of this type is adopted, there will need to be some sort of continuity in between the accrediting institutions. We're expecting standards for students to be universally adopted throughout the state, and thus professional development for the educators teaching to those standards should also be very closely aligned. Of course, we're adjusting for those regional differences. In terms of applications for use, this framework, as I said, it's expected that the model will be adapted to align with standards once they are released. Foundations was designed with the intent to be molded wherever it needs to go, and therefore this structure can be easily transferred to other fields. I focus specifically on STEM climate resilience in this case, but that's not including the over 30 schools who received funding from the same grant to implement pathways such as environmental engineering, resource management, or sustainability, to name a few. The Foundations framework is an organizing principle that's based in 3 modules, exploring climate science, climate solutions, and what careers in climate resilience can actually look like. It was made to support the creation of a micro-credential for educators involved in California's new STEM climate resilience CTE. I believe this framework functions as a strong jumping-off point for continuing the conversation around expanding climate literacy and climate career readiness. This topic is brand new, and it's going to need to be tweaked and changed as time goes on, but my hope is that this framework can overcome early barriers to implementation and make this transition as smooth as possible. I'd first like to thank my capstone committee, Dr. Cheryl Peach and Dr. Rachel Millstone, for very generously contributing their time and expertise to guiding this project. Thank you very much to Corey, Jada, and Mark for your constant support of all of us throughout this year. And thank you to my wonderful family for all your encouragement. And most especially, thank you to the class of 2026. It's been an absolute honor. I'm happy to take any questions.
I was hoping that you might be able to elaborate on long-term impacts of this work and how it might be able to increase future income for participants in this program.
Excellent question, thank you. So let me give you a little bit of context. For teacher salaries, the way that those are decided is it's related to the years of experience that you have as an educator, as well as the degree that you have. So if you have 12 years of experience and a bachelor's degree, that puts you at one section on the pay scale. If you have 12 years of experience, a bachelor's degree, and then additional units, which you can receive by taking courses like this, that can put you higher up on the pay scale. So assuming that you're an educator who's taking micro-credential courses, you're gathering units, and that's moving you further and further along so that you might end up with a higher salary once you've accumulated a specific number of units. Thank you for the question.
All right. Thank you so much, Ryan. Great job. We have a break for lunch after this. Recommend, don't have that much time. If you have the app, Caroline's is upstairs. We have lunch for the students, but the soup of the day is Mediterranean garbanzo, and the lunch special is actually on a brioche bun. You will get 1/2 pound of chuck, applewood smoked bacon, cheddar cheese, a chipotle aioli, lettuce, and an onion marmalade. And it comes with your choice of fruit or breakfast potatoes. No judgment here. You might want the fruit after going with that burger, but it is a very nice view up there, very nice. We have lunch for the students, and if somebody shares a little bit extra with you, I won't call the catering police. But that's lunch after this. Before that, we have one last presentation in the morning, and this is Clara's presentation. And this is interesting because it connects a lot of important things together, right? Communities, environmental justice, and also this real need in the West to have water, right? Because water is quite scarce here. And as time moves forward and water becomes more and more scarce as it gets warmer, there's more evaporation, the rain we have falls in more discrete bundles and isn't as useful. We have to figure out how to manage water more intelligently. And that's sort of what this project is getting at. But anytime you change the way that a resource is managed, even if it's in the aggregate collective best interest, there can be on the margins be people who suffer disproportionate negative impacts from that. And this project, in the context of trying to optimize our water source management, comes at a really interesting time because we are about to head into an El Nino event. And that doesn't guarantee, but it raises the probability of a very robust rainfall season in Southern California, assuming the mid-latitude and tropics can couple appropriately. So water management in times of drought, but also in times of plenty in terms of water, is very important in California. And Clara took on a really interesting interdisciplinary project that required a pretty solid understanding of the meteorology, but also the societal aspects of areas in this state where there are reservoirs, and made a lot of connections with those communities and with previous work done in those communities, and some pretty robust policy recommendations. So to round out the morning, Clara with social and environmental justice considerations for forecast-informed reservoir operations in California. Clara.
Thank you so much, Corey, for that introduction. Thank you guys all for coming to my presentation today. I'm going to be talking about environmental justice considerations for forecast-informed reservoir operations in California, as Corey mentioned. So water management is becoming increasingly important with climate change. Climate change is causing more extreme drought conditions and more intense precipitation events. In California, these increasingly intense precipitation events are driven by increasingly intense atmospheric rivers. Atmospheric rivers have caused 90% of floods in Northern California. So what is forecast-informed reservoir operations, also known as FIRO, and that's how I'll be referring to it for the rest of this presentation? Is a reservoir operations strategy that uses weather and water forecasts to inform reservoir management decisions for more flexibility within water management. Historically, reservoirs operate on a fixed rule curve that dictate the amount of water released based on historical precipitation patterns. With FIRO, water managers can look at weather forecasts to make decisions instead of relying on those fixed rule curves. Lake Mendocino was the first location to fully implement FIRO, and this graph shows the potential to have an additional water efficiency at Mendocino, courtesy of the Center for Western Weather and Water Extremes. The graph shows a FIRO pilot study in the water year 2020. The black line shows the water storage pool with FIRO, and the orange line shows the water storage without FIRO. And you can see with this orange line, it follows the rule curve, which is delineated by the darker blue dashed line. right above that line, we can see a light blue shaded area, which again highlights that gap the gap with using FURO and without FURO, highlighting the additional water storage we see at this location, which was an additional 19% of water storage going into these summer months, which can be crucial in drought conditions. So why is it important to consider environmental justice for FURO? Within water resource management projects, emphasis on efficient use often excludes or overlooks equity concerns, which can lead to the exclusion and marginalization of vulnerable communities. Incorporating environmental justice considerations offers an opportunity to take into account equity concerns and involve communities in these discussions. There are also social and environmental justice factors that have been found to impact flood vulnerability and flood resilience. Communities that are typically highly vulnerable to flood hazard include low-income communities, minorities, the elderly, children, people with disabilities, and low levels of education. This leads me to my motivating questions for this project, which were, what socioeconomic and environmental factors are important to consider when evaluating vulnerability to flooding? How much do differing social and environmental justice metrics vary? And what does the case study of the Yuba Feather watershed tell us about the potential for community involvement and equitable implementation of FURO? For this project, I look at 4 social and environmental justice tools, many of which we've heard about today, starting with the California Communities Environmental Health Screening Tool, or CalEnviroScreen, the Climate and Economic Justice Screening Tool, or CJEST, the EPA's Environmental Justice Screening Tool, or EJ-Screen, and the Social Vulnerability Index, or SOVI. I would also like to point out that this top tool is specific to the state of California, while the 3 tools beneath it are tools used by federal agencies, which I'll talk more about later in my presentation. Within each of these tools, I also look at 3 key indicators, those being education level, elderly population, and proximity to environmental contamination, with 3 subcategories of hazardous waste proximity, cleanup site or Superfund site proximity, and water contamination. I'm going to talk about the methods. I'll start with the statewide analysis, and then a little bit later on, I'll get into the case study more. But to start, the first step was to intersect structures in the National Structure Inventory data set with the floodplain, and in this case, it was the 100-year hazard floodplain, to capture only the structures in that downstream region. These structures were then overlaid with social and environmental justice data that I just mentioned, and then these results of the downstream structures are mapped at each of the 26 reservoir locations that are potential candidates for FURO implementation. This map is a quick example of what we're going to be seeing when comparing the tools. The size of the circles represent the number of downstream structures in the floodplain, and the colors represent the percent of downstream structures that are above the 75th percentile threshold. So we see areas in green having less than 20% of those structures above that 75th percentile threshold, while the structures in red, or the locations in red, are having 80% of the downstream structures above that 75th percentile threshold, with the idea of being the higher percentage of structures, the more vulnerability in those areas. This is an example of a map for less than high school education that compares results from 3 of the different tools. There's a few regions that stand out that I would like to point out. The Southern Central Valley, circled here, stands out for having higher percentages of these structures that are above that 75th percentile for education level. And then another area that stands out is Prado Dam and Hansen Dam. And while Hansen Dam doesn't make it into that red category, it has the highest number of structures overall downstream across this map, which makes it an area that might need potential additional research. Another map looks at hazardous waste proximity across 3 tools as well. There's also some areas that really stand out on these maps, one being Del Valle Dam, circled here, as well as Hansen Dam and Prado Dam down in Southern California, highlighted here. These areas really stand out for having that red category being above, having 80% or more of those structures above that 75th percentile threshold. I also want to point out that across all of these maps, there are slightly nuanced differences, but this map on the far right is the map of CalEnviroScreen, while the two maps on the left are maps from federal agencies or federal tools. The CalEnviroScreen map stands out because it has visually very different results than the other two maps. This is a finding that was found all across all of the different maps that I made. So now for the case study, we're going to zoom in onto the Oroville and New Bullards Bar Dam and Reservoir, which are circled here in Northern California. This map also zooms into that region and highlights some of the cities I'll be talking about, as well as where those reservoirs are and where the dam locations are. For the case study, I mapped the overall scores of the Yuba Feather region for the 4 tools, as well as summarize the findings from an environmental justice and FURO workshop held in Marysville, California by the Socio-Environmental and Education Network, also known as SEEN, as well as the Center for Western Weather and Water Extremes, also known as CW3E. So why focus on the Yuba Feather region for a case study? There is a long history of flooding in this region, and these images highlight some of those flooding events. These photos are from an exhibit at the Sutter County's Museum on flooding and really tell the story of these communities. There have been significant flooding events in 1950, 1955, 1986, and 1997. The floods in 86 and 97 were specifically due to levee failures, which is a unique feature of this region. The photos on the left of this slide are from some of those older flooding events in the 1950s, and they get progressively more recent as we go to the right. This is also not only something of the past. There have been more recent flood scares, such as in 2017, which I would also like to point out was an El Nino year. In February of 2017, the Feather River had received 4.4 million acre-feet of precipitation in 50 days. Damage to the main spillway at the Oroville Dam resulted in the evacuation of over 100,000 people, and this amount of precipitation that they received was essentially equivalent to receiving a year's worth of precipitation in that short time period. This sparked the need for additional conversations about water management in this region. So now for the case study results. These maps depict the overall scores for structures downstream of New Bullards Bar Dam and Oroville Dam. We'll look at this first map as a bit of an example, which looks at the EJ screen tool and counts the total number of flags received. A location receives a flag when it exceeds the threshold for an indicator. The idea is that the more flags there are, the more vulnerable an area is. The next map we'll look at to compare is CGES, which similarly counts a total number of flags. And then there's 2 more maps. The next in the middle is the Social Vulnerability Index, which also uses a total number of flags. And then lastly, the CalEnviroScreen map, which differs slightly from the other 3 tools. It calculates an overall percentile score, and then those percentiles are further grouped into deciles, which categorizes the data into 10% ranges. There's a few areas I'd like to highlight within these maps. The first being here, which is the Marysville and Yuba City region. As we can see, some orange and red structures across all of the maps, indicating higher flag counts. Also, as we get closer to Sacramento, we're seeing higher counts of flags across the maps, as well as when we look at the city of Oroville, which is directly downstream of Lake Oroville. These communities, as I mentioned, stand out across all the maps and have had some of these historical flooding cases previously mentioned. I also want to point out that, again, the CalEnviroScreen map stands out pretty significantly, but a caveat of these maps is that they aren't necessarily totally comparable to each other. All of these tools have different purposes and different histories, and so they're not super comparable, but it does still highlight the need to look at multiple tools when doing these types of analyses, as well as to get a more full picture and understand the vulnerability in these regions. So the workshop was held in January of 2025 in Marysville, California, and had many valuable findings, including that community members still hold trauma from these flooding events, especially those in the communities for long periods of time, and community members were able to identify groups that are absent from water management conversations, such as the Punjabi community in Yuba City and Marysville. They also express need for overall more education on topics such as how water management decisions are made and on emergency preparedness. This photo is also from the Sutter County Museum and has a brief blurb about emergency preparedness with the goal of educating community members that visit this exhibit. There are multiple key takeaways I would like to go over with you all from this project. One is that having a tool that can identify social and environmental justice factors that impact flood risk, such as education level or proximity to hazardous waste, can be very useful to inform the equitable prioritization of FERO. One of the locations that I pointed out in my maps earlier was Prado Dam. That really stood out across a lot of the maps I looked at, and is an area that is having work done, and there's progress on implementing FERO in that region, although it is a long process. And then while it is helpful, it is important to understand that these tools have limitations within themselves and that there is variation across all of the different tools, making it important to consider a range of social and environmental justice metrics when trying to understand a region. Additionally, future efforts should create a tool specific to socioeconomic and environmental justice factors that impact flood resilience for the better understanding and implementation of climate resilient water management strategies overall. Because of the potential for nuanced details to be missed in these broader tools that just use survey data, it is also crucial to foster community engagement in water management strategies such as FERO, because of their local knowledge and their ability to express community needs and concerns that may otherwise be missed by these data sets. Thank you so much. I would like to thank my amazing capstone advisors from CW3E, including Dr. Tom Corringham, Denali Pinto, Jerry Wilcox, and Sarah Ogle, as well as my chair, Dr. Corey Gabriel. I'd also like to thank the leadership of this program, including Dr. Mark Merrifield and Jada Ryan, for their dedication to our program. And last but not least, I'd like to thank my cohort and my family for your support along this journey. Thank you.
Hey, Clara, good job. Thanks for the presentation. That was really interesting. I'm super curious about the CalScreen Enviro and why it was differing so much from the other ones, and I wanted to know if you have any ideas and if it was differing in kind of the same way throughout your different parameters that you were looking at.
Yeah, so I'll go back to look at those maps, but I think there's a few different reasons to why these tools were differing so much, and for time purposes, I wasn't able to get into that too much. But I talk about it in my paper. One of the things is that these tools are not, the most up-to-date versions of all of these tools don't use the same time frames with their data. So for example, the EPA's EJ screen uses data from the 2023-24 year, as that's the last year it was updated, while most of these other tools actually use older data, which is interesting. And then I think another reason is the scale of data used. Most of them use census tract, but there's one that uses block group level, which kind of varies the scale. And then also for the environmental contaminants, there was slight differences in the data sets, especially for the CalEnviro screen tool versus education level. It was the same American Community Survey data, but for hazardous waste proximity, for example, CalEnviro screen has an additional list of their own hazardous waste sites that they maintain, while the federal tools are mostly looking at federally managed sites. So I think that kind of also varies the results, but I do think there's additional research that could be done into understanding what is the main driving factor of these differences.
Thank you, Claire, for the great presentation. One question for you, as we prepare for what could be a historic El Nino event, how did that work its way into your analysis, or did that change the prescience of the work that you're doing and the interactions you had with stakeholders supporting it? Thank you.
Yeah, I think it just makes this project increasingly critical. I think with like an El Nino year, we'll see stronger, well, I'm not an expert on this meteorological side of it, but I think we'll see stronger atmospheric river events, most likely hitting Northern California. And so it's super important to take into account and have these flexibility options available. I will say that from what I've learned, FIRO it's a long and extensive experience, process, which I think is for a reason, because there's a lot of moving components and parts, such as like updating water control manuals for the final implementation, as well as preliminary viability assessments and final viability assessments, because we want to make sure that the forecasts going into these models are accurate enough to be able to accurately predict these intense precipitation events. So I think as we see more like variation, and this El Nino event is a great example of like how we can highlight to policymakers the importance of projects like these that enhance climate resilient water management strategies.
Great job, Clara. Just final comment about El Nino. If you're thinking about that, let's say you're at a casino and you're betting $10 a hand on blackjack, right? And this winter is coming up. This is the blackjack analogy. I'm not guaranteeing it's going to rain a lot, but if I'm at the meteorology blackjack table, I'm going to split, and then instead of doubling from 10 to 20, I'm going to bet like 5,000 on the over that it's going to rain a lot this year. But I might be wrong, right? Because as a gambler, not that I'm a gambler, but as a gambler, you have to realize that probabilities are what they are, right? You might have this big giant blob of warm water in the Pacific Ocean in a place that usually leads to a lot of rainfall in California, but there's other timescales and other sources of variability that might make that all go awry. So chances are it's going to be wet as heck in California this winter, but we don't know. We are going to reconvene at 1:05 after lunch. I hope you have a great lunch. This was a great morning, exceptional job by our morning presenters. We have 12 more coming up in the afternoon, so thank you, and we'll see you in half an hour. Lunch, and welcome to part 2 of our symposium. Thought we had a really great morning today, and I'm excited about where we're headed this afternoon. So our next block of presentations is going to focus on the ocean and our coastal ecosystems. And, you know, as we move forward, I talked at the beginning about a lot of the progress we've made in terms of renewable energy adoption, solar, wind, battery storage, adoption of EVs, expansion of the grid, and talked about the opportunities that are being taken advantage of, not just in California, but in states that are more politically centrist or conservative to actually adopt more wind power, adopt more solar. But there's already a lot of carbon in the atmosphere. Pre-industrial CO2 levels, about 280 parts per million. We're now well over 430 ppm. And mitigation is hard and it's expensive. So there are some ideas out there about intentionally manipulating the Earth system to either reflect away more solar radiation or to actually try to draw carbon down out of the atmosphere and sequester it in a stable, permanent or semi-permanent manner in the land, beneath the ocean. And the research on where ocean and coastal systems might be susceptible to carbon management, both to try to possibly draw down atmospheric concentration of CO2, but also for targeted ecosystem purposes. That's an active area of commercial interest and also some academic interest. And this project is an interesting opportunity, and the student working on this, Ella, was actually in my climate change studies course 3 years ago. And it's been a pleasure to watch her grow. And I just got to be honest, having Ella in my classes has definitely brought out a more mischievous side of me, where I'll kind of just keep going on a joke sometimes, because she'll just be like, she'll be laughing or have something to add, and she'll bring out the clown in me. But also, I am quite impressed by the depth of research that went into this project. And for somebody who is a political science major to opt to dive this deep into chemistry, and chemistry that is kind of still, we're still learning more about the various chemical equilibriums here, just very, very, very admirable. And the title of this project is Carbon on the Coast, a suitability framework to inform coastal enhanced weathering in California. Ella, the floor is yours.
Okay, cool. Thank you, Corey. And thank you all for being here today. So I'm sure by now we're all familiar with the steps we need to take to limit warming, and reducing our emissions plays a huge part in this. But like Corey said, what if I told you there was also another solution, another way to achieve our net zero goals? Not to totally undermine the importance of reducing our emissions, that will always play a huge part in this. But there's been this new idea that's been around for quite a while, actually, but it's only just starting to be taken seriously as a potential climate solution. This idea is known as carbon dioxide removal, or CDR for short. CDR aims to deliberately capture CO2 from the atmosphere and durably store it for long period timescales. The state of California has actually legally committed to achieving net zero and negative emission goals by utilizing CDR technology alongside traditional emissions reduction strategies. But little steps have been taken to scale CDR to the extent it would need to be scaled in order to have an impact. And this isn't just in California. All over the world, people have begun recognizing the need to reach not only net zero goals, but also net negative goals, which means that we extract more CO2 from the atmosphere than we emit. And I want to emphasize that the goal behind this project is not to endorse CDR, but rather to evaluate its potential as a supplemental strategy to limit warming. So there are a ton of different CDR strategies. There are more engineered focused strategies, there are land-based and ocean-based strategies, and the one that we're going to chat about today is based on the idea of enhanced weathering. This builds on the foundation of rock weathering, which is a natural geological process that sequesters CO2 as rocks dissolve over long period timescales. So when rocks are weathered by rain, they can actually dissolve and capture CO2 in that dissolution process. That CO2 gets converted to bicarbonate, which essentially traps the carbon in a stable form, so it can't be released back into the atmosphere. Over time, bicarbonate can make its way to rivers and to the ocean, where it remains for thousands of years. So enhanced weathering tries to speed up this process by spreading crushed up rocks or minerals on surfaces like farmland, for example. And because they're so crushed up into finer grains, they dissolve much more quickly, thus can capture CO2 more efficiently and convert that to bicarbonate. But what if we sped up this process even further, and we brought these crushed up minerals straight to coastlines, where they could rapidly dissolve into the ocean via wave action? This brings us to coastal enhanced weathering, which is essentially enhanced weathering but at the beach. And the idea is, you can actually just see how it's depicted in this image. It's sort of this like bluish greenish pigment on the sand. This is actually olivine. That's a silicate mineral that's been deposited in the sand. Olivine's been used in 2 coastal enhanced weathering projects on the East Coast, one in New York and one in North Carolina that are actively going on right now. And the idea is you deposit these certain kinds of minerals, sometimes it's olivine, and over time they're washed into the surface of the ocean via wave action, and they dissolve. And this dissolution increases the alkalinity of the ocean, but also it increases the ocean's capacity to absorb atmospheric CO2 as bicarbonate in the ocean. So how this works is typically CO2 in the ocean and CO2 in the atmosphere are in this equilibrium. But when these minerals are introduced into the marine environment, the dissolution of these minerals causes CO2 in the ocean to rapidly convert to bicarbonate. So with less CO2 in the ocean relative to the atmosphere, naturally atmospheric CO2 is drawn into the ocean to try and balance out this equilibrium again. And as long as these minerals remain present in the marine environment, the cycle can continue, where atmospheric CO2 is drawn into the ocean, converted to bicarbonate, and so on. The cycle continues. So in theory, this could be an excellent CDR strategy that we could potentially scale all along the California coast. And it's also something we could easily integrate into the hundreds of active beach nourishment projects that exist in California. But we also have to acknowledge that this carbon removal process is extremely hard to measure and complex, making it difficult to identify where along the coast this could best work. Where can we get the most CO2 drawdown? There are also a ton of regulatory barriers in California that, in terms of intervention into the marine environment, and for good reason, but how do we go about permitting this? Because there isn't a designated agency or environmental law that's really capable of governing CDR right now. So how do we regulate these kinds of interventions? So recognizing this, my team and I built our little suitability map that I'll show you guys in a second. This is an interactive map of the California coast, and it scores segments of the coast based on their suitability for deploying these coastal enhanced weathering projects. And I want to emphasize that it scores segments relative to each other. It doesn't provide any sort of absolute value of this segment can sequester X amount of carbon. So the way we did create this scoring was based off of a 2-tier framework. So tier 1 looks at implementation feasibility for things like permitting. So if a segment would require an intense, strenuous permitting pathway, it's just deemed ineligible for the sake of efficiency. And tier 2 looks at the relevant oceanographic drivers that influence carbon removal processes along the coast. So getting into tier 1, this is our eligibility check. Obvious must have, the segment must have a sandy beach that's compatible with nourishment infrastructure for physically depositing the grains. And then we get into some hard flags. So the segment can't be inside a no-take marine protected area due to permitting complications. Eelgrass and kelp canopy proximity are also relevant here, but in different ways. Eelgrass beds are actually designated essential fish habitat, so any interventions into this environment would likely cause a lot of permitting complications. And kelp is actually super sensitive to changes in local ocean chemistry. So any spikes in alkalinity, which is essentially what we're trying to do, would potentially disrupt this habitat. So we don't know the specifics yet, so overall it's just best to avoid these areas for now. And then we added a little soft flag here. Ideally, the segment isn't any sort of critical habitat for any endangered species, just to stay on the safe side. But it turns out a majority of the California coast is some sort of designated critical habitat, so we really can't make this a hard flag at the moment. But also, there have been no studies that have shown that these mineral amendments do cause harm to the marine environment. So we're gonna play a little video here. This is getting into, oh, the lights are dimming. We're gonna get into our suitability map here. This is tier 1, so this looks at eligibility, and you can see the segments highlighted from red to green. Red is ineligible, green is eligible, and we're gonna zoom in on a section of the coast here that we all should know very well. This is San Diego, and we can hover over segment, and we can select that segment, and this white panel pops up with the eligibility status and the reasoning as to why it's eligible or ineligible. And the fun part is you can actually overlay a ton of data sets onto the map. So just taking into account things like marine protected areas and nearby critical habitat, that's what's being showed right now. And we can also factor in ecological considerations. So eelgrass beds, eelgrass is super prevalent in the San Diego region. And we can also overlay kelp canopy onto the map, which is super neat. And so overall, the map in tier 1 just gives us a better understanding and inventory of some of the regulatory considerations that would go into evaluating a segment for a coastal enhanced weathering project. So if a segment ideally passes all of these checks, it can move on to tier 2, which is the actual scoring part. This evaluates the relevant oceanographic conditions that are relevant to the carbon removal process. So this suitability metric is solely based on physical drivers because it turns out that CO2 storage efficiency is very dependent on where you are on the coast because of all the relevant oceanographic drivers influencing the marine environment, thus influencing carbon removal potential. So recognizing this, we gathered the relevant oceanographic data, and we used this data to evaluate the 4 phases of this carbon removal process. And the 4 phases, or 4 subscores, are broken down into dissolution, residence time, efficiency, and storage. So dissolution looks at how fast the minerals are dissolving in the ocean. Residence time looks at how long the grains have to remain in the surf zone where they're able to dissolve. Efficiency looks at once the minerals have dissolved and the water does increase in alkalinity, how much CO2 can actually be drawn into the ocean. And then storage looks at, well, what happens if the water becomes too alkaline? This could trigger something called calcium carbonate precipitation, which could essentially reverse the carbon removal process. And these are the relevant oceanographic drivers that make up each phase or each subscore. And since there's no standard way to measure this specific coastal carbon removal process yet, I gave equal weights to each driver, meaning that all of these metrics are weighed equally in terms of how much they would influence their respective subscore or phase. In reality, certain drivers will likely have more influence than others, but we just don't know the specifics of this yet to make any sort of assumptions. So this is a first step in evaluating that process. So we're gonna go back into our map here. So it's highlighted in eligibility. We're gonna switch to the suitability tier 2 score. So you can see now all of the eligible segments are highlighted from dark green to yellow. And we're gonna zoom in on a section of the coast that scored super well. This is a little cluster in Santa Cruz. So you can click on an eligible segment, it'll tell you the exact location and the composite score. And what's super neat about this is you can click on a subscore, it has a little drop-down button, and it gives you a brief description of the process and how this is relevant for carbon removal, but it also gives you those exact oceanographic metrics for that location. So all of those scores factor into the dissolution score, which factors into the overall composite suitability score. But you can see this for every single subscore or phase. You can see this for residence time, efficiency, and storage. All of that data is the exact data at that location. That feeds into the composite suitability score. I want to highlight closest mineral source. That's something I don't have too much time to get into now, but ask me again at the end. And we also have the regulatory flags here to consider. This segment is critical habitat for a few listed species, so we want to be cognizant of that. And also kelp canopy proximity and eelgrass proximity is still relevant here. But I want to zoom out a bit and go down along the coast to a section that didn't score as well as Santa Cruz did. This is a section in Malibu, so you can click the segment, it'll tell you that location and the composite score, which is pretty poor in comparison to Santa Cruz, likely due to the lack of wave energy here. You can see that's 0.6. And the storage, the sea surface temperature is a bit on the warmer side, which isn't super ideal for carbon removal. But overall, the Tier 2 suitability phase of the map, it's just super efficient to have all this data and all these suitability scores in one place to better understand why certain sites perform better than others, to base our decisions on the best available science. So moving on, to address some of the limitations of this project, this is obviously still a very new, active area of research, so we don't know how much influence certain drivers have over others. And also, coastal zone and surf zone observations are pretty limited along the whole coast of California. So some of the measurements that we have take measurements that are a few kilometers offshore, so they're unable to capture the exact surf zone dynamics. So that's something to flag. And also, this framework omits some relevant non-physical dimensions of suitability, so like community consent and politics and grain size and transportation and fisheries input and so many more relevant considerations that are just beyond the scope of this project at the moment. So some next steps. If we want to do CDR or coastal enhanced weathering right, we really need the infrastructure to do so. So we need streamlined permitting. There are too many barriers to entry because our permitting system just isn't really set up to regulate these types of interventions yet. So having a consistent, streamlined pathway would greatly reduce that burden. We need standardized MRV protocols, so measuring, reporting, and verifying that this carbon removal process can actually do what it's saying it can and remove carbon from the atmosphere. And community outreach and coordination with fisheries, that is super, super key here. The last thing we want to do is exclude the people that live at the coast and work at the coast from these kinds of decisions. And of course, pilot projects, doing these experiments in the coastal ocean and in the surf zone to get the most accurate data measurements possible. There are so many research institutions in California, like Scripps, that have the capacity to perform pilot projects like this. It's just a matter of getting started. So wrapping up here again, I'm not trying to endorse CDR or coastal enhanced weathering specifically, but there could be a lot of untapped potential here in terms of carbon removal capabilities. But the only way we can do this is if we do this right, which means being 100% certain of the impacts and the outcomes associated. This project is a first step in that process. And I want to take the time to say some, thank yous to my incredible, incredible cohort. I couldn't have done this without you all. To my, my legendary capstone committee, Mark Merrifield and Connor Mack, especially Connor Mack. He's been such a mentor for me these past years. I truly wouldn't be here without him. To Jada Ryan and Corey Gabriel for making CSP such a safe and supportive environment to really explore my true passions. And to my friends and family for being here today. My family's here all the way from Gaithersburg, Maryland. Shout out to them. But thank you, thank you all so much for your attention. I'm so honored to have this platform to share my research with all of you. It truly means the world to me, and I hope you enjoyed. I'll take questions now. Yeah,
Thank you so
Lang.
much, Ella. That was really an incredible presentation. I am wondering a little bit about, you mentioned that there isn't any research saying that this could be a harmful process. I am wondering whether or not there's any research showing how it could actually benefit even particularly endangered species. I'm thinking specifically about that drop down that you showed was about abalone. So mollusks need this bicarbonate in order to exist, and ocean acidification is just getting worse. So is there any data that you've found that actually suggests that this could be beneficial to endangered animals?
So
thank you.
My research mainly looks into how this could counter ocean acidification. It didn't go into the specifics of what kinds of animals this could benefit or harm, but that's something me and Naomi talked a lot about at a conference we got to attend. Thank you to Julia Brown for sponsoring that. But mainly the studies, we talked about the Northwest Pacific, especially like the Salish Sea. So doing these types of open ocean alkalinity enhancement projects, not specifically coastal enhanced weathering, but just dumping alkaline minerals, like usually dissolved alkalinity, into the water. That is actively going on right now at Woods Hole, I think. So looking at how those could raise alkalinity levels, we don't know how those could impact, the species that live there yet, but it's definitely an active area of research looking at it to counter ocean acidification. Thank you.
Right. Amazing job. Thank you so much, Ella. We remain on this theme of the coastline. So Naomi Howard is our next presenter. And I remember Naomi wrote a summer paper that I thought was extraordinary, one of the better summer papers anybody's written in this program. It was about physics at high latitudes that were very complicated. And the real strength of Naomi's paper was that she didn't really have to, but did an incredibly thorough literature review. And rather than sort of try to capture like a headline or two, she presented the science really as it was, which was kind of murky. A lot of people trying to learn about a complicated system, and there weren't clear, satisfying answers to fully explain the reason why climate change might be progressing in certain places at high latitudes faster than others. But she provided a lot of nuance and a lot of granularity to a really important topic, and that level of engagement on systems science has continued throughout the year, and translating from global scale climate processes to thinking locally, connecting with the city of Oceanside, and then working with them on some innovative and important and overdue coastal management projects have really allowed Naomi to, I think, combine a lot of different things, science, instrumental science, and also policy making and local politics and the constraints that puts on evidence-based policy. So Naomi did a nice job encapsulating what we're trying to accomplish here very well with this project and how she executed it. Naomi Howard, Spatial Coastal Monitoring for Climate Resilience, a case study of Oceanside, California. Naomi, the floor is yours.
Thank you, Corey, for that kind introduction. Happy to talk socioeconomic politics of Oceanside anytime. As you all know, let me get this started. Okay, let's get started. All right, as you all now know, again, my name is Naomi Howard, and today I will be presenting my capstone on spatial coastal monitoring for climate resilience, a case study of Oceanside, California. Just before diving into the presentation, here is my capstone agenda. I will be first talking about the significance of coastal dunes as a nature-based solution and their value to Oceanside. Second, I will address some gaps in coastal monitoring I encountered throughout my project. Third, I will go on to discuss the existing frameworks for coastal dune monitoring and experimentation with the new survey methodology applied. And finally, I will present my preliminary findings from this research and what I believe its future implications are for the city of Oceanside and for coastal adaptation. To start off, I would like to introduce coastal dunes as a nature-based system. As defined by the International Union of Conservation of Nature, also known as the ICUN, nature-based solutions are a pathway for both mitigation and adaptation for climate action in order to achieve both reductions in warming and overall resiliency as a planet, outlined in several climate change agreements like the Paris Agreement. Living shorelines serve as an entire nature-based solution ecosystem, provide adaptation and resilience to the coastal communities living behind them, while also maintaining the natural integrity of the shoreline and the biodiversity that inhabits it. The restoration of living shorelines has become widely adopted by coastal communities across the globe, slowly taking over gray infrastructure strategies such as retaining walls, groins, and jetties that cause harsh separations between the shoreline and the ocean. There are three important objectives to fulfill when trying to restore living shorelines. One is improve coastal and climate resiliency. 2, protect upland areas and coastal infrastructure. And 3, maintain shoreline ecological function. Coastal dunes are formed on the back portion of a living shoreline, also referred to as the upper beach. The high elevation of these dunes, compared to the rest of the lower coastline, serve as a protective barrier against high wave activity while providing habitat. Coastal dune restoration projects are gaining momentum across California as sea level rise projections become increasingly urgent. Senate Bill 272, passed in 2023, strengthens the authority of coastal communities to act on these projections by requiring local coastal governments to develop and implement sea level rise adaptation plans, which is giving cities a formal mandate to pursue nature-based solutions. Policymakers are now actively evaluating which coastal adaptation projects are best address the hazards associated with rising seas, and dune restoration has emerged as a leading strategy. Several coastal cities in California, like Santa Monica, have already begun investing in dune restoration along their coastlines, reflecting a broader statewide recognition that rebuilt dunes are among the most effective and cost-efficient tools available for long-term coastal resilience. Coastal dunes are a relatively easy strategy to implement. Wind will blow onto the sand and onto the back beaches, accumulating into mounds over time. This sand is able to stay in place from rooted vegetation, which increases overall dune stability and accelerates the sand retention rates. When storm surges, coastal floods, and mean water lines swallow the entire shoreline, the dunes are eroded instead of the infrastructure behind it, bringing sand further down onto the beach. Therefore, coastal dunes are not only a protective barrier, but a natural sediment deposit for the rest of the beach. It is estimated that up to 75% of California's beaches will be lost by 2100. Oceanside is already experiencing these significant changes in beach loss, where up to 6.6 feet of sand is lost each year along the city's beaches. This is largely due to the construction of Oceanside's harbor at the north end of the city, which has amplified erosion along Oceanside's shoreline to the south of its placement. To combat this erosion, the city has invested in annual nourishment projects to keep sand on the beach. However, beach loss still occurs every year despite this. Coastal dune restoration is one of the pathways the city is exploring to resolve these devastating beach loss impacts. The project was chosen for 3 main reasons. The first is coastal dunes have been historically existing in Oceanside pre-harbor construction, as shown in this photograph taken in the 1880s on the far left. Second, coastal dunes act as a natural windbreak, physically intercepting and trapping sand before it can migrate off the beach and into the city's parking lots and roadways. Third, the addition of coastal dunes in the city of Oceanside has the potential to mitigate coastal floods and coastal storm surges, like the example shown here in 2015 on the right. This depicts large waves overflowing onto the Strand, a popular beach site for both its residents and visiting tourists throughout the year. To briefly give you all a full understanding of the Coastal Dune Project, this is a map of North Oceanside. Here you can see the Harbor Beach and its associated jetties, the San Luis Rivermouth, and the Strand Beach, just north of the Oceanside Pier. The blue areas is where coastal dunes used to be in the 1880s. Pre-harbor construction continued to extend north and south of this map. The purple segments are where the coastal dune projects are currently placed to restore these lost areas in Oceanside. and this map is intended to show the extent of natural shoreline that has been lost due to the construction of coastal infrastructure, causing coastal dunes to disappear, along with the numerous ecosystem services that they provide. In order to monitor the city of Oceanside, I was hired as an intern to conduct weekly surveys of the 9 different dune sites installed in the northern Oceanside. At each site, I would record dunes related to qualitative and quantitative observations, as well as perform any additional routine maintenance necessary, such as picking up trash and fixing shims. I wanted to incorporate Oceanside's dune restoration project into my master's capstone for several reasons. Oceanside beach loss is not universally understood, and its community expresses a lot of concern, but little action has been taken to adapt beyond annual dredging projects. Therefore, in order to increase sand retention in Oceanside's beaches, nature-based solutions are necessary to provide immediate beach resilience benefits, as reflected in projects such as Ponto Beach, Cardiff, and Santa Monica as dune pilot study examples. Basing off of this sentiment, the city has just started moving forward with its first green and blue coastal management projects, creating an immediate and growing need for robust monitoring and adaptation data to track their effectiveness. This creates a direct opportunity for me to step in at a crucial moment, contributing to a restoration project that is not only the first of its kind for Oceanside, but one that will set the precedent of how future coastal adaptation efforts are measured and evaluated here in the city and the state of California. The city of Oceanside gave me a qualitative coastal monitoring framework to follow each week as I visited the dune restoration sites. I was asked to record daily metadata, tidal cycles, and the overall success of each dune installation, including dune topography, native vegetation, non-native vegetation, sand retention, human intrusion, and the overall dune height of each of the 9 sites. The image on the right is an example of an observation form that I used to record information for all of these categories. These criteria are used to evaluate the overall performance of the restoration project and are due to be delivered in a brief annual report for the next 3 to 4 years to key stakeholders throughout the duration of the pilot study. While I found that this framework was helpful, I realized that it was not telling the full story, especially in the categories I have asterisks on the left image. This is because I had no way of quantifying these changes, including how much sand was actually accumulating, where topography changes were actually happening, and how high the dunes were actually growing week to week in each study area. Once I started to explore how dune morphology and shoreline changes were quantified and calculated in similar coastal projects, I ran into even more challenges. One barrier is that there are incredible technologies, such as truck-mounted LiDAR and drone surveys, that are able to detect shifts in beach topographies, but these are costly and are usually deployed on a biannual or annual basis to assess seasonal shoreline changes. These technologies are not ideal for site-specific coastal projects, as infrequent seasonal surveying does not tell the full story of early dune formation. Another significant barrier to monitoring coastal dune projects is that they rarely exist as a single uniform site. While some stationary survey technologies can repeatedly capture data at one fixed location, this dune project spans multiple distinct installations, and each one is telling a different story in terms of elevation change, vegetation establishment, and sediment behavior. I also found that coastal monitoring data rarely makes it into climate adaptation planning. This beach profile was taken from Save Oceanside Sand on the right, a nonprofit specifically run to identify Oceanside's beach loss. This group has produced over a decade of monthly transects rigorously analyzed by Scripps researchers, yet it rarely reaches the local governments who are responsible for implementing these coastal adaptation projects. Once the coastal project is in place, the data is outsourced, creating a disconnect between what is happening in the field versus what is being analyzed. So the solution for this is my project aims to help close that gap by making monitoring data more actionable for the decision makers on the ground, while providing a low cost and low barrier tool to measuring and quantifying dune change over time. To achieve this, I created a spatial monitoring technique using Oceanside and La Jolla as my 2 sites of study. I coupled my iPhone 17 with a highly accurate coordinate system receiver device called a Vidoc to take photos and points to capture and replicate each dune site, which I'll expand on in the next slide. Please note that the phone itself is not shown in this setup, as I need it to take this photo. Phones are equipped with high-quality cameras when coupled with high-resolution point detection. You can evaluate even the smallest changes in topography and sand accumulations with these. These images are captured in a 3D modeling application called Pix4D-Catch, which is free to use. I believe that this technology, if successful, would address several challenges I just discussed by creating a frequent survey tool that is not stationary or expensive to set up and use, would be quantifying dynamic coastal variables that cannot accurately account for right now quantified in qualitative measurements, and serve as a low barrier and low cost technology that can be adopted outside of research institutions, since there is no licensing or certification required, which would be creating an opportunity for citizen science and potential partnerships with outside organizations interested in coastal work. The technology uses three main components to successfully measure spatial changes. Ground control points are a physical marker placed on the ground at known surveyed locations before you've been capturing imagery. They act as anchors that tie your points to real-world coordinates. Real-time kinematic is basically a refined GPS system. Normally, GPS has an accuracy of several meters, too imprecise for detailed survey work. RTK fixes this by using a second stationary GPS receiver as a reference point. By constantly comparing signals between the iPhone and the fixed receiver, RTK corrects positioning errors in real time, where every photo you take is tagged with a highly precise location. Once the images are processed, Pix4D generates a point cloud, which is also called a dense collection of millions of individual 3D coordinates that together represent the surface of the landscape. From the point cloud, you can extract different data sets, including elevation data, measuring fore-dune and back-dune volumes, and overall shifts in topographic landscape, and much more. The surveys that were successfully captured show considerable promise for this methodology. When compared against beach spatial surveys, including truck-mounted LiDAR, stationary LiDAR, and RTK transects, the iPhone and ViDoc pairing produced point cloud data within centimeter-level accuracies. To put that into more digestible terms, every individual point generated by the iPhone and ViDoc fell within a few centimeters of readings produced by technologies that cost at least twice as much. This figure demonstrates this with a comparison of cross-sectional elevation profiles across 4 survey plots along Harbor Drive and Oceanside, overlaying 2026 survey data against March 2026 truck LiDAR data baselines. And these two data sets show centimeter scale differences in elevation readings between established truck LiDAR surveying and the handheld survey methodology, which is visible in the subtle vertical offsets between the blue and red dashed lines across all 4 plots. I have to say that several of the handheld surveys I took were often heavily misaligned compared to the surveying technologies currently established and required lots of edits in capturing technologies, coordinate system aligning, and more. However, handheld survey outputs were significantly improved by implementing ground control points that created better positioning and alignment across the surveys. And finally, more surveys must be captured by the handheld survey methodology before confident quantifications of mean dune change can be made, as a mean error and coordinate offset must be determined with a larger sample size, as figures like these revealed mysterious offsets that need to be further investigated. From completing the dune observation forms, technical assessments with the iPhone and ViDoc, and given maintenance materials, here's a summary of what I observed during my weekly observations. All right, dunes were first installed in the last few weeks of January. Each dune plot installation included 2 rows of back fence line and upfront areas with wooden shims. Native vegetation taken from Camp Pendleton and San Luis Rey nearby were dispersed across each installation to root in the sand. At the end of February, high winds and rain led to significant changes in dunes topography, where plants were buried with sand and the sand accumulation was significantly higher around the fence line and shim areas. In the middle of March, new growth was observed in all 8 of the installed plots and are now starting to establish in all dune areas. Starting in April, significant changes were made due to overlap in the coastal dune restoration site plans and the area for the annual harbor dredging conducted by Army Corps. This resulted in an entire plot removed that was closest to the harbor beach jetty and the front areas of each of the 4 dune sites on the strand, with only the back line fencing remaining. In May, the dredging equipment has been removed, and spring winds are starting to bring more sand into the plots and onto vegetation. With new plant growth and flowering, along with sites displaying more dune topography, the public has also shown increased interest in this project as well. And there will be more observations to come in June. From my work in the field and my discussions in the coastal adaptation space over the past few months, I believe that the iPhone and RTK surveys should be explored as a low-cost and low barrier to entry coastal monitoring technique for cities, nonprofits, and the general public to pursue and learn how to quantify changes in these coastal projects that aim to protect the public at a higher level. With the incorporation of new technologies such as this one in the coastal monitoring space, I hope to guide future adaptation efforts where we can identify ways of defining success of coastal adaptation projects on site-specific basis while continuing to the development of performance measures for them. Specifically, coastal dunes need these metrics to define success in reference to sea level rise adaptation plans and coastal hazard assessments, since it is recognized as a viable adaptation pathway but lacks standards to determine the exact magnitude of shoreline improvements these projects provide. Overall communication and community engagement will be imperative for the ongoing success of the Coastal Dune Project. We have the tools and examples to create successful dune projects across California. We just need to provide and implement spatial technologies to monitor them, as these projects are crucial to the success of climate adaptation strategies in coastal California communities. I want to end by thanking my capstone committee members, Mark Merrifield, Jamie Timberlake, and Jenna Wisniewski, and Rob Grensbeck for their incredible support on this project and in the coastal adaptation space. I also want to thank my wonderful cohort, as well as Dr. Corey Gabriel and Jada Ryan for making this program such an amazing experience for me. Thank you.
Thank you so much for that presentation, Naomi. It was just super interesting. I know mostly from you talking about this that you have experienced like people like coming through and like not understanding what's happening with the restoration projects and that leading to it getting torn apart or walked on and all kinds of stuff. How do you see this technology like addressing that issue in terms of, you know, just letting people know what's going on? Do you think this technology will make that easier?
Yeah, I think that's kind of, I think yes and no in a way. Like, as so many presentations touched on earlier, education is kind of the root of all of these motivations, and making sure that these people understand that climate adaptation is a crucial part of adapting our cities, even if it involves a fence line and by your property. But I think also the spatial technology would be a really cool way to engage people. And I mean, I had a few discussions when I was even out there being like, look what I'm doing. I'm like tracking I'm making a whole 3D model of what's happening, because it's important to like measure these changes over time. And just introducing this as an exciting point of that dunes are a dynamic system that just are really cool to measure. Like, they migrate, they change, and they've been really successful, and they're pretty. So I think that there's a lot of potential there. Yeah.
Right. Great job, Naomi. Thank you so much. I looked at a headline earlier today, and it said that 7% of species killed because of climate change. And then I decided I would read the article. And the article told a slightly more nuanced story. Turned out that this species, is in Indonesia, had been displaced over and over and over again by industrialization and then wave after wave of mining. So the habitat was drastically shrunk, basically the forced ghettoization of a species into a very, very small space that then experienced a flood, which was enhanced by climate change, and there's the climate change attribution. But all of the mining, all the anthropogenic influence sets the stage for an environment in which climate change can have extraordinarily bad impacts. So that's the nexus of anthropogenic influence on our system and climate as a vector of change. And in Colleen's project, there's a clear recognition that climate change is a context in which we all live. And climate change is something that actors, corporations, meaning pieces of paper that have the ability to produce X and then sell it and collect money and then return it to their shareholders. Those entities control a lot of real estate, a lot of assets, and at the same time, we have a state of California and a federal government that has priorities, collecting taxes, keeping people safe. But is the corporate community and the state, national, local policymaking communities, are they aligned, right? Are we making climate policy that is the kind of climate policy that corporations, private sector can compete in, right? And are we allowing the private sector to be held accountable by us for the kind of impacts they're going to have. And one incredibly important risk that we're facing going into the future is sea level and then singular discrete events like big storms interposed on that sea level signal. And one of the important things we can do now, and has already started with Senate Bill 261 and other things, is trying to better align the priorities of corporations and governments to make it so that we can work together and think about how to adapt to the risks that are in the pipeline. And Colleen did a great job engaging a lot of stakeholders in this project, and also was an absolutely superb CSP student and an excellent representative of a little sliver of this country that doesn't get enough love, the Jersey Shore. So I'm very proud to have Colleen in this program. Shout out to everybody at WRAT FM in Belmar, New Jersey right now. Colleen Cochran, aligning corporate climate risk disclosure with public adaptation planning. Colleen, the floor is yours.
Thank you, Corey, for that introduction and really helping set the scene for us. Just give me 1 second as I pull this up. Okay, great. Thanks again, Corey. Hi, everyone. I'm Colleen Cochran, and my research aligning corporate climate risk with local adaptation planning really focuses on bringing together emerging public and private risk adaptation and assessment efforts. So before we dive into the research, I just want to take a moment to talk a little bit about the motivation, including both my personal background and the climate governance context. So my introduction to climate work focused on dune ecology, so thank you, Naomi, for really teeing up how important that work is. And as you just heard, both Corey and I grew up on the Jersey Shore, and I had the experience of having my home and my community devastated by Hurricane Sandy, and that really influenced me to start doing coastal management and dune ecology research. So I also had the firsthand experience of seeing what it looks like when climate risks materialize, and also how difficult local adaptation planning can be. But outside of academia, I've spent the past 4 years working in climate consulting, advising corporations on their climate strategy and climate risk assessment and adaptation. So entering my master's degree, I knew I really wanted to connect these worlds, but more importantly, I saw a critical gap between private and public risk assessment and adaptation. And this year really emerged the perfect opportunity to explore this intersection. The introduction of California's Climate-Related Financial Risk Act, or SB 261. This law is implemented by the California Air Resource Board, or CARB, and the law requires companies doing business in California to assess and publicly disclose their climate risks. Many companies had already been voluntarily doing this through a voluntary framework called the Task Force of Financial Related Disclosures, or TCFD. So because of this, SB 261 requires alignment with this framework as opposed to the existing climate risk guidance in California. But SB 261 really predates a long history of other climate risk laws and guidance in California for public planning. In fact, California conducts their own state-level assessment, translating IPCC science, which is the Intergovernmental Panel on Climate Change and the leading scientific body on climate science, to California and discussing specific climate risk exposure to the state. This document really underpins the state's primary climate adaptation planning guide, which we can see here. And there's also laws that require implementation of climate adaptation within California, including SB 379, SB 1035, and AB 691 for entities with public trust land. So these frameworks explore multiple climate hazards, including wildfire, cyclones or hurricanes, water stress, and sea level rise. My study is going to specifically be focusing in on sea level rise, and this is because it's the most developed hazard in California's public planning infrastructure, and also where better to study sea level rise than Scripps. So zooming in on sea level rise, for coastal jurisdictions, this general framework is supplemented by 2 additional layers of sea level rise specific guidance.
So first, we have the Ocean Protection Council's State of California Sea Level Rise Guidance, and that translates that larger IPCC science to individual sea level rise scenarios. And then we also have the California Coastal Commissions Act Sea Level Rise Guidance, which takes those scenarios and makes them a requirement within the California Coastal Act. And then also a couple years ago, SB 272 was introduced to require all local coastal governments to develop a sea level rise adaptation plan by 2034. So I know that was a lot of context, but hopefully this complex and disaggregated system helps lead you to my research question. How can corporate physical climate risk disclosures be aligned with local adaptation planning in California? And as for why I'm exploring this now, SB 261's first compliance cycle just started. So for the first time, we have a publicly accessible data set of corporate climate risk assessments, making now really the perfect policy window to explore policy recommendations. And as for why do we care about this? We care about this because it is a significant and well-documented adaptation funding gap. Climate hazards are already beginning to materialize with sea level rise and compounded flooding and storm surges already damaging coastal infrastructure, communities, and businesses. This makes every single opportunity for exploring co-investment worthwhile to explore. So I explored this research question in two primary phases. Phase 1 was all about document analysis. I analyzed 146 SB 261 disclosures, which are publicly available on CARB's docket. There's more as of now, but I also reviewed 20 public adaptation planning documents across 6 California coastal jurisdictions, and I also compared those 5 climate risk frameworks that we saw on that earlier slide against each other. And all of the photos you'll see across my presentation are directly grabbed from all of these wonderful reports. And then so for phase 2, I did stakeholder interviews to really validate phase 1's findings and explore realistic policy recommendations. I conducted semi-structured interviews with 9 corporate sustainability professionals and 9 coastal planners. They were 30 minutes each and fully anonymized with 7 mirrored questions to enable cross-comparison. So we'll start first with what I found with the SB 261 disclosures posted to CARB's docket. 75% of filers did conduct scenario analysis, which means they assessed climate hazards using that IPCC science under a range of future emission scenarios, but only 16% planned out to 2050 and none to 2100. Also, only 21% of disclosures even mentioned sea level rise, and only 3% rated it as a material business risk. Material business risk meaning financially significant enough to affect business decisions. Also, only 8% provided asset-level geographic detail. Most assessed risk at the portfolio level, which means they provided a categorical risk, either low, medium, or high, for their entire global or national portfolio, as opposed to zooming in on a specific location. Additionally, mention of public and private partnerships was minimal. However, there was one standout example, which was PG&E, which is a public utility here in California, which identified Bay Area substations by name, quantified sea level risk out to 2050, and actually co-invested with the City of Menlo Park in an actual adaptation project. The sea level rise rates also really varied by industry. Engineering and real estate had the highest rates, consistent with them having direct physical asset exposure. Professional services also mentioned sea level rise quite often, but none of them rated it as a physical material risk to their business. So moving on to the public side, again, I looked at 20 different documents across 6 jurisdictions along the California coast, and these documents range from AB 691 compliance reports to local coastal programs and other adaptation frameworks. So most of these documents did quantify sea level rise projections, and the dominant modeling tool used was COSMOS, or the Coastal Storm Modeling System, which is developed by the US Geological Society, and that appeared in 7 documents. The COSMOS mapping is much more precise at the parcel level when compared to the broad portfolio levels of the SB 261 disclosures that we were just talking about, making cross-comparison of shared risks in certain geographies very challenging between the public and private disclosures. Additionally, several documents called out the extreme funding gap for adaptation projects, with the Bay Area specifically quoting a $110 billion adaptation gap. Here, there were also a few examples of public and private partnerships. For example, San Mateo County included Facebook, Google, Oracle, and PG&E as governance stakeholders in their sea level rise assessment process. Here, what I wanted to show in this figure is that all of the documents when assessing sea level rise planned out to 2100, including 2030 and 2050. Here we can see that in 2100, we're expecting, at the worst case, sea level rise of up to 10 feet, and then 1 to 2 feet between 2030 and 2050. These bubbles all represent different plans that I looked at, and the larger the bubble represents the larger range of uncertainty. So knowing that there could be sea level rise between 1, 2, and 10 feet really shows us that there will be significant impacts on coastal infrastructure, communities, and businesses. But again, going back to the corporates, none of them planned out to 2100, very few out to 2050. And this is because the framework that they're using through SB 261 allows companies to pick their own time horizons. And as such, it puts them out of alignment with California's planning guidance. And because a lot of sea level rise risks don't materialize till later, they can be significantly underestimating this risk as part of their business risk assessment process. So now onto the interviews. They really added a lot of texture and nuance to the document findings. The corporate interviews span global financial and professional service companies to public utilities, hotels, and insurance companies. So across all 9 corporates, awareness of California or any other planning tools was extremely minimal. However, 2 interviewees had developed their own risk assessment tools using FEMA and other public guidance. Companies with mobile portfolios, short-term leases, and remote-capable workforces consistently rated sea level rise as not material because they can relocate. Again, industry played a role with professional services organizations less likely to rate sea level rise as material. However, on the other hand, interviewees that had coastal assets or instances where adaptation was critical to preserving their customer base or infrastructure reported that they have already engaged or are interested in engaging in directly co-investing on adaptation projects. So there was a notable difference though as well when I was talking with organizations across all of them when I reframed adaptation projects to talking about the idea of quantifiable, claimable resilience credits, which are similar to carbon credit mechanisms rather than these abstract nature commitments. And so lastly, generally on partnership appetite, the consistent theme for corporates was mission alignment and mutual benefit as a non-negotiable precondition. But every corporate did identify that they believe that climate risk adaptation is a shared responsibility between public and private sector. So then moving on to our public planners, interviewees consisted of resilience planners, coastal managers, and sea level rise program directors. Every single planner reported funding as the #1 barrier for implementation. And on SB 261, most planners were aware that the law had existed, but none had reviewed a disclosure. Several immediately asked me who has responded, are any in my jurisdiction? And I think one planner really put it best by saying, SB 261 is sitting on a shelf, how do we make it useful? The institutional type also really mattered across planners. Port authorities had the most developed frameworks for private engagement, with one port already requiring tenants to plan for sea level rise and contribute 25% of funding to coastal flood defense costs. Lastly, planners, similar to corporates, also really emphasize the importance of mission alignment with strong organizational credibility. And one interview noted that the most durable partnerships observed or anticipated were those where the private actors had a direct and visible stake in the place. So taking all of these findings was really important to me to put together policy recommendations given that SB 261 has just been implemented. So I developed 5 policy recommendations that fall into 2 categories. The first is improving the information infrastructure, and the second is creating mechanisms for co-investment. And each of these recommendations aims to address a specific finding from the research. So in that first category, we first have geocoded asset disclosure being the single highest leverage change. This simply would be requiring companies to disclose their assets either by city or latitude or longitude within their filings. And this would enable spatial overlay with the public plans as well. And it could also create a searchable registry within CARB's docket for planners and other stakeholders to directly find the reports in their jurisdiction. Next, to align temporal horizons, requiring 2050 and 2100 benchmarks would bring SB 261 into consistency with the rest of California's assessment guidance. And third, a cross-sector risk mask would be a periodic overlay of SB 261 disclosures with Cosmos hazard zones. Again, combined with recommendation 1 would really give planners what they asked for of making sure that they're aware of what corporations are assessing risks in their jurisdictions. The last two recommendations involve mechanisms for co-investment and direct collaboration. The fourth is a coastal resilience credit framework. Again, every company expressed interest in the idea of resilience credits. And recently, just a few months ago, Vera, which is a group that also works on carbon credit methodology, published the Vera Coastal Resiliency Methodology, which provides an existing verification structure for this work. The longer-term vision here would be a state-sanctioned market that couples adaptation projects to be aligned with hazard zones to, again, have better public and private alignment. And lastly, establishing a cross-sector network really emerged from a consistent theme that I saw in the interviews across both public and private, where there was a lot of curiosity and understanding what the other sector was doing. Additionally, both the public and private interviewees highlighted fragmentation within their own organization. Public planners talked about perhaps the climate work team having more awareness of SB 261 disclosures, and then also with the private interviews, there was a disaggregation between climate work, adaptation work, and governance affairs. So a reoccurring forum organized by either the Ocean Protection Council or within regional climate groups like the San Diego Regional Climate Collaborative could really put a pathway to having those conversations today and working on co-investment projects, data sharing, or other opportunities to really bring these folks together. To conclude, both sectors are assessing the same hazards and the same geographies and using the same science, but producing outputs that really can't talk to each other without the recommendations suggested here. And we already see examples of meaningful public and private partnerships, but we just don't have a way to scale them. The companies most willing to bridge the gap that emerge from this research are those with fixed coastal assets and existing government relationships like public utilities, hotels, and other group with critical infrastructure. For everyone else, the condition to unlock partnership is really focused around mission alignment and ensuring quantifiable benefits that can go towards resilience targets. I've learned that sea level rise is probably the hardest case for corporates. Again, chronic, long-term horizons, having mobile assets makes this hard for corporates to care about, but other hazards emerge from the interviews as potential immediate near-term opportunities. A couple of examples include water stress from data centers could provide options for hyper-local collaboration with water managers, and even wildfire was a topic that emerged in other interviews as well. So SB 261 was designed to bring transparency to corporate climate risk, but this research asks, how do we move that disclosure to action? And lastly, California's SB 261 is the most developed climate disclosure law in the country, but other states are also proposing their own climate disclosure laws, albeit focused on GHG emissions, but it's really making the policy window now to better connect public and private risk. And lastly, with the reduction of current climate, federal emergency work, and weather research in the US at a federal level, I think connecting our local, state, and private actors is even more paramount today. So lastly, I'll just quickly close with some really important acknowledgements. I'd like to give a huge thank you to my chair, Mark Merrifield, and the rest of my Capstone committee. Having the City of San Diego and CARB on my committee was just really integral to making sure that the research and policy recommendations were both practical and decision useful. And while they shall remain anonymous, a huge thank you to everyone that I interviewed. All those conversations were so invaluable to better understanding this and hearing from experts in the fields. And lastly, of course, thank you to the rest of my CSP cohort. You all have been amazing in helping me develop this project. A huge thank you to my family who's here today from Florida, and also all of my friends that I know are watching. So thank you so much, everyone. Oh, okay, my dad first. All right.
That was pretty good, Carl.
Thanks.
No, very proud of you. Hey, so what are you going to do next with all this? So you interviewed 30 public and 30 private, I think you said?
9,
right?
but thank you for
was
making it
9?
sound more.
Well, you
N-
can
9 across both, so 18 in total.
18
I'm still
in total.
interviewing more people.
So what are you going to do next? So you made a lot of recommendations. Did they see your recommendations, and are you going to move forward with this? What are you doing next?
Yeah, thank you. So I'm continuing to focus on further developing the research. An area that I'm still looking into, working on, is doing more interviews to get better results across industry, especially as I saw there was a lot of variation depending on the type of businesses and the type of planners. So trying to have some more interviews, as I'd really love to publish this work to make these policy recommendations implementable. But like I said, I was really fortunate to have the stakeholders that are the audience for my policy recommendations on my capstone committee, like CARB and cities in this coastal jurisdiction. But so I'm really trying to just focus on having greater data and getting the results publication ready to be able to share that. And honestly, like I've met so many people through this that I would really like to even like have a hand in putting together some type of cross network like I've proposed in this research.
All right. Our next presenter hails from Guam. That's unique and that's pretty cool. It's pretty close to, like, isn't it close to the Marianeras Trench, or that's that? It's very deep, and then at some point in Guam, like the difference between the bottom of that trench and the top of that little mountain in Guam is probably the largest mountain on Earth if we didn't have ocean. I don't know if that's true or not. I may have just made that up. Okay, Zane will maybe debunk me on that, but I want to point out that Zane has taken on a lot of important roles in his life. I think working for FEMA is extraordinary. We as a society value competence and compassion in terms of quick responses. Sometimes our longer term responses to chronic things starts to falter, but I can't think of anybody that I know who probably was better at that than Zane, other than other people that I've known who also work in that space. But what Zane is doing here is pivoting to a career associated with climate change, where I think he's going to have an amazing opportunity to get in front of the problem and help people implement solutions on the front end, so that maybe in 2060, 2070, 2080, 2090, all the plots of those climate change disaster books and movies with all those terrible weather events don't happen, right? Because we have smart energy policy. So moving from the response to the proactive planning. And I'll just say about Zane, obviously somebody who was tremendously respected by his cohort, by his director, by the faculty. And this, I'll just say, this is a voice that should be and will be heard going forward on issues about climate and energy. This is somebody who has a lot to say. So you're going to see and hear more from this guy. And he's going to make an important difference in just taking on this project about small modular reactors, which he'll tell you about. This is a solution for really, really, really hard to decarbonize sectors. So this is going from a really hard application of disaster preparation, like coming down after a hurricane's hitting and trying to help people get their lives back together, and then going through this intense one-year program and pivoting to a career that's probably going to be focused on hard to decarbonize sectors. And our next speaker is Zane Heather with a concise title, The Pathways to a Smarter Future. Zane.
One second, please. All right, good afternoon, everybody. Lovely to be here with you all. As Corey said, I have a lot to say, and I talk pretty quickly, so I'll try to get through this quickly here. I'm Zane Heather. Good afternoon. I'm excited to present on my capstone of Pathways to a Smarter Future. SMRs, or small modular reactors, and this is not the only time you'll see a pun within this presentation, so apologies to start. So this capstone focused primarily on evaluating the impacts of both policy and market conditions on the development, deployment, and diffusion of advanced nuclear reactors in the United States. And so the motivation for this project and why I was interested in advanced nuclear is because I'm not sure if you all have realized recently, but we are in a pretty interesting energy moment, and that's to put it lightly. Obviously, with the Strait of Hormuz being closed, all the headlines about data centers and electricity rates, we need rapidly to expand our energy access and portfolio while at the same time decarbonizing the energy sector. And you see some statistics up there. In the next 10 years, we need about 40% more energy throughout globally, while also decarbonizing the energy sector by about 55% to mitigate the worst impacts of climate change. So within this project, I was looking at advanced nuclear as a potential solution for that. And why advanced nuclear? Well, nuclear is historically safe, efficient, and clean. And when I say safe, usually those two things don't always go hand in hand in everyone's mind. I don't know if that's the right metaphor there. But as you can see on the graph, nuclear is historically much safer than the vast majority of generation resources and almost the entirety of fossil-driven generation resources. On par with solar and wind, nuclear only accounts for 0.03% of fatalities per terawatt hour of electricity produced. And that's even accounting for, as we think of the large nuclear emergencies, 3 Mile Island, Fukushima, and Chernobyl. Obviously, nuclear is a high consequence generation technology, so regulation needs to be strong and efficient, but it is historically much safer than the other alternatives. Additionally, nuclear has, one thing that's not covered in the study that is a real challenge that will continue to be worked on and solved in many ways is the radioactive waste piece of it as well. Next, nuclear is efficient. And that's really the value proposition of nuclear at large. So nuclear is about 1 to 3 times more energy dense. A nuclear reaction is 1 to 3 million times more energy dense than chemical reactions driven by fossil fuel plants. As you can see here, 1 pellet of uranium fuel, which is essentially the size of your fingerprint, has as much energy potential as 17,000 cubic feet of natural gas, 149 gallons of oil, and 1 ton of coal. And finally, nuclear energy is green. And while we don't think of, while uranium, the main component of nuclear fuel, is not a renewable resource like wind or solar, it is a carbon-free generation technology, and the life cycle carbon emissions of nuclear are on par with or lower than typical renewable resources like wind and solar. Okay, so we talked about the value proposition for nuclear at large. Now let's talk about SMR specifically, which is a subsect of advanced nuclear technologies. So here we have a summary. All right, so what is an SMR, or small modular reactor? It's all in the name. You've got the diagram there, and you can see they're not that small comparatively, but comparative to large nuclear reactors, they are much, much smaller. Large nuclear reactors power about 1 billion, large nuclear reactors provide about 3 times as much power as small nuclear reactors. Small nuclear reactors typically classified between 1 and 300 megawatts. They're modular, so the majority of the reactor components are designed to be built off-site in factory manufacturing processes and then assembled on-site. And then finally, like I said, they are reactors. They are fission reactors, and they use various degrees and types of nuclear technologies, from traditional technologies that we see in the standard nuclear fleet, which is light water reactors, the main premise of my presentation today, to advanced reactor technologies that have different use cases and technical components. All right, so what are the main competitive advantages of SMRs? Mainly, they are on the cost and scheduling reduction side. So like I said, they're traditionally smaller than typical nuclear reactors, traditional nuclear reactors, and they are built primarily off-site. That leads to quicker manufacturing, as well as less component parts that need to go into these reactors, leading to cost declines, scheduling declines. And then additionally, because of their size and footprint, they can be sited in various different locations that traditional nuclear reactors are unable to be placed. The main bet of SMRs as compared to legacy nuclear technologies is that the economies of multiple will trump the economies of scale. And so essentially the way we currently build nuclear is as big as we can go and cranking it as much as it can over the life cycle of that plant. That is not the operating procedure of an SMR, and we are sacrificing the size of the plant for the ease of manufacturing and the amount that can be manufactured off-site and then assembled on premises. So the main research question that I dived into are what factors on the market side and the policy side will influence the development, deployment, and diffusion of SMRs, and that approach took 3 distinct steps that led to 3 distinct analyses. The first one was on development, development focused primarily on the policy environment that would support initial development and deployment of SMR technology. Think of that as first-of-a-kind technologies, so proving the technology initially, and then getting to the first 10 or so units deployed in the real world. Next, I did a deployment analysis, essentially developing a parametric model that would look at the different policy and economic factors that would support essentially deployment and cost reductions of SMRs going forward. And then finally, based off those cost reductions, looking at how SMRs could potentially diffuse in markets throughout the US. So working through each of those components specifically, I'll talk first about development factors. On the development side, the main driver of development, so proving a technology initially and getting to the first 10 deployments of it, is policy. And the main goals of policy are fivefold. It's to prove the technology initially, so get to a first-of-a-kind technology. It is to de-risk and finance initial deployments, so getting to the first 10 or so risky deployments. And then finally, is to achieve scale and then enable a supporting ecosystem. There are three different types or specific types of policies that support this. You've got direct fiscal investment. It makes sense. It's the government spending money on a thing directly. You've got fiscal incentive, so think of that as subsidies or taxes to support competitiveness going forward. And then also you've got regulatory reform, which is what it sounds like, making it easier to build and site these things. This is a policy matrix that looks at specific policy interventions that have been used throughout the world to support advanced technology development and deployment. You can see on the x-axis we've got deployment support, on the y-axis development support. Most of the direct federal investment support initial development and deployment, while the other set of policies support deployment and ecosystem generation. Of note, in the past 2 administrations, the US has worked to support, to enable all of these policies minus one. At this time in the program, you probably know which one that is, and that is carbon pricing or carbon taxes. Historically, we do not like additional taxation in this country. All right, so the next stage of my review and my analysis was looking at a state-level overview of what the policy environment looked like. I did this by scoring different policies on a range of criteria, nuclear policies specifically, as well as current operating reactors, historic operating reactors within different states, and then recent nuclear plant closures throughout the US if they were driven by political means. As you can see, it's a much more diversified policy environment within the states, with several states that are pro-nuclear having active reactors and active development of SMR technology, and then a handful of states that are hostile to anti-nuclear themselves. Importantly, the main policies that lead to a hostile environment within states are an outright ban of new nuclear development, which we have in Minnesota. Additionally, you've got essentially effective bans that are contingent on the waste problem being solved at the federal level, which we have in California, Oregon, and Maine. And then also, you have another subsect of policies that is dependent on legislative or voter approval for new nuclear development. All right, so we talked about initial development factors, and now we'll talk about deployment factors. And essentially, the key questions of this analysis we're looking at what specific economic and policy factors would support the deployment and cost reductions after the first 5 to 10 SMRs were live. The way I did this is I built out a parametric model, and to inform that model, I used different markets as well as different market factors. It's important to understand part of the value proposition of SMRs are the different markets that it can approach, and the use cases that it has as compared to legacy nuclear or additional generation. When it comes to electricity generation, that's relatively straightforward, but one thing that is key with SMRs and nuclear at large is it provides firm baseload energy, which most renewable carbon-free sources do not, and it does so in a way that is much more geographically open, less limited geographically, which is the case for hydro and advanced geothermal. Next, you've got industrial process heat. One key component of next-generation nuclear reactors is they operate at higher temperatures, and those higher temperatures can be used to support industrial processes, which are historically hard to decarbonize sectors. Next is load following. If you have a high penetration of renewable resources on the grid that are dependent on geographic or geological or climatological features, you'll have a lot of variability in your electricity load throughout the day, throughout the season, throughout the years. And so SMRs can help really balance that load in a carbon-free factor, in a carbon-free manner that other renewable resources or carbon-free resources cannot. And the bottom three here are different subsects of market segments that SMRs can approach or that they can deploy into. Behind the meter can support large load entities like data centers, which is hot right now, as well as industrial facilities, and then microreactors and microgrid or off-grid resources help for very specific use cases like emergency response or off-grid communities. This is a very busy slide. I'm not going to ask you to digest all of it, but essentially these are the main parameters of my parametric economics, and policy model. There's 3 parameter types: design, economic, and policy. And then anything that you see with a range and a base case was essentially used to set up the bounds of the model themselves and look at a range of different scenarios based off of different economic policy conditions. I'll draw your attention to 3 specific ones here. The ones at the top were important for informing cost reduction models for overnight capital costs, and then these 2 right here were critical to inform the levelized cost of energy models that I use in the economic analysis. All right, so overnight cost of capital, or OCC, it looks at how much a plant would cost to develop and deploy if it happened overnight. So it's essentially just the baseline cost for development. It doesn't take in financing fees, doesn't take in construction fees or time in construction, and it's important to understand how capital intensive these are compared to other generational resources. As you can see, so the base case is the line in the middle, the range is depicted by the swath, and as you can expect, or we can expect based off my assumptions, around a $3,000 cost of overnight capital or overnight capital cost from the first deployment to the 100th deployment, and this is very dependent on supportive policy and market environments. One thing that's important to contextualize this is currently where solar and wind and combined cycle natural gas sit. So solar and wind are the most competitive renewable resources, and then combined cycle natural gas is the most competitive thermal resource at this time. And so it takes about between 30 and 40 deployments of SMRs for them to become competitive with other resources, especially in the renewable space. This isn't as important as the levelized cost of energy, which we'll go to now, but is an input into this model and helps understand the financial or potential risks associated with financing large capital projects. This is for levelized cost of energy, LCOE. What LCOE tells you is essentially how much you need to recoup in costs to make it worthwhile to produce energy from this resource. And you can see there's a very large margin of LCOE for nuclear right now, and it's very dependent on a supportive policy, mainly environment and learning rates. This is where nuclear, advanced nuclear SMRs become competitive with other generational resources. One thing that's important to note is solar and wind are some of the lowest LCOE, but it doesn't always capture the variability of these resources, and it takes about 10 deployments in the base case, but in the worst case scenario, it never becomes competitive with other generational resources. One thing that's important, and again, like I said, what we don't have in this country is carbon taxes. If you combine a $50 carbon tax on top of the policy packages to support nuclear, it is almost immediately cost competitive with combined cycle natural gas, which is the most effective of the thermal generation resources. And if we look at deployments specifically, like I said, it becomes almost immediately effective or cost competitive with combined cycle natural gas, and then also within the first 8 to 20 deployments, competitive with other generation technologies. Where does that put us within the growth rate, or what does that put us within deployments, or expected deployments within the states? Right about there. And this is the IEA's announced pledges for SMR deployments. The states, the United States is the blue line at the bottom. So by 2035, we should have a good indication as to whether or not these technologies are in fact becoming cost competitive with other generation technologies. All right, so we set up what is going to help with development, what's going to help with deployment, and finally, how will these diffuse? I'm going to walk through very quickly several inputs to a model I made in the geospatial diffusion model in QGIS, which is a GIS platform, and essentially takes all that information and then tries to depict where they diffuse depending on different feasibility and viability cases. I'm not going to walk through this one by one, but essentially this is measuring how feasible SMRs are based off geographic, operational, and infrastructure requirements. It's going to be a bit of a busy map here, but this shows you where can you put an SMR. Not where should you build an SMR or where would you like to build an SMR, but based off of just geographic factors and regulatory and siting guidance, where can you put it? Essentially, nowhere with a lot of people or with a big slope or limited water. Next, this is a policy layer that has been integrated on top of that, and this is where can you put an SMR, not just with geography, but also political economy. This is going to be a very busy map because I love busy maps, but essentially, again, this is all part of a model that you can build out and use and can be tailored to users, and this is looking at not only where can you put an SMR, but what sites can you select? You've got your site list on the left. Those can be toggled on and off based off user expectations and user criteria. And then finally, you've got where can you put these things? You've got specific sites that you can use, and then where should you put it? It's based off the viability. 2 viability models I looked at were electricity prices and carbon intensity as different ways to cite these things. When it comes to electricity prices, again, another busy map. This is taking all the inputs previously. The one thing I'd like to point out is SMRs become cost competitive with most generational resources fairly quickly in the first 20 deployments. So that's the majority of the map right there is covered by that based off the previous analyses. And then when it comes to carbon intensity, there are several, the diffusion would look differently, but it would be focused primarily on the Midwest and the South, where you have a large portion of coal generation within the United States. All right, so when it comes to the pathways of a smarter future, some of the big key findings is that it'll be very dependent on supportive policy in the development and initial deployment phases of SMRs, and that learning are going to be critical. Learning is going to be contingent, again, on being able to manufacture most of these components off-site and then assemble them on-site. And then SMRs can become cost competitive based off my analyses within the first 10 deployments without carbon taxes and almost immediately with carbon taxes. Limitations, this is a very immature and complex technological space and regulatory space. It's really hard to put in all the different factors. Additionally, political considerations and political, supply chain, and radioactive waste disposal considerations were not included in the analysis. And then finally, acknowledgements here. First, I'd like to acknowledge, I'd like to thank my capstone committee, my chair Ryan Hanna, Shani Chowdhury, and Dr. Josh Graff-Zivin. I'd like to acknowledge my beautiful wife, my family and friends that came from near and far to support me on this. None of this would have been possible without your support and love. Then finally, the CSP crew, my cohort, my colleagues, Corey and Jada, and everyone else that made this possible. It's been a hell of a year. Thanks. Probably have time for one question? No. One question, all right. Yes.
So Zane Heather, of those states that are possibly green because they're looking at this, are any states showing in their legislation? Did you come across any states that are actually actively looking at employing these?
Yeah, any state that has, we're going to go way back here, that is bright green in the policy analysis has some sort of supportive SMR legislation that's out, and several pilot projects have already been started in those specific states. Namely, Tennessee, Utah, and Idaho are the most forward-moving in this space. All right, thank you, everybody.
Wait, one more. Zane, one more? Well, I guess I won't ask him a question, but I want to commend him on his excellent taste in fashion, particularly the herringbone blazer. Your father must be very proud.
All right. Well, that was great. Thank you so much for that. And it's amazing, just, I've been in this role for almost 9 years, just the things we talk about and the pace at which technology is moving is rather incredible. Our next presenter, I've really enjoyed working with this student a lot. I would say that a lot of our meetings have taken on a very kind of conversational tone, and we've been able to talk about just a lot of stuff related to life, to politics, to policy, to energy, to technology, even math. Actually more about math lately than some other stuff. But Zihan worked at PwC in Beijing before coming here. He studied at a small university in the United States a few years back. And he's come to this program with the man loves cars. I'll just say the man loves cars. And the guy really cares about our environment. And the way the political system works in China is a little bit different from the way the political system works in the United States. So often finding common threads where we can obviously work together, but that's not the context we're talking about here, but where we can take policy priorities that might exist in both countries and tune those appropriately to the United States and to China. For example, China has a large industry producing EVs, so wants to put a lot of EVs on the road. and also has a large air pollution problem. In the United States, we have robust air quality regulation. We have, in some places, subsidies for EVs, but really we have yet to find a synergy where there's been an opportunity to deploy EV subsidies in a way where we not just think about decarbonization and adoption, but also about air quality. So some of the work that Zihan has done here, thinking about the United States and China and the comparative policy and politics of that, but also just thinking about how we can best optimize and deploy EV policy in the United States, jurisdiction by jurisdiction, in ways that'll catalyze more rapid deployment and deployment of EVs where we need the EVs, where there's a clean grid and where there might be air quality problems that the EVs might actually mitigate in addition to the climate change impact. So our next presenter is Zihan. Beyond Zero Emission Labels, a region-specific use phase assessment of electric vehicles in China and the United States. Zihan, the floor is yours.
Thank you, Corey. But I have to make a clarification first. I love cars, but I really love ICEVs, the internal combustion engine cars, the V8, the V10s, bring back the glory of Detroit, okay? Yay! So let me open my project first. Wow, there's a lot. There you go. Nope, it's not presented. Yep. So my project is called Beyond Zero Emission Labels. So let me ask you guys a question. How many of you driving EVs? Your family? Wow, there's a lot. So is there a question in your head that whether driving an EV will be really helpful for the environment? Is that question pop up in your heads? So we'll figure out whether or not driving EVs here in California or in the US is actually helpful for the environment. I've done the assessment of 31 Chinese provinces and then 51 United States, and to see whether driving it is a positive solution for the environment. So for the motivations, transportation is about 30% of the global emissions. So electrifying the whole transportation matters a lot to the climate. And according to IEA's newest data, global EV sales passes 20 million in 2025, and China, which is on the right, is colored in red, and then US in green, are over 70% of the car sales of EVs in 2025. And then both China and the US have a lot of different types of EV incentives, like tax credits, especially in the US, trade-in benefits, and also subsidies, direct subsidies to the consumers. So let's first look at the policies. For China, the EV policy support came in 3 phases. The first phase, I call it the demonstration phase. It's from 2009 to 2015 with big subsidies with a tax credits exemption to start the markets. And then moving to the second phase, the tipping point. So from 2016 to 2022, the subsidies are actually slowly cutting down with the fiscal pressure of these Chinese government goes higher and higher. And then moving to the last part, and it's the current parts, the central government actually decided to determine all these direct subsidies was actually ended in 2025, and then a national trade-in policy was actually later taken on. Then moving my camera to the US. So the US also had 3 phases. The first one, I'll call it origins. So a federal tax credit up to $7,500 was given to consumers, but actually these automakers lost the subsidies after they selling 200,000 of the models. So the best-selling brands like Tesla and GM Motors lose the subsidies first. So it gave these automakers a huge market pressure if they lost the subsidies from the consumers. And then to the second part is actually calling the IRA restructuring process. So the government actually decided to keep the $7,500 subsidies, But they removed the cap, and then adding on another restriction that asking these automakers to source their products and then manufacture in the North American regions. And then it's lowering the eligible models from 14 to like 4 eventually in the end of 2024. And then to the last part, in 2025, the federal credits were actually repealed entirely, and then leaving the policy choices to individual states like California. We have the Clean Car for All Act. So we gave the tax credit back to the consumer once again. And then, so both China and the US wants to electrify in their transportation systems. And then we share the same goal, but we actually have a shared blind spot at the same time. So if that the subsidies are uniform, that the same amount of money sent everywhere to all the consumers that are buying EVs, but these maps are actually showing that these environmental benefits, or to be precise, the amount of carbon dioxide emitted from the grid is actually different, regions to regions, states to states. Like the map showing on the screen, all these middle to left provinces, that's Yunnan provinces, they actually are heavily hydro power plants. So they generate their electricity from hydropowers, from wind farms, or from other renewable sources. And then if we compare it to the upper north provinces like Inner Mongolia, these states actually rely heavily on coals, so they are burning a lot of coals, making these emissions differ 6 to 2 times across the China's region. And then if we turn back to the US, so in the US, it's a relatively clear pattern that in the states located in the 2 coasts, it's actually much more cleaner than the states in the middle. So we rely on nuclear and renewable energies, and I think Vermont actually rely over 50% on hydropowers. So pretty good. And then if all these states are different like that, so driving EVs is actually have a lot difference of these environmental output in states like Vermont or driving a EV in Texas. And then, so there are some challenges. The first challenge is relatively simple. So most of the studies only look at CO2s, like the map I showed you previously, and skip local pollutants like NOx and fine particles like PM2.5, PM10s. And then second, most of studies assume EVs are usually heavier than ICE due to the heavy batteries. And then after I test the real data from the 2025 sales data, and I found that actually we are different in China and the US, and it actually reveals my assumptions. So my 3 research questions are, so how much does the benefits vary by regions? What drives the difference? And then how should the policy respond to this difference? Then to do these analysis, there's also 3 phases of doing this. Sorry, I love this 3 phase. So phase 1, I used the Fisher-Price model to forecast how many EVs each Chinese provinces and US states will have by 2030. And then phase 2, I calculate the emission difference between an EV and an ICE per kilometer drive across 4 pollutants. And then phase 3, I combine those environmental benefits, market share and size, and also local air quality into a scoreboard that actually ranks each region into a tier. And then the same method runs on both countries so we can compare them directly. All right, for the first part of the methodology, I use Fisher-Price model, and then here's why. Fisher-Price is built for one technology replacing another, which is exactly this case, EV replacing ICEVs. And then I reject two other alternatives. First is the base model. And the base model is actually building for launching a brand new products, which is not what is happening right now in the China and the US markets. And also, it asks me for 6 different type of factors, and then I cannot get the data from it. So we just use the simplified Fisher-Price model to do the calculations. And then I reject the simple exponential one due to it's way too simple. And then it actually will predict more than 100% of the car going electric, so which is actually impossible. So that's the reason I say no to the exponential. And then talking about the Fisher-Price, I actually gave it a ceiling. So all these models need a ceiling. So the realistic maximum EV shares for each regions. So I built it from some local factors. First, higher income actually raises the ceiling. So you have more money in your pockets, you have more willingness to buy a new car or trade in your old ICEVs. And then with a strong public transit, actually lowering the people's willingness to buy EV cars or any other car, since you can just use the public transit to go everywhere without a passenger car. And then third, the cold climate actually lowers the ceiling, since the cold temperature will actually cut EV's drive range. And then for the US, specifically, I add one more factor, is the truck culture. So because pickup trucks and large SUVs are really, really a lot of it in the US. So people are tend to not willing to adopt an EV with an ICEV, since you guys have the truck culture, and then we don't have a lot of these truck model of EVs in the markets right now. Only Tesla, Cybertrucks, and then the Rivian. And then China don't have that barrier actually. So this one is the US only, and then it's actually lead to a later result that US is actually EV cars are heavier than the ICEV cars. So quickly on the data, everything is relatively official. Government grid factors, EPA vehicle standards, and registration records. I would say US data are way too transparent than the data I got from China. So I have to find, I can find all these data from EPA, and then with 2,000 rows of the grid data from EPA, I can just get whatever I want. But for China, a lot of these data are actually hidden into different case studies. And then these companies are not willing to publish these data, no matter the drive range or the or how old is the fleet age. The data I have to find it from a third party or gathering by myself through websites. It's just painful. And then key findings. Yay. So 3 findings I got. First, the carbon benefits and how much it actually varies. Switching to an EV actually cuts CO2 everywhere, sadly. And the size depends on the grid. So in China, it ranges from 56 grams per kilometer in this coal-heavy Inner Mongolia to up to 137 in hydro-rich Yunnan provinces. And then in the US, it's from just 32 in West Virginia to up to 205 grams per kilometer in Vermont. So 7 times the difference. And then on average, the US saves more CO2 because the American ICEV, the internal combustion cars, remind you guys, are actually bigger, heavier, so they burn more fuels eventually. Second is the most surprising one, the NOx divergence. So in China, switching to an EV actually make NOx worse in 16 out of the 31 provinces. So China have a relatively young fleet age. Switching these vehicles, even with these grid mix or grid emissions are the relatively lower level, switching these new vehicle SUVs is actually worth the scenario in China. And then In the US, it actually reduced switching from EV to switching SEV to EV, actually reduced NOx in every states. Even the coal-heavy states, the two countries actually go into opposite direction on the same pollutants, since you guys don't have the fleet age requirements here in the US. So I love the car culture here in the US. You can see an old 1970 BMW run on the street. That was so fun to watch. And then, ooh, I lost it, sorry. So yeah, the last part, the vehicle weight reversal. Research always assume EVs are heavier. You can look at ResearchGate and find out all these research actually assume that EVs are built to be heavier since they have a heavy battery. And then after I do the analysis with top 50 selling EV and SEV cars in the US and the China markets and found out actually it's not the case. So in China, the assumption is actually no longer true. EVs and SEV almost have the same weight because so many small city EVs sell in the Chinese market. But in the US, EVs are 50% heavier because most of the EV model sales in the US markets are SUVs, and then they're heavy. So they are generating more tire particles, PM2.5, and brake particle, PM10s. And then back to my policy toolkit. So instead of the flat subsidies, I match the policy to each region's tier. And then the top tier, priority and targeted. So states should get a stronger push. Food subsidies, charging stations, and public fleet lead the way. And then the bottom tier are different. For grid-first regions, almost everything is different, except one thing, clean the grid first. So because in these states, pushing EVs, switching EVs is actually move the pollutions from your car to the energy power plants. Yep, and then let's take a deeper look at the China's case. So each bubble actually represents a province. Horizontal axis is the market size, and then vertical is the environmental benefits. So the ideal corner is the top right. These three provinces. Sorry, the Guangdong province is actually kind of like an outlier of these maps, so it's not look great. So these states is actually the one that are ideal for switching ICEV to EV, since you have a great market share, and then you have a great potential of switching EVs to ICEVs to EVs. And then the key results is actually China have 5 provinces in tier 3 and 4 is the fourth quadrant. So in these states, provinces, switching to EVs actually carry a local pollutant penalties. So for them, EV incentives should come after the green cleanses first. So not before. And then we look into the chart, same chart for the US, and here is the contrast. The US has 0 states in tier 3 and 4 because the American fleet is relatively old and dirty. And then replacing those cars improves local air qualities everywhere. And then even on the coal grids. So taking the two countries together, we face different problems. So China have place where pushing EVs may lead to a backfire, and then the US have none. So for the US, the task is just prioritizing which states comes first. And then, side by side, China's charts, the US, the US don't have penalty states. And then, but the one questions pop up. So who gonna pay for the incentives, or who gonna be the one that gave these EV automakers more money? So China may have a potential answer to it. It's called the dual credit system that make automakers that sell too many ICEVs buy credits from the EV markets. So the industry actually found the transition itself without the government money. So the US will copy this now that the federal subsidy is gone, and we can just weight the credit value toward the regions with the EV with the best potentials. And then some limitation, future work. I only look at the driving phase or the use phase, not on the production phase or the end phase. They are way too hard for me to quantify them. So, and then I use a snapshot of today's grid, our grid no matter in China or the US, our grid is become cleaner and cleaner, so our data will change day to day. So I think that's it. I want to say thank you to all of my cohort for the love and support you guys gave me. I want to thank you first, and then to my lovely, beautiful wife on the second floor for the love and support you gave me, and then thank you for doing the beautiful map on the previous page. Yep. Questions?
Thank you so much for your presentation. I loved it.
Thank you.
I was really interested when you showed that China was actually, the NOx was increasing when you have more EVs. And it was making me think of my chemistry class. I don't know if you know this, but when you have higher NOx, it could be a VOC limited regime, so maybe increasing volatile organic compounds. So I don't know if you came across that, but is China trying to implement more green spaces or more nature to try and offset the higher NOx emissions?
Well, you actually call it NOx, right? I call it nitride. Oh, but NOx is make more sense. So China actually not having a specific policy to offset the NOx, but we do see that the greening on this cities or on the larger province level, green space are become more and more. So I don't have the contrast right now. So we used to have a huge PM 2.5 problems during before the Olympic Games. And then thanks for the US Embassy is actually the first one to bring up the concept of PM 2.5 to the whole Chinese society. So we used to have a huge air pollution problem. So with these policies on not only on the ICEVs or on the coal-fired plants, we have a stricter and stricter emission standards. So it actually lowers not only the NOx, but also the SO2 or carbon dioxide, all these pollutants lowering down to a relatively low value. But China have 1.4 billion people, and then there is a huge energy challenge to support these people to survive, right? And then it's just impossible for us to just switch in suddenly from coal-fired plants to directly to hydropowers or more sustainable renewable energies. It's just impossible. So I will say we are the biggest polluter, but we are actually trying our best to lower it a little bit.
Great job, Zihan. I've got to keep it quick with my intros now. But I've got to say, on this one, to be honest, I don't know that I've ever had more fun working on a capstone. And I'll say that because this connected with me in a lot of different ways, not just the science of it, but also the persistence in the face of adversity and snark and reductionist thinking, and the hope and the reality-grounded hope that the Northeast United States will substantially decarbonize relies on a lot of technologies, but one essential piece of the puzzle is offshore wind. And Christina did a remarkable project on offshore wind that I think is going to have a lot of impact. Quantifying the economic and climate case for offshore wind's displacement of natural gas in New York State from a town known as Oyster Bay, Long Island. Here's Christina.
Thanks, Corey. My main goal over the summer was to convince Corey that offshore wind was worthwhile, so I'm glad to hear that maybe I did that. So while I pull up my presentation, just wanted to, quick caveat that I've been having a quite persistent cough, so I apologize if that happens today.
But good afternoon, everyone, and thanks so much to all of my peers for all of your excellent presentations so far. Really been learning so much and really looking forward to the rest of the afternoon. My name is Christina Guerra. I'm originally from Long Island, New York, and my research is centered around understanding the impacts of offshore wind energy for New York State, based off of data from the nation's first commercial offshore wind project that's located about 35 miles east of Long Island. For the interest of time, I'm just going to skip my agenda because I have a lot to say. So essentially, I'll dive straight into the problem statement. The problem statement is that despite proven technology, strong wind resources in the Northeast, and statewide statutory mandates alongside a statewide political climate that's pretty favorable to offshore wind, New York's offshore wind build-out has faced many challenges so far. Public discourse around offshore wind has become increasingly prominent and distorted by scientifically unsubstantiated claims. A lot of that is around impacts to marine mammals and birds, also around intermittency concerns and high costs. And in addition, as I'll get into throughout my presentation, there's a very strong network of documented research that has traced a significant share of misinformation to a network of organizations that have financial ties to incumbent fossil fuel industries. And I'll be kind of talking through my presentation at why that might be occurring and what the financial stake is to these incumbent industries if offshore wind persists and actually is successful. So meanwhile, there's comparatively little public attention thus far devoted to the economic benefits of large-scale deployment of offshore wind. A lot of the focus has been on the high upfront costs, but not as much on how these the different economic situation around wind and renewable energy can actually reduce energy prices, so I'll be talking through that as well. And this study evaluates the first year of South Fork Wind, which is New York State's first utility scale project, and it quantifies the economic and climate case for scaling the state's offshore wind build out to its full statutory target based on the state's climate law. And then finally, this analysis will also estimate the financial stakes that offshore wind has for the incumbent natural gas resources, as I've mentioned, in downstate New York, which is New York City and Long Island, and it provides a quantitative context for understanding where this opposition might lie. So all of my modeling was done in using the Python language in Google Colaboratory, and rather than approaching this as a one research question, I set up my research into 5 different sections and asked a different research question in each section. So I'll be going through the different sections and discussing my research question and the results that were discovered. And I used a mix of New York State data, public from the NISO grid operator, and also the federal government power plant operation resort data from the EIA. So first, I wanted to give a very high-level overview to introduction to energy. Also, I'll be going into a very high-level energy economics discussion for those of us in our audience that are not as familiar with energy and energy economics. Zane touched on this a little bit during his presentation, but power plants, both renewable and non-renewable, work by converting an energy source into electricity, and this can be done either through combustion, which creates steam that spins a turbine that converts, again, this fuel source into electricity, or it can be done via natural processes that don't rely on combustion. So the renewable energy resources either rely on, again, using natural forces to turn the turbine or to convert directly sunlight into energy via solar panels, et cetera. And the energy source determines how the turbine is powered. So again, the ones that rely on combustion, so the non-renewable energy resources like coal, oil, and natural gas, emit carbon dioxide, which, as we know, is a greenhouse gas, and greenhouse gases trap heat in the atmosphere. So more carbon dioxide emitted, more heat trapped, and therefore more implications for global warming and climate change. In contrast, renewable energy resources like solar, wind, hydroelectricity, and geothermal use nature to generate electricity, so they don't rely on combustion, there's no fuel inputs, and there's near zero to zero greenhouse gas emissions during operation. So this part is where it gets a bit technical, so just bear with me for a moment, but I just want to really give an explanation of how this works in terms of the economic benefits. So we know that renewable energy has no fuel inputs, so the cost of generating electricity is essentially free once the system is built and all of the other costs are involved or already accounted for. So this slide explains the basic economic model for how renewable energy resources enter the grid and reduce fuel costs. So the price of operating a power plant ultimately determines which fuel source will be dispatched or called upon at any moment, and generators with the lowest operating costs are generally dispatched first. So when energy source is available, so for example, if solar or wind is available, it's generally called upon to dispatch first because there's no marginal operating cost to call upon this energy source. And then as a result, it displaces the highest cost operating fuel source that's at the top of the grid. And there's actually a really interesting relationship here that the energy sources that typically are zero emissions are also the ones that end up having the lowest marginal operating costs. So as you go up the grid, as you go up the dispatch stack, it actually becomes more expensive to operate each fuel source and also produces more emissions as a result. So that's essentially just some background on how renewable energy sources can actually save money on fuel cost. Wanted to give a quick introduction to offshore wind. So you can see from the NREL map that the Northeast United States, with the exception of perhaps Humboldt in Northern California, is the region that has the most optimal offshore wind resources. So that's one of the reasons, in addition to an optimal continental shelf depth, that we are starting to generate the most projects thus far, because there's only 4 projects thus far in the United States that are actually under construction or completed, and 2 of them are in New York State, so I'll get into that in a moment. But offshore wind is a large-scale clean energy source. It, again, reduces dependence on fossil fuels. It can generate significant electricity in areas where solar energy potential is constrained by climate or latitude, so again, like in the Northeast. But unfortunately, development has faced significant barriers, including federal policy uncertainty, stop work orders, and permitting instability. And further, since projects are generally located in federal waters where the strongest wind resources are, they also must navigate state, local, and federal regulatory landscapes, which adds another layer to the complications around this technology. So I wanted to quickly provide a map to contextualize where these projects that I'll be discussing. So offshore wind is a critical strategy, part of New York State's climate law. New York State has a legally binding mandate of 9,000 megawatts of offshore wind capacity. However, the only plant that is currently under operation is South Fork Wind, which we will be talking about today. So unfortunately, a lot of the projects thus far have been halted or terminated due to a number of things that we will be discussing throughout the presentation. There's also a few projects in New England that we will not be focusing on since this is a New York State presentation, but just wanted to, again, give a little bit of context to where these projects are and what the federal landscape is around offshore wind at this time. So the first section of my analysis was reflecting on the first year of South Fork Wind. So South Fork Wind is New York State's first project under this climate law. It's really important because it's the first project that actually generated electricity for the country. So it provided some really critical empirical evidence that we didn't have before that this actually worked, because previously it was just projections. So we didn't actually know how it would function in reality in our country. So my research question was this section was, how does offshore wind perform under real world operating conditions in New York's electricity grid? And to what extent does it displace natural gas generation and reduce CO2? So we found that the year 1 of the project actually generated enough electricity to power 70,000 homes on Long Island, and it generated electricity 92% of the time, at least a little bit of electricity that was able to be used. And then despite only representing 3.6% of the total capacity of all of the plants, it displaced an estimated 7.3% of natural gas plants, which means that it actually operated at nearly double the average utilization rate of the existing natural gas fleet. And it avoided enough CO2 to basically take about 50,000 cars off the road. So my second section is using this data to project into the future the impacts. So the 3 kind of scenarios that are central to my analysis are confirmed projects, which are the 3 that I discussed, the 1 South Fork Wind and the 2 that are currently under construction. The second scenario, which is recontracting of previously canceled projects. So if New York State essentially takes those projects that had already been canceled and recontracts those and builds out, that's scenario 2. And then scenario 3 is full achievement of the state's climate law target. So again, the left-hand panel here represents net consumer savings under each scenario from offshore wind displacing natural gas. This also includes the EPA's 2023 social cost of carbon estimate, which is essentially the estimated dollar value of economic damages caused by emitting one additional ton of CO2. So we see that even after accounting for offshore wind's initial upfront project costs and the contract prices, the displacement of natural gas actually saves consumers money. And again, you can see from the bullets at the bottom that these currently contracted projects, so the scenario that we actually will be seeing in the next few years, are projected to reduce wholesale electricity costs by almost $700 million per year by 2027. And then that's about $5.9 billion in cumulative savings by 2035. So the next slide shows the emissions reductions benefits from offshore wind displacing natural gas. So under my analysis, I used a range of CO2 estimates because New York State has a variety of natural gas plants that have different levels of efficiency. So the natural gas plant's efficiency determines how much CO2 it might emit. So if offshore wind is displacing an older, less efficient plant, it would yield more climate benefits than a newer, less efficient, or a newer, more efficient plant. So across all modeled scenarios, we see that offshore wind reduces reliance on natural gas while producing large-scale CO2 reductions in the state's most fossil fuel-dependent regions. And that's because downstate New York doesn't have the same solar capacity as upstate New York, and we also are constrained by transmission due to New York City. So we have to import all of our natural gas or do local combustion there. So I think up until South Fork wind, it was more than 90% reliant on natural gas in the region. So the next slide talks about the economic and climate costs of project delays. So my question for this part of the study was, what is the quantifiable economic and climate cost to New York City and Long Island consumers when offshore wind projects are delayed or fail to be procured? And this is kind of like the pivotal part of my analysis, and it really shows that the cost of not building offshore wind is actually very measurable, and the federal policy landscape impacts projects coming to fruition both directly and indirectly. So the left-hand box is kind of the direct impacts, and the right-hand box are the indirect impacts that yield to this procurement gap that we discussed. So the direct impacts via federally mandated delays have resulted in nearly $1 billion in lost consumer savings, and it also cost consumers almost $6 billion in cumulative foregone savings by 2040, just from delaying these projects by 2 years. And then it will force us to endure about 3.7 million tons of additional CO2. And the indirect impacts are basically as a result of uncertainty discouraging developer participation and the canceling of previously awarded contracts that would basically ensure that folks don't want to continue to participate in this process, which has widened the state's procurement gap. So projects that were supposed to have been built simply never were, so those benefits were never realized. And since New York State has currently secured only 21% of its 9,000 megawatt target, leaving the remaining procurement gap unresolved results in $1.15 billion in lost consumer savings every year and 4.32 million metric tons of unrealized reductions annually. And that's, again, from not meeting its mandated statutory targets that the state had already agreed upon. So essentially, this determines that federal delays are equivalent to pay an extra $6.70 a month in electricity bills through 2040 for each person in the grid that is relying on electricity. So this is kind of where I pivot into discussing how the fossil fuel industry plays a role in this. So I really want to drive this point home by saying that every dollar that consumers don't save in their electricity bills because of offshore wind delays is a dollar that continues flowing into the natural gas generators and really benefiting those industries. So the annual fossil fuel industry revenue per my analysis annual fossil fuel industry revenue losses reach approximately $1.2 billion per year under the full build-out. So just to really drive that point home, if New York meets its statewide mandated offshore wind deployment policies, that results in over $1 billion a year in lost revenue for the fossil fuel industry. So they really have a vested interest in keeping their industry alive, which jumps to my next point, which is the fuel for misinformation. So This is something that is pretty dear to my heart, as I spend a lot of time on the beach. And I spend a lot of time on the beach, especially in the mid-Atlantic, where a lot of this misinformation is really rampant, and especially seeing it in surf shops and at places where you'd think that people care about the environment and care about the whales, care about, decarbonization, et cetera. This industry has really done an excellent job for them in essentially, I don't want to use the word gaslighting, but essentially confusing everyone and making it seem like offshore wind is doing all these terrible things, but really it's just a way for that they can market it to benefit their own pockets. So just a few examples. In New York specifically, one group called Protect Our Coast Long Island, which sounds pretty green and whatnot, they actually had a really intentional role in this process. So they filed formal regulatory challenges against Empire Wind state permitting processes, and they commissioned a study claiming the project would cost ratepayers $14 billion, but they did not include any of the fuel reductions that I included in my analysis. So they completely ignored every energy economics 101 that we learned about in school here. And this was a figure that, again, omitted the actual data around actually what the benefits of offshore wind are. And they also simultaneously promoted claims about whale mortality, electromagnetic health risks, and then they also have an information sharing relationship that's proven with a fossil fuel funded think tank, to say the least. So also a few other notes on here about the Trump administration paying a French company $1 billion in taxpayer funds to cancel its offshore wind leases in New York, reinvest in oil and gas. These are information that we know and we see, and it all comes down to the lost revenue that offshore wind would displace. I'm not going to go into this because I'm running out of time, but basically you can see that there's a lot of money at stake. So the main takeaways here is that the fossil fuel industry has $9 billion in revenue at stake in terms of the full build out, and it's investing money to protect it. There are multiple organizations opposing offshore wind in New York that have documented links to broader networks that receive funding from fossil fuel industries. And even after adjusting for build-out costs, consumers still save money with offshore wind, and it works even better than planned. So just wanted to give a few acknowledgements. So just wanted to say thank you to everyone I've spoken to about this research over the past few months. I've learned a ton. I also wanted to special thanks to the stakeholders that I'm working with in New York at the New York Offshore Wind Alliance, Nick and Alicia. They've also connected me with the Sierra Club, who I'll be working with to kind of tighten up some of this messaging and use that because the Sierra Club really cares about how offshore wind can displace natural gas. What else? And okay, I also wanted to, as everyone else has, thank our incredible cohort. I also wanted to thank my parents and siblings for coming all the way from New York to hear me talk about New York in California. And finally, to the CSP team, to Jada for all of your incredible support and your always bubbly attitude and whatnot, and to Mark, because even though you weren't on my committee, I wouldn't have been able to do this analysis without having taken your class. And then finally to Dr. Corey Gabriel for providing a lot of clarity during the initial noise, and for all the gentle encouragement, and for really believing in me in this project, even when I felt like I was very behind everyone else. And most importantly, for teaching me that you can be both a scientist and an advocate. Thank you. And to Chelsea for dressing up like a wind turbine with me. So yeah, I don't know if we have time for any questions, but. Great.
Thank you for that incredible presentation. I have a question on scalability,
Yeah.
and if you did any of the economic research on how many of the offshore windmills needed to be installed, as well as the infrastructure with it to support long-term impact in New York.
Yeah, so that is in my project. It would probably take me way too long to explain it right now, but essentially what we found from this analysis is that actually the recontracting scenario provides the most net ratepayer benefits, because the actual statutory target build out would require some more expensive contracts. But if we were to get to the recontracting scenario that we were at before, that amount of build out, kind of like Zane's presentation, you saw the graph with LCOE, that's the situation that would result in the most ratepayer benefits. So that would be, I think it's about you can probably see it on there, I don't have my glasses on, but it's like 5,898 megawatts would be the optimal goal. And I think the really interesting thing is that the industry had such a really impactful role on dismantling some of these contracts that would have gotten us to that place where you would see the most reductions. And right now with South Fork Wind, it's too small to show, and it's relying on a bunch of like above market contract mechanisms to see those reductions. So if I were an evil genius, I would think that I would say that having some of the empirical evidence around South Fork Wind would benefit them, because they could say, oh, it doesn't actually benefit ratepayers, but if you scale it up, it starts to. So that's why they have such an interest in preventing the scalability from happening. Cool. Thanks.
All right, so we are super time constrained. Great job, Christina. We have what's planned to be a short break coming up, but it's going to now be a super short break. Let's reconvene here at 3:25. Sorry about that. That's 4 minutes from now, and I'm going to start talking at 3:24 and 59 seconds. So enjoy your break, and I'll see you soon. right, welcome back to those of you making your way back into the room. Thank you so much for your attention throughout this. I know we've moved rapidly from presentation to presentation this afternoon. We really appreciate everybody who's been able to stick with us all day today. It is a long day, but it's an exciting day. And if you see the whole program, you see how everything sort of fits together, right? We have people talking about how to engage the public on climate change. We have people talking about policy solutions on state, local, and even international levels. We have people talking about emerging technologies like the small modular reactors. And we have an excellent opportunity here at Scripps if people are interested in how climate change impacts the ocean, the coastline, the atmosphere, urban regions, agricultural regions, those opportunities to hear about those impacts and learn about the range of policy responses in those systems. They exist in this program, right? And these students, for those of you who are in the room, everybody doesn't need to hear this, but these students have to go out, right, and connect with committees and connect with stakeholders. And that can be intimidating, right? And that can be a very, very challenging part of this project, not just to initially vet an idea, but to get a committee of experts to be deeply engaged about working on a specific problem is hard. And everybody in the group this year managed to accomplish that. And that's some of the alpha of this program, I think, and why our graduates often end up doing so well, right? Is there's no set academic, you complete X, Y, Z. You have to do this project. And this project requires creativity, it requires discipline, it requires organization, it requires interpersonal skills. And all of those things, from the organization to the leadership to even the management of a committee and delivering this presentation. This is all stuff that people do in the course of their careers in the private sector, in the public sector, in academia. And so I'm proud to be part of this, and I'm seeing more and more people start to trickle into the room now, thanks to Jada's, and thank you, Jada, for all of the amazing work today and setting up.
Loves it. I know everyone loves the chime.
Yeah. So if we could go ahead and try to get everybody back in the room, because I don't think you're going to want to miss Greta's presentation unless you have some like AI agent set up to like go ahead and like process all of this for you, and you trust that outsourcing. But I think we're probably a little bit off from that unless you have your own server powered by like the latest version of NVIDIA chips. But I don't know. So I'm seeing that we're at about 50% capacity right now. So I am going to begin introducing Greta. So I didn't immediately do this, but I really loved meteorology when I was a kid. If the world had been set up before me in a way that was more linear, I feel like I could have said when I was 4 or 5 years old, I'm going to be a meteorologist, 100% chance. And I remember when I was a kid, I went to school, but I did spend a little bit more time in the principal's office than the average student. Unfortunately, maybe not that much time, but I was a little bit rambunctious. But one thing I was very attentive to was the Weather Channel. And I remember from names like very few people, if any, will know this name, John Hope, an expert on hurricanes, who was a big star on the Weather Channel in the late 80s and early 90s. Probably the first time I had ever heard an expert explain how tropical cyclones work. And then moving forward into the future on the Weather Channel, many of you have heard of Jim Cantore, who became very famous, but these Weather Channel hosts, from Kim Perez to Dave Schwartz to many other people in the early mid throughout the 90s into the 2000s, these were my science teachers, right? How the physics I was taking at school, the way I got engaged was by people who were experts in physics, meteorology, some people with math degrees, all sorts of stuff at places like the Weather Channel, making science digestible for humans and helping regular humans make decisions about weather that would impact their everyday lives. So a lot of inspiration from meteorologists. So I think that the reason I'm here and the reason I'm a scientist is largely because of scientific data and physical scientists talking being available in the media. And Greta completed a meteorology degree and loves meteorology, but she's going to be working, starting very soon, as a consultant and working in the energy space. And I was her advisor for this capstone, and guess what? It's not really about meteorology per se. It's about artificial intelligence, which is a massive, massive emerging opportunity and threat. And as we move forward through the next 5 to 10 years, we're going to see the ratio of our energy footprint that comes from AI, the amount of everyday tasks that are handled by AI are going to grow exponentially. And this project is an important step in understanding what is the state of AI now and how is it impacting the grid and how is it going to impact the grid in the future. So our next presenter, Greta Schultz, who's using all the power, exploring sustainability in data centers in Illinois. Greta, the floor is yours.
All right. Thank you, Corey, and thank you all for being here. Again, my name is Greta Schultz. My capstone is called Who's Using All the Power? And I was exploring data center sustainability in Illinois. I knew going into this program that I wanted to do something where climate science and policy really couldn't be separated from one another. And so data centers turned out to be a perfect case study for just that. It's an industry that's quickly reshaping our energy system and our climate at the same time and doing it largely out of public view. Now, the public conversation around data centers tends to go one of two ways. Either they're framed as an economic success or an environmental disaster. And I didn't find either of these very helpful. So what I set out to do was more like a myth-busting exercise. Take a look at the concerns, look at them against the evidence, and then be honest about where the data supports alarm and where it doesn't. The driving question behind everything for me was, is Illinois prepared to manage this growth? And if not, what would it take to get there? So what actually is a data center? At its core, it's the physical backbone of the digital world. These facilities run 24/7, 365 days a year, and never turn off. The largest ones are called hyperscale campuses, and these can draw hundreds of megawatts of power, which is comparable to a small city. This is a picture that I took in Volo, Illinois, of Teresa Technology Parks, and it's a hyperscale facility built for hyperscale AI workloads. And just seeing the sheer size of it in person really put it into scale for me. So why is this happening in Illinois? Well, there are 4 main reasons. The first is nuclear power. Illinois generates more nuclear than any other state. It's about 53% of its electricity. That's reliable, low carbon, around-the-clock power, which is exactly what data centers need to operate. The second is fiber infrastructure. Chicago is one of the best connected cities in the Midwest. The third is land availability. There are large amounts of open land already near existing transmission. And then the fourth is policy. Illinois' commitment to 100% carbon-free electricity by 2045 is very attractive to companies with clean energy targets. So basically, Illinois checked every box and the industry noticed. So Illinois has been booming. As of early this year, Illinois has 108 operational data centers. 24 are under construction and 51 are in the planning stages. So this is a map that I made, and it focuses on just 25 key facilities in northern Illinois. The dots are the data centers, and they are sized by their significance and colored by their operational status. The lines are the high voltage transmission infrastructure, and the background shading shows 2 different regional power grids in the state, PJM and MISO. So when we zoom into Illinois, into Chicago area, you can see the pattern pretty quickly, that these facilities cluster around the city center and then fan out to O'Hare and the surrounding suburbs. And this isn't random. The grid really shapes where they can and can't be built. So all that growth is putting a tremendous amount of pressure on the grid. By 2029, capacity shortfalls are projected to reach northern Illinois and then will hit the southern part of the state by 2031. By 2035, data centers will go from 3% to 13% of Illinois' total electricity load. And then by 2040, a projected 30% increase in statewide demand. A big part of what's driving this is AI. US data center capacity has roughly doubled over the past decade, and it's projected to double again by just 2030. AI workloads are far more energy intensive than just regular cloud computing, so they're accelerating everything. So every major projection agrees that demand is growing faster than institutions are designed to manage it. And this isn't something you'll never see. It's already showing up in people's electricity bills. 70% of the $9.3 billion increase in PJM electricity costs in 2025 was driven by data center demand. Some ComEd and American customers said they saw triple-digit increases in their monthly bills that same year. So when we talk about data center growth as an economic opportunity, and it is, we also have to talk about who's paying for the infrastructure that makes that possible, because right now that cost is being passed off to ratepayers. Now I want to shift to part of the story that I think gets the least amount of attention, which is climate risk. These facilities will operate for 20 to 30 plus years in a climate that's going to look very different from the one that we have today. I've identified 4 primary stressors that will shape how Illinois' changing climate intersects with data center operations. The maps in this section were created in partnership with Monarch and Climate Weather Intelligence, who were part of my Capstone Advisory Committee. So their data and mapping were a huge part of this analysis for projections specific to Illinois. So starting off with heat. Data centers generate massive amounts of heat through their constant computation, and their cooling systems rely on the surrounding environment to remove it. So as ambient temperatures rise, those systems work harder, draw more power, and get pushed towards failure at exactly the moment when demand is highest. And we've already seen this go wrong. In 2022, Twitter's Sacramento data center went completely offline during a heat wave. That same summer, Google and Oracle both went down in London when temperatures hit 104. These were facilities that were designed around historical temperature ranges that just no longer hold. So this map shows the mean annual days above 90 degrees with the data center locations overlaid. Chicago's on the lower end, but we don't read that as low risk. The urban heat island effect can still add several degrees above the regional baseline. Days above 95 degrees in northern Illinois are projected to jump from just 1 to 2 per year to as many as 10 to 60 by 2090. The second is flooding. Heavy rainfall events have increased by about 40% in Illinois, and Chicago's stormwater infrastructure was built for a very different climate. Most data centers are built with a lot of underground infrastructure, all of which are vulnerable to relatively shallow flooding. So this map shows extreme rainfall is actually more frequent in the southern part of the state, but frequency isn't the point. Even a small number of high-intensity events can overwhelm stormwater systems, and the areas most attractive for data center development typically have the oldest infrastructure and the least capacity to manage it. Now, the third and most important is drought and water stress. Large data centers can use up to 5 million gallons of water per day. In 2025, 86% of Illinois was in moderate drought, 43% was in severe drought, and multiple rivers hit no-flow conditions. Now, looking at this map, unlike the heat and precipitation, drought doesn't follow a clean north to south gradient. Northern Illinois shows the heaviest cumulative drought burden in the state, so that's 60 to 100 plus weeks of severe drought over the past 25 years. And this is exactly where a majority of the state's data centers are located. These facilities with the greatest water demand are in the part of the state with the most sustained drought pressure. And then lastly is extreme cold. Polar vortex events can freeze outdoor cooling towers, pipes, and backup generators that just aren't designed for sub-zero temperatures. During the 2019 polar vortex event, MISO issued a maximum generation alert, and Illinois saw widespread grid stress. Winter Storm Fern this past winter in January pushed PJM demand above 130,000 megawatts for 7 straight days, which broke a record. The DOE issued an emergency order to curtail the large loads, including data centers. And switching to backup diesel isn't smooth. If everything kicks in at the same time, it can spike demand as opposed to reducing the strain. So across all 4 sectors, the main idea is the same, that these are long-lived facilities that are being built into a climate that's already changing. Now, water deserves its own moment. This chart I made compares the daily water use for 500 acres of irrigated corn, which uses about 1.5 million gallons of water a day, compared to a city of about 30,000 residents, which uses 3, and then a hyperscale data center at peak cooling can use up to 5 million gallons of water a day. So the point here isn't precision as much as it is context. Data centers sit right alongside the kinds of users that water systems were historically designed around. This picture, again, was from Volo, Illinois, of a water tower sitting right next to the data center. That water comes from the same systems that everyone else is depending upon. So what is the industry doing about this? They're doing some things, but it's not nearly enough. The largest facilities are operating efficiently. They have renewable energy credits that are being widely adopted. There are liquid cooling pilots and reclaimed water experiments happening. But efficiency gains are being outpaced by demand growth. Buying just a year's worth of renewable credits isn't the same as running on clean energy in real time. In a sector that's scaling this fast, voluntary measures just aren't enough. So how did Illinois get here? Essentially, the state attracted this industry without ever building a framework to manage it.
Back in 2019, a data center investment program created major tax incentives. And over the past 5 years, that meant $983 million in tax revenue. So it worked as intended. But by 2025, capacity auction prices hit records and electricity bills spiked. So in February of this year, Governor Pritzker proposed a pause on these new incentives. In that same month, the Power Act was introduced, and it's described as one of the most ambitious data center bills in the country. And it's a real step forward, but it's certainly reactive. Illinois is still trying to catch up while the industry keeps on building. So the underlying structural problem is what I frame as a principal agent problem, drawing on Cute and McCubbins. So here I frame Illinois as the principal. It sets the rules, they issue the permits, and it's accountable to ratepayers and their community. Data centers are the agents. They control the real load forecasts, the actual water consumption, and the cooling system choices. And they're incentivized by speed and cost, not so much as public interest. So Cute and McCubbins are clear when they say the agency loss is worst when agents hold private information, have different incentives, and face limited accountability. So all three apply here. And that's the core problem that my 4 recommendations are designed to address. The first is to require full environmental review for data center siting. The Illinois Environmental Protection Act already covers large industrial facilities, and data centers have largely avoided it. So my recommendation is simple: just apply what already exists. Hyperscale projects should go through the same permitting for air emissions, water withdrawals, and grid impacts, with load forecasts reviewed jointly by the Illinois EPA and the Illinois Commerce Commissions, because decisions today will lock in the risk for decades. The second is to make grid and rate impacts visible through the Illinois Commerce Commission. The ICC has the authority, it just hasn't applied it to data centers yet. A formal proceeding on how large loads affects costs and how those costs are distributed would give the ratepayers the transparency that they don't have right now. People are paying higher bills without any way to understand why. The third is binding community agreements for high impact siting. The Power Act already includes environmental justice provisions, and it's a real step, but provisions only work with real oversight behind them. So drawing on Ostrom's Commons governance framework, I'm recommending standardized, legally binding community benefit agreements that are publicly disclosed and measurable. And then lastly, use the leverage that Illinois already has. The state hosts some of the largest hyperscalers in the world, and it isn't using that position to the fullest. So I'm recommending that the Illinois Commerce Commission engage directly with the major operators, not just regulate reactively. Illinois can set the standard for what responsible data center governance looks like at a scale. It has the policy infrastructure, it just needs the political will. And this isn't specific to Illinois. Every question you ask AI, every email you send, or every video that you stream, a data center somewhere is running to make that happen. That infrastructure sits on our lands, draws from our aquifers, and connects to the grid. The question of how we power that future, who pays, who bears the environmental costs, and whether communities have a real say is not a technical question, but a deeply human one. Illinois is at an inflection point, and the decisions being made right now about permitting, grid planning, and community oversight will shape this industry for decades. So I hope this research contributes something useful to those conversations. And I want to thank the people who made this possible. So to my Capstone committee, Corey, David, and Deborah, they all helped with the policy side to make sure that I'm not just being a scientist and thinking about how this would go out into reality. And then to the Monarch team, Crystal, Kevin, hi, and then Evan and Catherine, who are online. Thank you all for the climate side of this project and bringing my research to life with the visuals. And then to Jada and the rest of the CSP team and my cohort. So thank you all.
Greta, thank you so much for your amazing presentation. It was so great to watch. I have a question based on your findings. Was there any communities in terms of like environmental justice risks that stood out to you based on like water or extreme heat, et cetera?
Yeah, I know the Power Act that's going to be hopefully passed in November if it gets voted in definitely has environmental justice
considerations in place, and they're proposing that data centers can't be built within, I believe it's 3 miles of an environmental justice community, which would be really good if that gets pushed into place. But as of right now, I know there's certainly air emissions that are affecting affecting disproportionate communities, specifically the diesel backup generators. When those get turned on during like high amounts of grid stress, those are certainly creating a lot of emissions like PM 2.5 and whatnot. So that's kind of the biggest from what I've seen. And then I know there's a lot of talk about water and how if you're draining all the water from the aquifers, it can leave a lot of the sediment and iron left in the water and kind of affecting our water sources. So there's a lot of public outrage about our public resources being tampered with. Yeah. Mm-hmm.
Thank you so much, Greta. Very important topic that's going to become more and more and more relevant in the future in many ways. And thank you for all those great pictures of Chicago. I didn't see any pictures of Peoria or Rockford or Moline or Springfield or any of the other magnificent Illinois skylines, but Chicago's a pretty cool place. Our next presenter has entered this program with a pretty ideal background for the program in terms of strong interest in policy and oceanography, a graduate of Bowdoin University, a East Coast liberal arts college, still some of those around. And this is a student who, has from start to finish just basically been a star, has done the work in a very careful, diligent, but also creative way, has brought a sense of humor to the table, but also a reasonableness and, no joke here, a maturity that I don't know that I've seen in somebody, who's fortunate enough to have graduated from college so recently. It's pretty remarkable how much Chelsea has equipped herself to be an incredibly successful person in industry, possibly in academia, who knows, but the sky is the limit. This was a genuine pleasure to work on this capstone, and also a shout out to Chelsea's love and commitment to the state of Maine, which is quite remarkable. I did find out that in Maine, a popular treat is a red snapper hot dog. So I learned a lot about Maine, more than just lobster and trees. Chelsea's project, Strategies and Outlooks for Virtual Power Plant Adoption in Maine. Chelsea, the floor is yours.
Sorry about that. All right. Hi, everybody. Thank you, Corey, for that great introduction as I pull up my presentation here. Yeah, I do love the state of Maine, which is interesting because I'm not even from Maine. I'm from Massachusetts, which you shouldn't tell someone if they live in Maine. But thank you all so much for coming out here today, and know that there are only 5 people standing between you and a lot of free food. So we're almost there. But before I get started, I just want to thank everyone who helped make this project happen, to my capstone committee, Corey and Ryan, to Jada for holding us all together this entire year, to all of the Maine energy stakeholders that I was able to talk to throughout this project, and the Julia R. Brown Fund for funding me to take that trip to Maine, and for my friends, family, and cohort for getting me through this year. And so, in case you didn't know, this is Maine, all the way up in the northeast corner of the United States. Maine has a very special place in my heart. My dad was born and raised there. I spent a lot of time there growing up. I'll be moving there next week, which is really, really exciting. Going back to Maine after just 1 year away, couldn't stay away. And it's a fantastic place. Maine, in case you didn't know, is one of the most rural and heavily forested states in the United States. Which means, unfortunately, it's also facing a lot of really specific challenges with its electricity grid. And so I'm going to focus on 3 major challenges today. The first is resilience. We're mostly going to be focusing on resilience to natural hazards today. So you can imagine that in a state that looks like this, beautiful, things like this are very, very common and cause a lot of issues. So People in Maine tend to be kind of spread out, which means that a lot of communities, especially rural communities, can rely on miles and miles of transmission and distribution lines to get their power, which means that sometimes a single tree fall or flooding event can disrupt power for hundreds of people, and those power outages can last a very long time. And so it can be hard, especially as we build more infrastructure for the system to bounce back, especially as these natural hazards intensify in the face of climate change. The second big issue with Maine's grid is affordability. And so if you live in the Northeast or even in California, I'm sure that looking at your electricity bill, that things are getting intense really fast. Greta teed me up really nicely here for that. But Maine has some of the highest electricity prices in the United States, almost double the national average. And these electricity prices are also rising really, really quickly. And so that rise is driven by two big things, two main things, you could say. The first is reliance on natural gas. And so Maine and the broader New England region rely on natural gas for about half of their electricity. Unfortunately, Maine and New England do not have any native fossil fuel resources, which means we have to import all of our fossil fuels. And you can think just maybe about a few things going on in the world right now that make it really hard to get fossil fuels, which means that natural gas can be kind of a volatile fuel to purchase, and those costs eventually get passed on to ratepayers. And then the second big thing here is the cost of infrastructure and maintenance. And so just generally with inflation, the cost of equipment is rising, but as Maine is seeing more severe storms that cause a lot of damage, it means the state is also having to really quickly try to repair infrastructure, which gets really, really expensive really fast and is eventually also passed on to ratepayers. And then the third big challenge here is emissions reduction. And so Maine has these really awesome climate and clean energy goals. Primarily, the state wants to use 100% clean electricity by 2040 and be net zero by 2045. And there's some pretty good progress being made there. But as you notice, not to make you feel old, but 2040 is in less than 15 years, and we're still only halfway. And so there's a lot to go if we want to meet our goals. But it's not all bad, I promise. Maine is doing a lot to make sure that they're on track there. And one of those things is really encouraging the adoption of what's called distributed energy resources, or DERs, as I'll refer to them for the rest of the presentation. And DERs encompass a lot of technologies, but think of it as any sort of small-scale energy resource that stores, manages, or generates electricity at or near the site of consumption. And so there are a few examples up on the screen here. These are things like EV batteries and chargers, at-home solar panels, smart thermostats, residential batteries, heat pumps, a lot of stuff like this. And Maine is having a lot of policy support right now to push out these energy resources, and that's really great. Unfortunately, if we leave these energy resources siloed, they can actually cause more grid stress than relieve it. But if we can coordinate these energy resources and sort of make them act as a single resource, we can leverage these DERs to solve a lot of Maine's grid challenges at the same time. And so that is where virtual power plants come in. And virtual power plants, a little bit of a confusing topic. I spent the whole year learning about them, and I'm still a little bit like, wow, there's a lot of potential here, a lot going on. But just to sort of walk you through at the simple level, virtual power plants are essentially a software system that aggregates individual distributed energy resources and makes them act as a single power plant. So for example, say everyone in the audience here had an at-home battery. If we just sort of leave your batteries alone, they act independently, maybe you call on them when you want. But if we can take a software system and sort of lump all your batteries together and tell them, hey, at this time of day, we want all of your batteries to send power to the grid, we make them act as a single power resource. And so if we can do that with a bunch of different technologies across a bunch of different people, we can address a lot of Maine's grid woes. And so from the resilience standpoint, as we know, physical grid infrastructure really vulnerable to natural hazards. And so if we can maximize the use of existing infrastructure and delay infrastructure build out, it means that we have less surface area where things like tree fall and flooding can affect ratepayers. Additionally, in rural communities, if we can have a large concentration of distributed energy and then coordinate it, it means we're really empowering rural people and rural communities to take power into their own hands quite literally. From the affordability standpoint, again, if we can delay build out of infrastructure, it means long-term we're saving a lot of costs. Also, as Christina mentioned, emissions-heavy forms of power generation are often really, really expensive. And so if we can use virtual power plants to sort of localize energy and bring down peak load, it means that we don't have to rely on those dirty and really expensive sources in the long run to give us our power. And then on the emissions reduction part of things, again, it allows us to rely on cleaner sources at the home level instead of having to rely on those dirty peaker plants. And so thinking about those things, my two big research questions for this project were essentially, all right, the state of Maine has a few virtual power plant programs, but there's a lot of room for expansion. So looking outside of the state of Maine, can we find things that work really, really well in other states, and then to what extent can we bring those things back to Maine to build better programs? And then the second part, looking forward, how can different actors in Maine who could implement and control VPPs go forward and build successful programs? And so VPPs, for some context, a lot of different entities can control them. They can be utilities, it can be private companies, state governments can control them, so there's really a lot of potential there for different actors to be involved in the space. And so the bulk of the work here was to do case studies of successful VPP programs outside of the state of Maine. The first one I looked at was Green Mountain Power's program in Vermont. Green Mountain Power is Vermont's largest investor-owned utility, and they run a program where they use at-home small batteries to power the grid during peak hours. The Connected Solutions program in the Northeast United States, which uses an array of DERs such as smart thermostats, residential batteries, and like commercial industrial load reduction to sort of coordinate across 5 states to make individual people essentially contribute to one big virtual power plant. And then California's demand-side grid support program, which uses a whole bunch of different DERs from EV chargers and smart thermostats, residential batteries, load reduction, all sorts of things aggregated into a single program to provide grid services. And so I picked out sort of 3 big things from these programs that work in other places that would also work in Maine. And so the first 2 big ones are low barriers to entry and multiple participation options. And so DERs, especially high value ones like residential batteries, can be really, really expensive. For example, a Tesla Powerwall, which is one of the more common at-home batteries, can cost $16,000, which is quite a bit of money. And so a lot of these programs have really effective mechanisms to bring down the cost. And so for example, Green Mountain Power, they have a battery leasing program in their VPP. So if you want an at-home battery, but you can't afford the upfront cost of one, you can lease a battery for about $55 a year over 10 years, which means you're bringing down the cost of a battery by about 1/3. And then you get to have backup power in your home when you need it, but also you can contribute to the grid. And then for multiple participation options, it just means that a bunch of different people and DERs can participate in one program. And so, for example, in Connected Solutions, if you have a smart thermostat, you can participate. If you have a residential battery, you can participate. If you're a business that wants to work on reducing your electricity use, you can also participate. So there's lots of different ways to enter into the program. Secondly, we have significant monetary incentives. And by significant, I mean that generally, DER owners are paid for their participation in these programs, and these significant incentives allow owners to either recoup the initial cost of investment for DERs in a couple of years, or even act as a secondary revenue stream. So for example, Green Mountain Power's program, if you come into it owning a residential battery, you can earn up to $11,000 a year participating in the program, which means in just 2 years, you've made back your money and then some, which is a great way to ensure that long-term programs stay up and running and also give more people access to programs if they know that they can make money participating. And then thirdly, we have third-party collaboration. And so on this sort of left side here that we're looking at, we have state governments, utilities, state departments of energy. These are place-based entities that understand the grid conditions and just general conditions of the place that they're operating in really, really well. But they might be lacking the technology and technological know-how needed to actually operate programs successfully, because it can be pretty technical to sort of have all of these things out there, and then you have to have software on top of that and a bunch of different communication methods. It can be really confusing if you don't have the background there. And then on the other side, we have third-party aggregators who are often private companies who are really, really good at the technology piece of things and really understand the software, but might not have the place-based understanding. And so these successful programs sort of marry those two things so that utilities, state governments, state departments of energy can collaborate with people with technical expertise and then create really, really successful programs. And so looking forward to the future of VPPs in Maine, we're going to look at 3 main groups of organizations who could implement and control VPPs. The first is Efficiency Maine. Efficiency Maine is a quasi-governmental organization in the state that does a lot of really cool work. The bulk of what they do is provide rebates for different DER technologies, and then they do have a pretty small VPP program up and running right now. So my main recommendation for Efficiency Maine is keep going with that program and keep building out, because it's already doing really cool work, and there's a lot of potential there as well. In Maine, there's a ton of solar, which is not super intuitive and something that I did not know. But there's a lot of solar, which is really great. Unfortunately, solar does not always line up with the time of day that people need electricity. And so if we can pair that solar with residential batteries, it means that in rural communities with solar, they have a really high value product that can also contribute to the grid and form really successful VPPs. And so Efficiency Maine can really do more work to make residential batteries more accessible for people across Maine. For Maine's investor-owned utilities, I'm sure it comes as a surprise to no one that investor-owned utilities are not super popular in the state of Maine, nor do I think they are anywhere else. Maine's investor-owned utilities are particularly unpopular, so Central Maine Power is one of the top here. They have been consistently ranked as the most hated utility in the US for the past 8 years, which is a pretty bad record, but maybe kind of an impressive when you think about it, I'm not sure. But so they have a really big trust issue in Maine, and trust is really imperative when we think about VPPs, because in a sense, DER owners are sort of giving control over to VPP operators when their resources are being called on. And so if Maine's investor-owned utilities want to run VPP programs, they should think about partnering with other trusted Maine entities like Efficiency Maine, like the state's Department of Energy, so that the trusted entity sort of has the face of the program, and then the utilities can do some more of the background work, and can also use this to frame VPPs as a way to actually lower electricity rates, which I think all Mainers and probably all of you, even if you don't live in Maine, would really appreciate over the long run. And then finally, third-party aggregators, sort of similar to Maine's investor-owned utilities, they should keep stepping in where they can to say, hey, I have a lot of really great technical expertise here. Maybe I don't know a ton about the state of Maine, but can I partner with a trusted Maine entity that has that place-based knowledge to create a really successful program? And so when we think about the future of energy in Maine, I think it's bright. VPPs are not the only solution that we can pursue. It's going to take a sort of multi-level approach to address all three of Maine's grid challenges, but VPPs offer a really, really exciting way for the state to tap into small-scale energy resources and empower communities to take a front seat in their energy future. Thank you. And thank you to our mic runners today for literally running around.
Yes, thank you. Thank you, Chelsea. You're such a great presenter. I'm feeling really jazzed about VPPs too right now. Thank you. I have a public-private partnership question. You did like such a robust analysis of different types of like third parties and stakeholders, but I'm wondering if you also thought about like the public-private partnership lens here for VPPs. Like historically, corporates have really focused on RECs to reduce their emissions, but there's a lot of moving away from that now and having more like place-based and longer-term agreements like PPAs. And so I'm wondering if like there could be any types of collaboration in Maine with Maine businesses that are like larger corporations in Maine that are looking to do that, and if that could potentially be a source of funding, or if you looked into that at all.
Yeah. I think along those lines, a really powerful tool that corporations can use is that sort of like industrial and commercial load reduction. It's not, when you say it out loud, it doesn't sound very exciting, but it is really exciting, especially because in Maine, industry makes up such a large portion of emissions, and so there could be a really interesting opportunity there to, I know in many VPP programs and in the ones operating in Maine now, there is a pretty good incentive for commercial load reduction. Like companies are literally paid every single year based on how much energy they would use and how much they actually used. And so I think that's a really good start. And I'm really interested also in the ways that on the sort of the, if you guys can't tell, I'm really into residential battery storage, and I think there could be a really interesting opportunity there for larger corporations to sort of make their community work focused on like residential battery storage, because that is of really, really high value, especially in rural communities. Yeah.
Great job, Chelsea. Our next speaker is Chrissy Allen, and this project involves a lot of complexity, and the level of information that we can glean from observations and the opportunities that we have right now to train AI, machine learning, et cetera, models for applications in geophysics there's a lot of stuff we can do, right? If we're going to be in a time where we want to build a lot of models, those models are only going to be as good as the data we put into them. And we are at a time where we want to kind of expand or extend the prediction horizon in terms of prediction of the first kind, making accurate weather forecasts for a little bit longer. And a lot of that is possible because of things like Google DeepMind, which uses AI and machine learning algorithms, and also, predictability based on boundary conditions to have a very dense network of observations and interpolate that network so that we have a useful understanding of things like subsurface variables. Without that, we cannot be a global leader in weather and climate prediction. And understanding and predicting the future state of the atmosphere based on initial conditions, on boundary conditions, the future state of the ocean, future state of fluxes, that's important to the point where it's economically important, but it's also a security matter. It's a fundamental matter for humanity and for this country to understand the physics of the world going on around it and best adapt and provide its citizens the best opportunity to be safe in this environment going forward. And we're in a time where politicians are sometimes hostile towards science and data. So it was very commendable for Chrissy to take on this project, and I really, really dug deep and enjoyed working with Chrissy so much on this project, digging deep into these issues. And even if there's a bit of a temporary lull in terms of the government's enthusiasm towards science, the amount of people doing amazing things with remarkable data sets is something that also gives me hope. And Chrissy is going to talk about here why artificial intelligence and observation is so important. Her project is called AI and Argo, Aligning on Federal Priorities. Chrissy, the floor is yours.
Corey, thank you for that. And good afternoon to everybody. I'm going to spend this time talking about something called Argo. So for anybody who's not familiar, Argo is an ocean observing program that consists of this whole network of floating instruments like this one. The floats are out there drifting throughout and continuously profiling the upper 2,000 meters of the oceans. And Argo is an international program that was started in part here at Scripps about 25 years ago, and it's grown into one of the most important sources of information that we now have about the global oceans. And the motivation for this project is related to current federal policies around artificial intelligence and how they're reshaping the funding landscape for scientific research, including for programs like Argo. So to try to illustrate the importance of maintaining support for Argo, I want to start by sharing some of why we need to observe the ocean in the first place. And I know it's a little bit late in the afternoon to be starting with the basics, but the Earth's climate depends on the overall balance of incoming and outgoing energy. And this means that the planet maintains a relatively stable temperature when the amount of incoming solar radiation is balanced by the amount that's reflected and emitted back to space, which is something that we've been observing using satellites for several decades now. But we've disrupted this balance by adding large amounts of greenhouse gases to the atmosphere. And our satellite data indicates that less energy has been leaving the system.
We also have a record of temperature at the surface, and that shows a clear warming trend over time that you can see in this figure on the right. But the amount of surface warming represented here is only a small fraction of the overall energy imbalance. And all of the warming that we're experiencing at the surface can fit in that tiny line way down at the bottom that's purple. And the rest, all the blue lines represent more than 90% of the energy that's gone into the ocean. And you can see in comparison that the oceans have absorbed an enormous amount of energy. And this has significantly buffered the effects of warming that we'd otherwise be feeling in the atmosphere. But because of this, understanding what's going on in the ocean is central to understanding climate change. But this excess heat in the ocean also impacts our day-to-day weather. Heat that's stored in the ocean gets moved around by ocean currents, like the Gulf Stream on this figure, which carries warm water from the tropics to cooler regions, and by exchanging with the atmosphere, which influences storms and rainfall patterns. So being able to measure heat in the ocean and track where it's moving is essential for making the forecasts that we all rely on. But the challenge is that the ocean is incredibly hard to measure. It's enormous. We know it covers 70% of the Earth, and much of it lies thousands of meters below the surface. We have had reliable satellites for many decades now, but they can only see the surface of the ocean. And so to measure the interior, scientists have relied on ships. But the problem with that is that they're expensive, and they require a whole crew to operate, and they can only sample a fraction of the ocean at a given time. These measurements are collected by stopping at stations along a transect that you can see on this map, and lowering this platform of instruments through the full depth of the ocean. So it can take weeks to collect measurements along a single one of the lines that are shown here. And because of this, we were limited to only seeing a snapshot of the ocean interior at a time, and so this leaves gaps in both space and time. But that changed significantly when the Argo program started, and we've since gained the capability to observe the ocean continuously on a global scale. As of May of this year, there are over 4,000 of these floats drifting around and collecting measurements that scientists aren't having to collect manually. And while Argo is not a replacement for ship-based data, the floats are able to observe the ocean in a way that wouldn't be possible using ships. So here are some photos of different Argo floats. All of them are engineered to autonomously move up and down in the water. And they all carry sensors that measure temperature, salinity, and pressure, which provide information about ocean heat and circulation. More recently, some of the floats also measure additional biological and chemical parameters like oxygen and pH, which are important for tracking things like low oxygen zones, ocean acidification, and carbon uptake. And most of the floats sample to 2,000 meters, which is a little bit over a mile. But the round one here in the middle is designed to withstand higher pressures and can dive down to 6,000 meters in order to observe the deep ocean. And a typical mission for a float looks a little bit like this. Once it's deployed, it'll drop down to about 1,000 meters and drift with the currents for 10 days. And then it will drop down to its profiling depth, so usually 2,000 meters or 6,000, before slowly returning to the surface and collecting measurements along the way. And then once it reaches the surface, it transmits this data by satellite and will begin the cycle again. And the data becomes publicly available almost in real time. And because of this, Argo's transformed our understanding of the ocean, not only from a scientific perspective, but also has improved our weather forecast by being able to integrate that real-time ocean observational data into our weather models. And one example of this is related to forecasting tropical cyclone intensity. And that is because warm ocean water is the fuel for a tropical cyclone. And that's why we monitor sea surface temperatures so closely when a storm is developing. But if we want to know how intense a storm can become, we also need to know how deep that warm water extends. And because as a hurricane moves over the ocean, it mixes the upper layers and it'll bring water up from below. So if there's only a shallow layer of warm water, a storm can cause upwelling of cooler water and it'll cause the storm to weaken. But if the warm water extends to greater depths, then it can continue drawing energy from it and it could intensify rapidly. So a recent example of this, maybe Zane remembers, was in 2024 when Hurricane Milton crossed a feature in the Gulf of Mexico called a loop current, which is characterized by very deep warm water. And in doing so, Milton strengthened from a Category 1 to a Category 5 storm within 24 hours, which is remarkable and incredibly fast. And predicting this kind of rapid intensification is still one of the biggest challenges in hurricane forecasting, primarily because it requires a good understanding of the subsurface ocean heat. And this is one of the reasons why Argo is so valuable. And research has shown that including this data in weather models improves hurricane intensity forecasts. And as Corey mentioned earlier, this is important because natural disasters like hurricanes can have devastating impacts on communities. And so better forecasts
can save lives and allow coastal communities more time to prepare. And a similar concept also applies on longer time scales with El Nino, where because the ocean is slow moving, these slow changes in the transport of ocean heat in the tropical Pacific is one of our main sources of seasonal predictability. Seasonal forecasts provide information months in advance about likely shifts in temperature and rainfall patterns, which again allows communities a longer time to prepare. So the earliest signals of an El Nino begin below the surface, as this figure on the left shows. When an El Nino is developing, a deep pool of warm water that normally sits in the western tropical Pacific starts to shift eastward. And that heat eventually rises to the surface, raises sea surface temperatures, and alters atmospheric circulation, which tends to affect weather patterns globally. But because these changes begin in the subsurface, observations from Argo and other related observing systems can detect them often months before they show up clearly in the atmosphere. So these examples hopefully give you a sense of how uniquely valuable Argo data are. And for a little bit more context, many of our weather forecasts used to only look at the atmosphere, but the ones that we rely on today are increasingly coupled, so they include the ocean as well. And Argo data are the main source of that data, which ultimately means that Argo makes our predictions better. And that skill is especially valuable in a warming climate, where one of our best strategies is to be able to better anticipate what's coming. But that brings us back to what motivated this project, which is that funding for Argo is currently facing a lot of uncertainty. And this matters because while Argo is just one network that's part of a larger global ocean observing system, there's no redundancy. So interruptions to the Argo record can't be replaced or made up for by other systems. The US Argo program relies largely on funding from federal agencies like the National Science Foundation and the National Oceanic and Atmospheric Administration, which since last year have been facing significant disruptions like staffing cuts and grant terminations and a growing amount of uncertainty. And at the same time, artificial intelligence has become a central executive branch priority. And those agencies are increasingly expected to show that what they're funding aligns with AI. And because of this, the scientific community needs to be able to articulate why investments in Argo remain important and relevant even under the current priorities. So ultimately, the goal of this project was to understand and articulate how Argo fits into the current AI policy environment, and then to develop some materials that could help communicate Argo's relevance in that context. And to do this, I spent some time interviewing researchers across the Argo community to get a sense of how AI is showing up in their work, specifically trying to find out how they're already using AI and what types of AI-related work might grow out of the program in the future. But first, just to clarify what AI means here, in this context, it's referring to machine learning as an alternative to traditional modeling. Traditional models are built on the known laws of physics, so they solve those equations numerically to simulate how conditions evolve over time. Machine learning, on the other hand, learns patterns directly from data and then uses those learned relationships to make predictions. So machine learning methods can be much faster than traditional modeling, which is computationally expensive. And the takeaway here is that an AI model is only as good as the data that it's trained on. So one thing that came out of these conversations was that scientists in the Argo community are already using AI in a number of ways. In one example, AI is used to map sparsely measured variables like oxygen, which I mentioned was only measured on some of the floats, to produce monthly global maps, which turns this data into a much more usable product. And because oxygen is an indicator of marine ecosystem health, being able to monitor trends at this resolution is helpful for managing fisheries and other natural resources. And because we haven't been able to measure everything everywhere all the time, AI helps use all of the information that we do have by finding relationships between them, and this lets us do more with it. And so in a sense, it helps extract the most value from the existing data. Additionally, something that came up in conversations is that even though Argo has provided one of the most complete records of the global ocean that we've ever had access to, it's still a relatively small data set to the standards of modern AI. And so the growing opportunities to use AI here are limited by data, not by machine learning algorithms, which speaks to where investment might be the most impactful. And because Argo data is currently the best and most abundant source of that data, AI's capabilities in the ocean are directly limited to the degree that we sustain and expand Argo. But throughout these conversations, it was also noted that while AI needs good observational data, it lets you do more with the data that you do have, which means Argo's value is also dependent on using AI. And so there's a lot of synergy between them. And researchers identified additional opportunities to take advantage of AI to be able to do more with Argo in the future. The combination of data being collected every 10 days and available almost in real time, together with the speed that AI lets you do things that were previously computationally slow and expensive, means that Argo can help us get closer to monitoring conditions in real time. And there is a whole range of applications for that, from fisheries and making fisheries more sustainable, and to being able to make more localized forecasts for coastlines, to Ella mentioned marine carbon dioxide removal. Data from biogeochemical floats could be used to verify that the intervention is working as intended and not causing inadvertent harm to ecosystems. But this is, of course, contingent on Argo being funded so it can be sustained and expanded. So with that, to zoom out a little bit, one of the takeaways for me is that we tend to assume that our ability to predict and understand the Earth system is going to continue improving over time, because it has. But the reality is that this has only happened because we've continued to invest in the resources that make that possible, which is this whole integrated observing system. And while the push at the federal level for AI right now is motivated by accelerating scientific progress and maintaining global competitiveness, it seems like it will be hard to achieve meaningful advances in AI without funding the core systems and the science that give AI something grounded to learn from. So the hope is that this project might be a small contribution to this in helping maintain support for Argo. And with that, I would like to thank my committee, Dr. Sarah Gilly and Dr. Corey Gabriel, as well as the many others who offered their time and thoughts throughout this project. And thank you all for being here.
Actually, I have a question for you, Chrissy.
Sure, Jada.
Would you like to talk a little bit about the products that you ended up with for your project?
Sure, yeah, I wrote a couple of white papers. One of them was intended for program managers at the funding agency, like at NSF. And there's a meeting next week for the US Argo program, and hopefully it will be distributed there, and it'll be kind of the start of a conversation for the folks to have. And the other one was just more of a general kind of government relations deliverable type.
Very exciting. Thank you.
Thanks.
Right, great job, Chrissy. Thank you so much. We have 3 presentations left. Our next presenter is going to be Adelka. Adelka is a student who also took my climate change studies class. So if you have any friends or family members that are undergraduates at UCSD, encourage them to check out the climate change studies program. Adelka was an excellent student in that class and has really brought professionalism, positive attitude, but also and importantly, a real abiding and earnest and hard-fought desire to do science. And this wasn't necessarily something a year or 2 ago in terms of doing like a hard science capstone that I think Adelka probably envisioned, but now not only a capstone where she had a cool scientific finding that was hard to get and did some cool science somewhere that's also a bit hard to get. She is going to be continuing to do science, I believe, next year in Prague, which is pretty exciting. And I'm really proud of what Adelka has accomplished in this program. And you don't meet many people this dynamic or all-around skilled. So I'm grateful for the opportunity to get to know Adelka and to see how this project progressed. The title is Detecting Greenhouse Gas Emissions from Textile Waste Under Ultraviolet Weathering, an Emerging Climate Impact of the Fast Fashion Industry. Adelka.
Hello, everyone. That was incredibly nice. I'm so flattered. Thank you, Corey, for that. Let me just pull up my slides. Thank you to you, amazing audience, for sticking through with us all day. Hopefully it's very fascinating. We've all learned a bunch today. Okay, let me pull this up.
All right, so thank you for giving me the platform to share my research that I've been working on for the past year. As Corey mentioned, my research was on detecting greenhouse gas emissions from textile waste under ultraviolet weathering, and this is an emerging climate impact of the fast fashion industry. I hope by the end of my presentation, you could better understand how the clothes that we buy, wear, and end up discarding can contribute to the climate crisis, and hopefully you leave with a few solutions that you can implement in your daily life. I would like to thank my advisors, Dr. DeHane and Dr. Rue, for facilitating this research and taking a leap of faith for a non-scientist to take something like this for their research project. All right, so has anyone heard of fast fashion? Yes. So fast fashion is the rapid production of low-cost, low-quality clothing, mostly made of synthetic fibers. 59% of our clothing is made out of polyester. This is a synthetic textile derived from fossil fuels, similarly to plastic. So prior to the 1990s, we had 2 to 4 seasons every year. These were meticulously designed and sourced from good quality garments that would last generations, and you could have hand-me-downs for your kids. That doesn't really happen anymore. We have now 52 micro seasons a year. And companies such as Shein actually produce 6,000 to 10,000 of new garments onto their website every single day. I just wanted to highlight that our most accessible brands that we have in our malls and online have succumbed to the fast fashion model, because slow fashion and good quality takes time and a lot of money, but you invest in these clothes so you can then have them for a long time. So many companies that used to be good quality and were slow fashion have now succumbed to the fast fashion model. This fast fashion model promotes a take, make, and dispose economic model where it's now cheaper to buy new than to fix old. This is causing a huge overconsumption issue. The average American buys 65 new items of clothing every single year. 50% of that will be discarded in just 1 year. That's a lot of waste. That equals to 92 million tons of textile waste produced annually. That's kind of an abstract number. What does that equal? That's 1 garbage truck's worth of clothing getting dumped or incinerated every single second. So where does all of this textile waste go? Here I've highlighted countries in the yellow, so countries such as Chile, Ghana, Nigeria, Kenya, the Philippines, and countries in India receive these secondhand clothes thinking that they can make a new life and not end the life of the garment right there and then. But with the rise of ultra fast fashion and fast fashion, these are ending up in open air landfills. So the countries in the global north, such as the US and countries in Europe, have engineered landfills where we can capture the gases that are getting emitted and reuse them as energy. That makes sense, but a lot of these countries don't have that infrastructure, so these emissions are going straight into our atmosphere, contributing to global warming. So my research question is, does textile waste emit greenhouse gases under UV weathering? Why would I ask a question like that? Well, there's 2 studies from Royer et al. And Shaw et al. That have found that low-density polyethylene, which is one of our most abundant plastics, these are our soft plastics from plastic bags and water bottles, emits a significant amount of methane and CO2 just under UV light. So this is not a biological process. This is just UV weathering on these plastics. And so we're curious if this polyester, which is different from plastic but similarly derived from fossil fuels, will it emit a significant amount? We're also testing if polyester and cotton has a difference, because cotton is a natural fiber. But in the fast fashion industry, there's over 10,000 additives that we don't know a lot about, and they're trade secrets, and so perhaps that can outgas something as well. And so here is our picture of our water bottles that are emitting these greenhouse gases, and then those are our polyester clothes that are getting dumped, and we're wondering, will these emit a significant amount? So how did we do this? So we had yellow and black polyester versus yellow and black cotton, just to have the same variable in colors. And we degraded them for either no weeks at all, so non-degraded, or 1, 2, or 3 weeks of degradation. Then we put this in a sealed enclosure. Shout out to my dad who built this for me. And this is UV transparent, so we would put the textile in here with either dry condition or wetted condition with H2O or hydrogen peroxide. Hydrogen peroxide to simulate a natural environment when H2O, UV, and organic compounds react together. And then we closed this sealed chamber, connected it to the LGR analyzer that produces CO2, carbon monoxide, and CH4 time series, and then we put them with and without UV to see if UV is driving these emissions. And so, were we able to see emissions? Yes, which is exciting, but also a little evil. But here, I wanted to show you on the x-axis, we have our dry condition, H2O condition, and hydrogen peroxide condition. And then the pink is our UV variable. So as we can see, the green variable, non-UV, is not emitting emissions. So we can tell that UV is driving these emissions up. And what we can see is that our H2O2 condition for yellow polyester is emitting the most amount of methane. We're particularly interested in methane as climate scientists because methane has a global warming potential 80 times greater than CO2 on a 20-year time scale. And so why is H2O2 emitting the most? But because when UV light and H2O, or in this case H2O2, react, they create hydroxyl radicals, which is OH. They can attack these additives or the polymer chains. This creates chain scission, where the backbone of the polymer breaks apart, and then carbon released as greenhouse gases are emitted. Here I wanted to show you yellow polyester versus yellow cotton. And here you can see this is our yellow polyester and yellow cotton. And what's really interesting about this is our yellow cotton, the natural fiber, is emitting a significant amount of methane and CO2 and carbon monoxide. But our synthetic is emitting much more. One of the interesting findings that we found is this U-shaped plot. A hypothesis of why it could look like this is that on our x-axis we have day 0 of degradation, so not degraded, then 1 week of degradation, 2 weeks of degradation, and 3 weeks of degradation. And all 4 of these lines equal our yellow polyester, our yellow cotton, our black polyester, and black cotton. And so one thing that the reason we think that this is happening is that on the left here we have unweathered. So we can see this is very pigmented, much more than the one on the right, which is 3 weeks of weathering. And the difference is that a lot of the dyes have already outgassed. So what we're thinking at day 0 is this initial enhancement when it's with UV. It emits these additives and these dyes for the first 16-minute trials. And then by week 1 and 2 of degradation, those additives are already gone. And by week 3, we can assume that the UV penetrates to the polymer, breaking the polymer and then releasing these gases. This is a hypothesis of what this could look like. Royer et al., who found that low-density polyethylene emitted methane and CO2, had a 212-day study where the methane exponentially grew over the 212 days. So perhaps if we kept this in the UV chamber for weeks, months to years, it would continue to outgas, maybe to look like a Nike sign. So this is, of course, a laboratory study. This is a controlled setting where we have the control of what textiles we use, how much UV exposure, what the temperature is like. But the real question is, does this happen in real life, in real places that get all of these textiles? So Dr. Dehane and I had the privilege of researching in Accra, Ghana. Ghana is a country in West Africa, and you might wonder why Ghana. Well, Accra is one of the leading importers of second-hand textiles in the world. They receive 15 million garments every single week, yet due to fast fashion, 40% gets landfilled or incinerated immediately upon arrival. So as you can see, this is Jamestown Beach, completely covered in textile waste because these textiles have nowhere to go. They don't have the infrastructure, so they end up in their ecosystems and in their neighborhoods. This is in the middle of a neighborhood in Accra, and this is an illegal dump site called Old Fatima, where we were able to take our measurements. So we took flux chamber measurements here with a fancy mop bucket. And we pulled 1.5 liters of air into these air sample bags, which are kind of look like Ziploc bags that we then sent to SIO to analyze the same way we analyzed our control. And then here we had a metal pole and a little string that had our tubing where we took air samples right above the lagoon because it's very polluted with textile waste and plastic waste, and we wanted to see if it would emit higher amounts of methane and CO2 and carbon monoxide. So we had 9 sites. This is a picture of Accra, and we started at Contamonto Market, and Contamonto Market is truly an incredible place. It recirculates thousands of clothes. It's filled with sewists and tailors and upcyclers and recyclers who try to give a new life to these garments. And they did this around the 1990s. They were really able to execute this well, but with the rise of these petroleum-based fibers, it's really hard to recycle and it's really hard to make something new out of them because they're so stretchy, they break, and it's just not good quality. And then we went to Old Fatima, like I mentioned before, and as you can see, it's along a lagoon, so anything that falls out of the lagoon is falling straight, whatever falls out of the dump site falls straight into the lagoon. And then we had 4 different sites along the lagoon. Here you can see this water is extremely stagnant, not really moving how a lagoon should flow. This is a lot of plastic debris, and lots of textiles are polluting this lagoon here. This used to be a fishing hub and a recreational swimming place. As I mentioned, this is Jamestown Beach. What's really interesting is that no textiles are dumped at the beach. What actually happens is that the lagoon spews into the Gulf of Guinea, and then this is recirculating the clothes onto the shore of this beach. This beach is cleaned up every single week. 30 tons are picked up out of this beach every single Tuesday. But it just keeps on recirculating due to the abundance of textile waste. Here, I just wanted to show you all what I was seeing. What you're seeing at the surface is called ebullition, methane bubbling up from the sediments below. Years of accumulated textile waste, plastics, and organic debris create oxygen-free conditions at the lagoon floor. In these anoxic sediments, methanogenic microbes break down organic matter and produce methane, which builds up and escapes as bubbles. While plastics and synthetic textiles are not the main food source for these microbes, they help trap organic material and maintain the conditions that support continuous methane production. So what was once a fishing lagoon and a recreational swimming is long gone. And here, to just give you a better idea of what we looked like in the field with citizen scientists from the Orr Foundation, this is us on Jamestown Beach taking our syringe samples. And this was once a beautiful beach that people got to hang out on and play soccer on, and they can't do that anymore. So what are my results? So here is my lagoon transect, all the blue bar graphs. And then there's Old Fatima, the dump site, and then the purple is Contamonto Market. What I want you to look at is the yellow arrows and the black line. This is the atmospheric background, so the average background of these gases around the world. So the atmospheric background for methane is 2.03 parts per million. You can see that one of our sites on the lagoon is up to 55 parts per million. That's 28 times the atmospheric background. This is extremely dangerous and unaccounted for. Here for CO2, it's relatively high, and especially high at Contamonto Market, and especially for carbon monoxide as well. This could be due to the burning of the synthetic textiles that are done around Contamonto Market. So what are our main findings? Textile waste accumulates in open-air landfills where weathering generates GHG emissions that are currently unaccounted for. Production of GHGs from textiles has 2 phases, within minutes due to the additives, and again after a few weeks due to outgassing of the polymer, a hypothesis of our U-shaped plot. So a few policy recommendations. The 3 most important things we need right now to combat this growing issue is traceability, continuous monitoring, and financing. Here you could see me standing on a pile of textiles at Jamestown Beach. And so the importance with traceability is that we donate our clothes to Goodwill or charity shops. Only 20% of that gets resold. The rest, 80%, gets sent on the global market where there's no traceability. These are trade secrets. We don't know what country's getting what. And in order to get producers responsible for these garments, we have to understand where they're going. And right now, the EU has the digital product passport, which is shown here. It's a QR code that tells you exactly where your fiber was milled, what dye and additives are on your garment, who manufactured it, who produced it, and how to take care of it for the end of its life. And this is important and a great starting framework, but once it leaves the EU, no one has the infrastructure to understand this QR code or deal with it because it's getting sent in bales to countries in the global south such as Ghana who are just opening them and trying to resell them, and if they can't, they end up in the environment around them. Secondly, we need continuous monitoring. As we saw in the RU lab here, is that we saw enhanced GHG emissions, and we also saw them enhanced in Ghana. And we need continuous monitoring and financing to continue this monitoring so we could see if it's getting worse and get gas flux chamber measurements so we can better understand and quantify textile by textile how much these are emitting under the sun. And right now, all of our GHG emissions for landfills in the global south are estimates per capita, but of course, those are on engineered landfills, but they have these open air landfills that are going straight into the atmosphere, these GHGs, so it's a very lowballed number. Lastly, we need financing. Some of you may heard of EPR, Extended Producer Responsibility. Senate Bill 707 just got enacted. It'll get enacted next month, and it gets the producer responsible for the end of the life of a garment. But again, this is happening in California right now, but once it leaves California, that ends the end of the life. But we know it has a whole nother life once it leaves California in these global south countries. And we need to support local NGOs such as the Orr Foundation. They collect tags from every single garment that they find on the beach, and they write reports to try to get financing from these big producing companies that are polluting their beaches. So we need to support these companies so they can get financing and really do real science and get jobs for these people on the ground instead of picking up trash from their beach. Lastly, I want to just leave you with, you don't need to be a scientist or activist or politician to make a difference. You can buy intentionally. You have the power to choose who you buy from or what you buy. Buy secondhand, buy from your closet. You already might have a lot of clothes. And this photo is from the Tide Turners, and this is them picking up the 30 tons of clothes every single Tuesday. And I hope this wasn't depressing, but rather inspirational and educational that we can make a difference. And thank you so much to Dr. Rue and Dr. DeHane, my amazing cohort, my parents, Ollie, Jada, Corey, and Mark. You guys are amazing and have changed the trajectory of my life, and I'm so grateful to be here today to share my research. Thank you.
Thanks for a great presentation, and I commend you for also taking the laboratory into the field and turning it into something practical. I'm very curious, in Ghana, do you see any local programs or policies or regulations aimed at addressing this problem, in addition to the Tide Turners?
Yeah, so Dr. DeHane is actually a leading scientist for the Orr Foundation, which is a local NGO, environmental justice group, and they actually have this program for kayaye, which are the women who carry these bales, and they try to get them to not have those jobs and instead get them jobs to learn how to sew and upcycle and work for the Orr Foundation and create a more sustainable job for them instead of carrying these heavy bales that are just like waste. And they have an immense amount of upcycling. They have all of these denim clothes like made out of clothes that they couldn't repurpose in another way, and they recycle them and make something new. They remanufacture the clothes, they compress them and make speakers out of them and furniture. So they have a lot of on-ground, like Ghana is doing an incredible job, but just the abundance of clothes that we're sending that is bad quality is ruining their economy and their system that they already built there. Thank you so much.
All right. We're almost there, everybody. This has been a great day. I'm having a great time, and that was a great job, Adelka. Thank you so much. Soraya, this next presentation, the level of, this was an idea that Soraya had in August or September to explore the issue of waste management in Tokyo. There were a lot of conversations about how to go about this project the best possible way. Soraya looped in a committee and got the genuine, like emotional and, academic involvement of her committee, like through 4 or 5, a lot of meetings that were very substantive. And in assembling this project, identifying the importance of this project, narrowing the focus of this project, and then refining the focus of this project and achieving a deliverable that, number one, shows a tremendous amount of work, but also importantly just reflects just the depth of talent that this student has in so many ways. Spotting this issue, the level of attention to detail and rigor in taking apart everything every single interviewee said, the attention to detail in the structure of Japan's incineration system, and the cultural awareness to execute this, and just the decency and courtesy to make participating in this project a good experience for, I think, probably all of the stakeholders. I was really proud of this project and what Soraya accomplished this year, just really proud. So Soraya Banal, a case study of waste management in Tokyo, infrastructure, stakeholder views, and circular economy goals. Soraya, the floor is yours.
Thank you, Corey, for the introduction. Let me just pull up the slides. Okay, thank you all for being here today. My name is Soraya Kikuchi Bernal, and this is my capstone project. I will also be talking trash. And it is titled A Case Study of Waste Management in Tokyo, Japan, Infrastructure, Stakeholder Views, and Circular Economy Goals. So first I'd like to introduce Tokyo, which is the capital of the island nation of Japan. And as seen in the zoomed-in map to your right, it consists of 23 wards as well as 39 other municipalities. Tokyo has a population of over 14 million, of which around 10 million reside in the 23 wards, again shaded here in purple, which is the highly populated metropolitan area in eastern Tokyo. While Japan as a nation faces a shrinking population, Tokyo itself has an increasing population. Alongside this increasing population is actually an observed decrease in the amount of waste that is produced in Tokyo. This is due to the progress of several national and regional policies and action plans striving towards waste reduction, recycling, circular economies, and the achievement of net zero carbon dioxide emissions by 2050. Circular economies are systems in which materials are continuously reused and repurposed, contrasting from the traditional system where resources are extracted, used, and discarded over and over again, leading to more and more trash. Now, waste reduction and emissions reduction go hand in hand, as cutting 1 ton of combustible waste in Tokyo reduces around 520 kilograms of carbon dioxide emissions. Reducing plastic incineration and promoting plastic recycling is a priority for reducing these carbon dioxide emissions, as well as reducing microplastic pollution. While Tokyo aims to reduce incineration-related carbon dioxide emissions through proper recycling, it is also important to note that the practice of incineration has avoided landfill methane emissions that would result from the direct landfilling and decomposition of unprocessed mixed waste. Methane is a greenhouse gas that is 28 times more potent than carbon dioxide. Additionally, Tokyo faces a very specific landfill constraint. The central breakwater landfill, which is shared by the 23 wards in the urban core of Tokyo, is expected to fill up in 50 years. There is no other landfill left. Therefore, the lifespan extension is critical for this landfill. My research has consisted of 2 main objectives. One is to explore alternative pathways and gain insights on net zero emissions and waste reduction approaches that differ from the US norm. While Tokyo is heavy on incineration, and I know that incineration is very stigmatized here in the US, my goal is not to be pro or anti-incineration, but to understand how it is implemented and the direction to which the waste management industry is heading in Tokyo. My second goal is to understand local sentiment by engaging local stakeholders to gauge public opinion surrounding climate and just understanding the socio-political situation in Tokyo. In order to do so, I first conducted a literature review. This consisted of existing policies, infrastructure, and reports. Then I spent 4 weeks in Tokyo, where I conducted 8 total site visits, 10 interviews, and distributed a survey to Tokyo residents. Now I'd like to talk a little bit about the flow of waste in the 23 wards. This can be broken down into 3 main parts, each under 3 different authorities. First, each of the 23 wards of Tokyo, First, each of the 23 wards are in charge of setting their own sorting rules and collecting the waste, largely in the categories of combustible, incombustible, and large-size waste. Each of the 23 wards are also in charge of the entirety of their recycling systems, from sorting rules, collection, to processing. The second part of the flow is under the Clean Authority of Tokyo, which is in charge of intermediate processing of waste. This includes the incineration of combustible waste at 21 facilities, as well as the pulverization and sorting of incombustible and large-size waste at 2 corresponding facilities. The third part of the flow is under the Tokyo Metropolitan Government, which is in charge of landfilling. I would also like to note that outside of the 23 wards, which has a more centralized system, there are 39 other municipalities, each with their own waste management systems, with some similarities in sorting categories and processing systems, as well as differences in skill of cooperation and aggressiveness of recycling. And these tend to be smaller municipalities compared to the wards. Now moving on to the site visits. So out of the 8 site visits that I conducted, 5 were incineration tours under the Clean Authority of Tokyo. The first incineration plant under the Clean Authority of Tokyo began operations in 1930, and the infrastructure has been updated over the years to incorporate more and more features, notably due to the initial modernization and expansion catalyzed by the 1964 Tokyo Olympic Games, as well as strict pollution regulations passed in the late 1990s. I will highlight some current features at these incineration plants. First is the incineration or burning of trash itself. This process reduces trash to around 1/20th of its original size, and by doing so at temperatures over 800 degrees Celsius, it is able to reduce or restrain dioxin generation. Dioxins are a known pollutant to cause negative health impacts. Additionally, there is no post-collection sorting of combustible waste, so any recyclables that end up at the plant do get incinerated. The next feature is pollution prevention and analysis. So on top of the legal and regulatory pollution standards, each facility has self-imposed stricter pollution standards. In order to achieve these standards, they have advanced filters and strict testing of waste, ash, drain water, and flue gas. Another feature is energy recovery. So this is the direct use of electricity and heat that result from incineration directly at the incineration plants, as well as at nearby facilities such as schools, households, pools, botanical gardens, etc. Additionally, they conduct material recovery. So currently, 40% of incineration ash is recycled into construction materials such as cement. And the Clean Authority of Tokyo is making an active effort to increase this ash utilization percentage. Additionally, these incineration plants have incorporated green infrastructure into their buildings, including carbon capture, solar panels, rainwater harvesting, rooftop gardening, and wall greening. During the tours, I was also able to talk to the workers and hear their opinions. First, they urged for the use of the 3 Rs, reduce, reuse, and recycle, in order to increase landfill longevity and reduce emissions. Additionally, they emphasized the need for proper battery sorting in order to prevent truck and facility fires, such as the one in the photo to your right, in order to protect worker safety as well as save money. They also talked about some shifting trends, such as how society is moving away from incineration, and they expect recycling efforts to speed up. They also said that there's been rising awareness surrounding waste and environmental issues in the recent years. And while they promoted practices to reduce incineration as a practice, they also emphasized its importance and how it has solved sanitation issues that existed previously from the mixed landfilling of unprocessed waste. Furthermore, they expressed the desire to engage neighboring communities in order to build trust and reduce potential backlash, since many of these incineration plants are located directly in neighborhoods and urban areas. Now I'd like to move on to stakeholder interviews. I conducted 2 interviews with industry professionals. First was Mr. Yohei Kuroki, Executive Officer at Pantech, a plastic services and consulting company. The second interview was with Ms. Reiko Futagi, President and Representative Director at Otani Seun, which is a waste disposal services and consulting company. We talked about a lot of topics in depth, but these are just general and broad takeaways. First, recyclables should be recycled, not incinerated. However, incineration is still a valid method of processing non-recyclables. They talked about how strict pre-collection sorting is helpful for their operations as it leads to less contamination, makes materials easier to process, and gives them higher value. These are also 2 companies that work towards building a circular economy, working on initiatives to design products to be easily broken down, recycled, or repurposed, considering the end of life of the products. However, they talked about how there is still a long road ahead in order to achieve a true circular economy in Tokyo. Aside from industry interviews, I conducted 8 interviews with Tokyo residents. The first takeaway is that there is a culture of following rules regardless of whether they agree with the rules or whether they understand the purpose behind them. The second takeaway is that while the existence of incineration as a practice rarely seemed to be questioned, I observed a range of preferences for the amount or scale at which incineration and recycling are implemented. On one hand, those that were more mindful of recycling tended to be more satisfied with or desire for more sorting categories. For example, I interviewed a woman in her 90s that lives in a ward with limited recycling categories, where materials that aren't collected as recycling become combustible waste and incinerated. Since she has a strong will to not waste, she takes recyclables to community drop-off locations, such as these on the right. However, she is in her 90s, and as she gets older, it has become harder for her to walk, and she expressed that there's an accessibility issue, and recyclables such as plastic food containers and used cooking oil have been piling up in her kitchen. She said that she'd appreciate it if her ward created more recycling categories and made it easier for residents to recycle. On the other hand, some expressed preference for looser sorting rules, mainly due to the imagined stress from the thought of having to sort more, not from the actual experience of having to sort more. Additionally, I was able to hear about some successful waste reduction strategies that have been implemented in different parts of Tokyo. One is designated costly waste bags. So it seems that when people have to pay to throw out trash, but don't need to do so to recycle, it pushes people to recycle more to save money, which makes sense. And the second is bright stickers being left on incorrectly sorted waste. So I actually interviewed a lady that talked about how when she sees these bright stickers being left on her neighbor's trash bags, she can't help but go take a look to see what they're doing wrong. So it appears that there's a desire to protect public image, pushing some people to sort more and recycle better. Additionally, composting, which doesn't seem to have taken off at scale yet in Tokyo, seems to be seen more as an individual or small community practice rather than something with the potential to be a large-scale industrial practice. Now moving on to data from the Tokyo resident survey, which gathered 147 responses from 35 municipalities from people ranging from under 20 to over 90. And there were 22 questions, but I will highlight 4. The first graph here on the left are responses to the question, how confident are you that you are sorting your waste correctly, where 1 is not confident at all and 5 is completely confident. Most respondents answered either a 4 or 5, indicating high level of confidence in their waste sorting, likely indicating clear communication from the municipalities. The graph here on the right shows responses to how much do you trust Tokyo's incineration plant filters to trap pollutants, where 1 is no trust at all and 5 is complete trust. Around 70% of respondents answered either a 4 or 5, indicating that they have trust in these incineration plant filters. The third graph here on the left are responses to if there are adequate recycling systems in place, to what extent do you support the incineration of the rest of the waste? Where 1 is strongly opposed and 5 is strongly support. Around 80% of respondents answered either a 4 or 5, indicating support for incineration in the case that there is proper recycling. Last here, the graph on the right shows answers to the question, should areas in Tokyo prioritize improving incineration technology or reducing waste, where 1 is a strong preference for incineration and 5 is a strong preference for waste reduction. There seems to be a pretty even distribution with a slight preference for more recycling, with a clear peak at 3, where 40.8% of respondents demonstrated equal support for both incineration and waste reduction. In conclusion, there seems to be a shift towards incinerating less in terms of policies, industry, and behavior. However, incineration is still widely accepted and does not seem to be going away anytime soon. There also seems to be rising awareness about waste, environmental impact, and circular economies. However, in order for a true circular economy, there is further cooperation needed between product manufacturing and waste management industries, as well as between municipalities and residents. Now, zooming out a little bit, there are waste-related greenhouse gases being released and landfills filling up around the world. Even locally here in San Diego, the Otay landfill and the Miramar landfill are expected to fill up and close in 2030 and 2031. There is no perfect or one-size-fits-all solution to the waste problem, and solutions must consider a region-specific constraints. There's a need to be open to new systems and new rules, whether it be changes to sorting rules or changes to processing systems. There's also a need for systems to make use of materials that fall between the cracks of recycling so they don't fill up landfills and lead to more greenhouse gas emissions. In the case of Tokyo, this system would be incineration due to Tokyo's specific constraints and available infrastructure. I hope I was able to provide some insights on the waste management system in society that may be unfamiliar to you all. I would like to thank my Capstone committee for the support throughout this project, Dr. Corey Gabriel from, well, we all know him, our program director, Alexander Galasso, Waste Reduction Division Program Manager at the City of San Diego, and Jeremy Martin, Vice President of Energy and Sustainability at the Institute of the Americas. I would also like to give a special thanks to the Julia R. Brown Fund for making my research trip to Tokyo possible. Thank you.
Now? Okay, sorry. Thank you. When I visited Japan a few years ago, I noticed a lot of things have a lot of like excess plastic packaging, like fruits in the konbini or like wrapped in plastic. Do you think that sort of thing makes up a significant portion of the waste, or maybe it's a drop in the bucket compared to just all of the waste in general? And then I'm curious if you learned anything about whether manufacturers are trying to reduce that sort of thing during your interviews.
So the single-use plastic packaging is definitely a big issue in Tokyo and does make up a significant portion of waste produced. There is effort, at least in the interviews that I conducted, there seemed to be efforts to, at least with the consulting companies, they work with different companies to try to help them create products that produce less waste. But it's definitely something that still needs work. Yeah.
All right. Thank you so much, Soraya. So in our final slot today, somebody had to well, enjoy a lot of presentations, but with the fact in mind that they would be presenting at 4:55. It's now about 5:10 or so, so apologies for the little bit of a delay, but Mia is up to the mental challenge, I think, of going last. Kind of like, you know, the Yankees had a closer back in the day who was unbeatable. His name was Mariano Rivera. And they played Enter Sandman by Metallica when he came in because the game was over. You knew he was going to do his thing. And Mia is kind of the Mariano Rivera of CSP students, if there are baseball fans out there. Her degree at UCLA is in something very fancy and challenging. And she came here and identified a summer topic, the Atlantic Meridional Overturning Circulation, and was interested in the long-term variability of this coupled ocean atmosphere phenomena that's really important for weather in Europe and also really interesting to paleoclimatologists because it's been associated with a number of important rapid climate change events, like I was involved in the Younger Dryas event and a lot of other things like that. And the quality of that summer paper, both in terms of the understanding of the paleo context, but thinking about how climate models work and the physics behind the kind of abrupt climate shift that she was thinking about, the understanding of the concept of bifurcation. It was very sophisticated, and the work she's done in this program has been sophisticated, and the way she's communicated about her project, something I don't know that much about coastal ecosystems, to me, has been impressive, because I would say that a good third of what I've come to know about these kind of blue carbon ecosystems, I was sort of starting to learn a little bit about this, but Mia was a catalyst for me to kind of start doing my own looking into a lot of coastal ecosystem stuff that I never would have cared about. And I'm sorry to say that, but that's one of the great things of being part of this program is there's so many disciplines connected to climate, and people are such passionate advocates of these interesting topics that they bring to the table. Not everybody can stare at a 500 millibar chart of air passing over the Rockies all day and be excited about Lee cyclogenesis, but I can. That's not everybody. For Mia, blue carbon ecosystems, that might be something that she's super interested in, and she's done a great job engaging me in her topic and has been an outstanding CSP student. So last but not least, Mia Conti, blue carbon ecosystems as nature-based climate solutions, science to policy analysis and habitat mapping of seagrass and macroalgae in Norway. Mia.
Wow, thank you, Corey. I've been waiting all year to hear that introduction. Very exciting, and oh my gosh, our cohort is so impressive. I'm so proud of everyone, and I'm very excited to be our last speaker of the day. All right, so I'm going to be talking about seagrass and macroalgae as nature-based climate solutions, where I mapped blue carbon ecosystems in Norway. So first, let's talk about the importance of blue carbon. Most people picture forests and plants when they think about natural carbon storage, but some of the most efficient carbon sinks are actually in our oceans. Blue carbon ecosystems are coastal vegetated ecosystems like mangroves and seagrass that are able to store and sequester atmospheric carbon, sometimes at rates even faster than our terrestrial forests can. Although they cover less than 2% of the seafloor, they account for 50% of storage of all sediment carbon in the ocean. The problem is that despite how powerful they are as carbon sinks, sometimes they're entirely overlooked in how countries account for carbon. And that gap is what my capstone is about. So I got the opportunity to collaborate on the Sea Blues project, which is an EU-China joint research consortium across 12 countries, all focused on advancing what we know about blue carbon.
It's coordinated by the Norwegian Institute of Water Research, or NIVA, who is my primary capstone stakeholder. And here's all of us in Greece just a few months ago, where I got to attend the annual meeting and discuss cutting-edge blue carbon science with the whole team. So I focused on Norway, obviously, as my case study, and I was lucky enough to travel to this beautiful country and work hands-on with the experts at NIVA. Norway is an extremely compelling case study. As you can see, it has a huge coastline, which is dominated by seagrass and macroalgae as their dominant coastal vegetated ecosystems. And its government has expressed a lot of interest in blue carbon, which they call their blue forests. But these ecosystems are extremely complex, and that's why it's such an interesting implementation challenge, bridging the science to the policy. So Norway has macroalgae, which include kelp forests like this one, as well as rockweed like this, which are both found on rocky substrate. In contrast, seagrass is found in softer, sandy, or muddy sediments, and this difference is key because how they store carbon is completely different. Seagrass buries carbon in the sediments directly beneath the habitat, whereas macroalgae bury their carbon non-locally. It's exported out into the deep sea and buried there. So by studying both of these ecosystems, I'm capturing two prominent but highly contrasting carbon pathways in Norwegian waters. And remember this contrast because it drives a lot of the results to follow. So beyond carbon, these ecosystems also host a whole variety of co-benefits, such as fisheries and nurseries habitat, wave attenuation and coastal resilience, biodiversity, nutrient cycling, just to name a few. These ecosystem services are highly essential, but they're also super relevant to blue carbon policy because they offer financing mechanisms. But human pressures also greatly impact their ecosystem function. These habitats face threats from fishing, dredging, coastal darkening and eutrophication from runoff, marine litter, anchoring, coastal infrastructure, just to name a few of our anthropogenic activities that we do that mess up these ecosystems. And this is super important because it also messes with their ability to store carbon. So why do we care about carbon accounting, and why do countries care? Because what gets accounted is ultimately what gets managed and what gets noticed. Countries report their emissions and removals through greenhouse gas inventories, such as this example from Norway. On the positive y-axis, you're seeing some of Norway's emissions broken down by sector. But you also notice this section here which goes into the negative, and that's their carbon removals. And this category that I've highlighted is land use change, and forestry. There are now methodologies for wetlands, yay. But the problem is that blue carbon doesn't always actually fit into this methodology. Sometimes it's not compatible, or countries simply aren't choosing to implement them. And this is important because if these ecosystems aren't put in these inventories, then their losses are essentially invisible, and so is the benefit of protecting them. So to understand the role of blue carbon ecosystems in climate change mitigation, you can think of these ecosystems like bank accounts that have been filling up for centuries, something we wish we all had, right? So the carbon that's stored long-term in these ecosystems is like the bank account balance. And just by existing as healthy habitats, these habitats can basically earn interest, just like money sitting in the bank, pulling down extra CO2 from the atmosphere year after year and adding that to the existing balance. So the stronger the ecosystem, the bigger the balance, and the more interest it earns. And that's what this schematic is showing, and it's specific to Norway. So you have rockweed, seagrass, and kelp that all fix CO2 from the atmosphere through photosynthesis, shown here as their net primary production, or NPP. And this carbon is often just remineralized back as CO2 into the system, but some of it is sequestered long-term, and that's the carbon that we care about. For seagrass, it's sequestered as particulate organic carbon directly underneath the sediment, but for macroalgae, it's exported to the deep sea and buried as particulate or dissolved organic carbon. And so what this schematic is really revealing is that the long-term storage of these ecosystems is equivalent to 2% of Norwegian emissions. That number alone is huge. But what if we flipped it around? What if all of these ecosystems were lost because of all of our anthropogenic pressures? It would release 33 million tons of CO2 and lead to the loss of nearly 4 million tons of CO2 uptake every single year. That's that interest I was talking about. And that's the key issue. These fluxes aren't accounted for in Norway's climate commitments or their inventories, at least not yet.
So this brings us to my research questions. I'm analyzing what the current distribution, carbon evidence, and ecological context is, the environmental drivers and human pressures that shape these ecosystems' potential, how they differ in their scientific and their policy readiness, and then what monitoring and governance gaps exist, limiting their ability to be implemented into policy. So I accomplished this by creating 2 databases, one for seagrass and one for macroalgae. I started with site-level data compilation, and then I aggregated that to the regional and national levels. I combined my data files with external spatial layers, ran that through Python, real easy, and created an interactive map of Norway, showing all of its blue carbon and the variables of interest. And then from there, I was able to do my data analysis, which was mostly spatial co-location. So here's the central deliverable of my capstone, the interactive Norway map, and I'll run through briefly kind of how it works. So first I'm toggling on my study sites for seagrass and macroalgae, and then you can see on the left side panel all the data source information and legends that's gonna explain everything. And then on the right is the layers broken down by category. So you can pick which category you're interested in. For example, right now I'm adding sedimentation rates and regional summaries for carbon. There's also the environmental drivers. So this is sea surface temperature as well as sea surface salinity. And then all the human drivers that I was mentioning earlier, you can toggle those on: ocean darkening, port vessel activity, and dredging effort, just to name a few examples. So now we're going to dive into southern Norway to look at some more specific details of the map. So here you can see summaries from the Oslofjord and the Skagerrak coast, and then you can also see kelp and seagrass sites. Then zooming in even further, we can look at some spatial co-locations. So the blue is showing kelp extent, and the green is showing seagrass extent. And then the colored polygons are the co-location. So this is showing a protected zone, but it's still facing 12 pressure signals, and it's nearby to seagrass sites. In contrast, this polygon shows 0 pressure signals, but the same protection. So you can see how highly variable it is, even within this very small scope. Toggling on the marine protected layers, we can see where those are. And then you can jump over here and see that this area falls outside of that protection zone, but it still faces pressure signals. And so the point of my mapping is basically central to my results. And the intention is to demonstrate how this kind of co-location analysis can be utilized by policymakers to understand the current science that exists, the data gaps, and so that they're able to assess the next steps. So I'll go over a few of the key results that I derived from the mapping and the data analysis. First, macroalgae have a much larger extent than seagrass, roughly 10,500 kilometers squared for macroalgae versus 90 kilometers squared for seagrass, which is driving the results that you're seeing in panel A, which is the carbon pools. And this is about a 1.5 order magnitude difference for macroalgae versus seagrass. And then panel B shows sequestration rates, which is about a 2 order magnitude difference between macroalgae and seagrass. But the key thing is that these are there are fundamental differences in the type of carbon that we're seeing here. For seagrass, all of these values represent true sequestration. Sure, there's a little bit of uncertainty, but the macroalgal carbon is much more uncertain, and it's continuously fluctuating. So we're not sure how much of that is actually being stored long term. And all of this means that you can't account for carbon in the same way for these 2 blue carbon ecosystems. You can even add sequestration values if you'd like. Panel C shows, for example, like the social cost of carbon for the sequestration. But jumping back to panel B, you can see the error bars, and macroalgae has a much larger bar, which shows that it has a much higher uncertainty, and that carries over into the sequestration values and any other metrics that you're looking at. Panel D also shows some important results. Basically, the resolution difference matters a lot for policy. Seagrass scales to the regional level, but as you can see, it's very highly regionally variable, which matters a lot when you're looking at a national scale inventory. And macroalgae actually doesn't scale to this level. Carbon data was only provided at the national level, which is also a huge data gap. So quantifying the uncertainties and the data gaps embedded is also another key result, because those determine whether each ecosystem is ready for formal accounting. The next analysis comes from overlaying pressures, protection, and carbon. First, in panel A, you can see looking at carbon, pressure, and protection. Pressure is kind of an interesting finding. Seagrass, the bottom 3 panels, show a lot more pressures than what kelp face. So seagrass face roughly 16 to 53 pressure indices per kilometer squared versus under 5 for all of macroalgae. And then another key finding is that the worst case scenario in Norway is actually for seagrass in southern Norway, which is the region I showed you on the interactive map. And it's that bottom pane right there. You can see that the majority of carbon in seagrass is stored in the southern region, but this is the region that also faces the most pressure and the least protection. And then panel B decomposes the pressures by the actual pressure type, so you can see what it's facing, like dredging, aquaculture, and fishing effort. And this analysis signals for policymakers where they should focus. And on the next slide, I turn it into a screening analysis. So these screening classes basically rank the areas by management priority, and the most obvious or striking result is pretty obvious in this first panel. There's no carbon that's considered the most safe category, which is where there's low pressures and lots of protection. Instead, most of the carbon falls in a low pressure zone, but it's unprotected, which means that it's vulnerable. And the rest of the carbon is already facing high pressures. And if there's no protection and a lot of pressures and we're losing these ecosystems, then they're not able to function their best. And none of that is being accounted for right now. So this signals to policymakers that protection needs to happen immediately. And lastly, I'm going to uncover this figure piece by piece. It's essentially the heart of my project where I turn the science into a policy roadmap. So these are the existing tools or frameworks that can bring blue carbon into national governance. First, there's the IPCC wetland supplement, which is the main methodology for accounting for wetlands in greenhouse gas inventories. Some blue carbon is compatible, but some isn't. This is then reported to the UNFCCC, which also has some blue carbon financing mechanisms. At the country level, there's nationally determined contributions, which are flexible climate goals. And then there's UN Sustainable Development Goals, 2 of which apply directly to the oceans. And Norway also has a whole host of national marine and biodiversity policies that are applicable. So secondly, the crucial aspect is that seagrass and macroalgae don't fit into these tools equally. And these tools can basically provide policy entry points, but these are going to differ by ecosystem because the science is so different for these two. So seagrass fits most directly into the IPCC template, and I would argue that it's nearly ready for formal accounting if it can address some of those data gaps and enhance monitoring, whereas macroalgae doesn't fit the standard template for the IPCC. And this means that they would have to develop their own unique methodology as a country, which has only been done in one other country so far recently. So it's a highly novel process. And third, I propose a phased differentiated pathway for implementation. This is my primary finding. Basically, seagrass can start immediately with basic tier 1 accounting and then work its way up to more advanced accounting over time, adding co-benefit policies as you go, whereas macroalgae would have to start at the opposite end where the science is the strongest with biodiversity, adaptation, and other marine regulations, only adding in the carbon accounting as the science matures. And basically the key takeaway is that blue carbon policy needs to encompass the entire carbon, biodiversity, coastal resilience nexus rather than just focusing on the carbon benefits. And that policy needs to be enacted now to protect these ecosystems, but that happens on different timelines. And finally, if you guys would like, you can scan the QR code here and access my public GitHub repository, which contains my interactive map, and it contains all of my data analysis in a reproducible workflow. No pressure if you are not interested. But the whole intention was to give Sea Blues and NEVA something concrete to build on for the next steps of blue carbon policy and science. So I have so many people to thank. But I'd like to start by thanking Richard Bellerby and Mark Merrifield, my advisors, as well as Corey and Jada for their support this entire year. There were so many other scientists and professors at Scripps and at NEVA and at Sea Blues that all helped contribute. Also, big thank you to the Julia Brown Fund for helping me go to Norway and Greece to conduct my findings. And lastly, thank you to my wonderful, beautiful cohort who has supported me and inspired me this entire year. So, thank you.
so much. This was such a wonderful and very, very impressive project. After scanning your QR code and talking to you a bit about your project throughout its development, I noticed that you had a couple of deliverables that you may not have had time to mention in your project. Would you like to speak on any of those?
Yes. So originally, as the Sea Blues project encompasses pretty much all of Europe as well as China, I actually built an interactive map for all of Europe as well. But I didn't include it because it has some data that hasn't been publicly released yet from the Sea Blues project. So once Sea Blues gives me the go-ahead to make it public, I will add it to my GitHub, and that QR code will also have that. So it's not just Norway, it's all of Europe. But yeah, so thank you for that question. Alrighty, thank you guys. Thanks for everyone for coming here and for sticking around all day.
Okay. My name is Mark Merrifield, and I've been helping Corey manage this program for 9 years. And I would say that in that 9 years, I've never been more impressed or more proud of a cohort than this one. Not only all the individual achievements, but collectively, I mean, you can all see it, just the support they give each other. They go at it as a team. It's a model for how we should all be going at the climate challenge, and just really inspiring you guys this year. Behind the scenes, there are a lot of committee chairs and advisors that have put a lot of time into this. I would like to thank them again for all the hard work that's gone into this. Many of them are here today. We know that this group has put in a lot of time and energy that requires a lot of support. And so for all the friends and family that are here behind the scenes also, supporting this group, we're very, very appreciative for letting them join us, for allowing them to join us this year. You can see it here. Thank you, Julia. How do you go to Norway? How do you climb the, how do you go to Ghana? How do you dream, make all these dreams for these capstone projects? You've really just expanded the horizon of the program and giving these students an amazing opportunity. It's been 9 years now, Julia. So thank you. Sitting next to Julia is the former director of Scripps, Charlie Kennel, and his wife, Ellen. And if you want to see what the career of a climate champion really looks like, please Google Charles Kennel. He has an amazing record. The building, the auditorium we're sitting, beautiful auditorium we're sitting in, was designed, planned, fundraised under the leadership of Charles Kennel. So thank you, Charlie. We saw a lot of bar charts today. If we were to put a bar chart, it was who's the most influential person for improving just the experience that these students have had this year in so many ways, just countless. And just to let her know that she's been seen and she's very appreciative, that's Jada Ryan. And lastly, the program has evolved over the years to what it is today. I don't think everyone completely realizes the role that Corey plays. He's teaching, he's managing, he's behind the scenes fighting for all of you. And he takes the time every year. I'm always amazed by that. You could tell by the way he was doing his introductions. He knows these students really well. He's taken the time. He's had countless hours sitting at Pinpoint, just learning what they want to do and trying to help them reach their dreams. And so I think, Corey, just thank you for everything you do for the program. Okay, it's been a long day, so let's raise the roof on Charlie's auditorium here and give one more rousing round of applause for the cohort of 2026.